as for Laboratory Sustainable Award by International Institute of Sustainable Labs in USA. And in 2015, he was awarded for Environmental Improvement Award by S-Lab United Kingdoms. His area of work includes setting up a testing lab to measure priority pollutants at trace levels in air, water, and soil. He has developed microscale and automated methodologies to reduce waste generation, promote green chemistry and engineering. So these are his few of the fields. So we hope, sir, we will be getting more knowledge about the sustainable development and green chemistry from your lecture. Sir, we welcome you for this international conference. So you can start with your lecture. Sir. Sir. Ma'am, I guess I got disconnected.
I think sir is trying to connect, sir. He's there,
okay.
I think. Oh,
fine.
Acha, we have our Sudhakar ready online.
Yeah, he's ready. No.
Okay, okay.
Good morning, madam.
Good morning, sir. Let's see, sir. I think he's trying to connect back to us.
Yes, ma'am. He got connected back.
Okay,
sir,
I'm back.
We welcome you back,
I'm
sir.
back.
Right.
Yeah. Thank you.
Sir,
thank you.
Please, you can start with your lecture, sir. And we hope we'll be getting more information. As teachers, we are looking forward for the green chemistry labs that you can help us to develop in our institution, sir. Welcome, sir.
Thank you. Thank you very much. And Srikanth, and so you need to again let me, get on to my system.
Yes, sir.
So you have to give me an access. Share screen. Okay.
Yes, sir. Share screen.
I have given the access to you, sir. You can share the screen.
Share screen, and I have to go to my desktop, right?
We're able to see your screen, sir.
Okay, just a minute. Okay. Perfect. I am going to, okay. Now I'm a slideshow format, and can you see the entire screen?
Yes, sir. We can see the screen, sir.
Perfect. So to start with, again, I formally would like to thank your entire team, including your principal and conveners and all the presenters and everything. And it looks like so far it has been a successful conference, and I'm being part of it, and I'm very, very happy. So today, with the time I'm given, so I will skip a few slides, but I'll concentrate more on the later part of my talk. These are most of the slides are very informative and self-explanatory, and a copy of that is with Vijayalakshmi Garu. You can always request her. And here my contact information is here. You can always, any one of you can always contact me for the information that you're looking for. Even if I don't know, I'll just research and get back to you. So thank you for that. So today, I think my talk has about split into like a few segments. Green chemistry and its 12 principles, which I'll go through very quickly. And some real world examples, what's happening in green chemistry and how that is affecting our economy. And then teach the teachers. This is where I think you can grab some ideas and develop your own. And a few references on these talk and the chemistry. So your theme is again to the sustainable development. And this sustainability is now a buzzword for the last at least decade. But University of Michigan caught on this sustainability almost like 27 years ago. And we formed an office of campus sustainability, and I was part of it. Sustainability, simply put, it is an ability to continue a defined behavior that is indefinitely to benefit future generations. So each generation to generation, then we have to develop this and then pass on. And typically it has sustainability has 3 pillars: social responsibility and environmental and economic. So I think we belong to, our community belong to the central pillar. And the other 2 you talk about the business and politics and etc. And green chemistry, as you now realize, it is not a definite solution, but it's an ultimate necessity. So that's what I think you'll realize at the end of the talk. The history, I'm not going to go all these landmarks and milestones, but three of them I'll point out. And one is 1997, formally green chemistry has been recognized with 12 principles of green chemistry and by two distinguished scientists, the John Warner and Paul Ernestus. Both of them I have met in person and invited them to our campus. In 2006, our own governor of Michigan has signed a green chemistry executive order. And that led to my appointment to the Green Chemistry Roundtable, where I contributed for about 10 years. The recently, University of Michigan and along with other universities, right now they're introducing a full-fledged degree in green chemistry, which is a very nice thing to share about. What is green chemistry? We all know chemistry is like reaction at atom and molecule level to produce another product, and most of the time we end up with hazardous waste. On the other hand, green chemistry is doing the same chemistry, but the end result is to reduce or eliminate the use or generation of hazardous substances. So there we are contributing in a positive thing to the environment. And this is very important to understand. The green chemistry people started doing green chemistry without what they were doing, and they thought it's a green chemistry. But after we understood what green chemistry is and all the principles, so some independent research companies started doing some research, projecting how this green chemistry, where it goes. So the Pike Research out from Boulder, Colorado, they have predicted what the economy due to this green chemistry was 3 billion in 2011 would swell to almost 100 billion in 2020. But on the other hand, the exact chemistry, it is valued at like 4 trillion in 2011, but there's only 50% growth to 6 trillion. But on the other hand, green chemistry is going much faster pace, although the numbers are low. And these are all the drivers. And then go to the next slide. Another independent agency called Statista. It's a German company. And they have done a wonderful job in predicting and capturing the green chemistry economy in 2015 with $50 billion. And they projected to go to 86 billion in 2020. So it should be a little bit more now. And now recently, last month, another report, independent report came, Vantage, but their research was a little bit, different in the sense they only projected about the green chemicals, but not the entire green economy. So what I did is they projected about 16.6 or 17 billion, which I put a factor of 10 to get into the economy. So there's going to be almost like 166 billions, in a very, very short period of time in 2028. That's about another 6 years. So this is what is going on as far as the economy is concerned. So that means there's something special about green chemistry. So we need to all adopt, understand, and apply so that we produce a green chemist of tomorrow. That's our main goal. And then we also see the publications of green chemistry. As you see, the number of it says years, but this number of papers. This is 70 times 1,000, so that is about 70,000. 70,000 to in the year 2022. It came all the way in 2019, and with this COVID, these numbers are coming down a little bit. But as you see, in the last, 20 years, it was so meager, the green chemistry papers. Right now, they're increasing. They are they're taking a place in almost all journals. And again, there are some dedicated journals for green chemistry, which I'll share with you in a minute. These are the green chemistry principles. And I'll go through this very quickly. And these are some videos you can go through. And principle number one, it's a triangle. It's a triangle back in the past. It used to be like source reduction on the top and the disposal was at the bottom. But right now, in the present day, it's the pyramid has been reversed, and where source reduction comes first. So that's where we call reduce at the source. If not, you can reuse, recycle, then treat if possible. Then if nothing happens, go for disposal. That's the last option. So I caught this slide from Heterodrugs, which is now one of the top companies in Hyderabad. And they came up with a sustainability report to highlight the R3, that is reduce, reuse, and recycle in their report. So one can go through this and see how people are taking, how serious people are taking on this green chemistry related objectives. So principle number one, again, it's waste reduction. And I have just taken one example here, which will again show a lot of toxic solvents have been eliminated. And then again, hazardous materials are removed in this particular Zoloft by Pfizer. It won the Presidential Green Chemistry Award. Then atom economy, as you all know, you design a reaction to end with your product with the maximum benefit of using all the atoms possible. And in basic chemistry, everybody knows Diels order. So it's a diene and a diene. And end product is completely used up, and then the atom economy is 100% there. But here I've given a couple examples. You can just go through that later. And then use less hazardous chemicals in the products. And this EPA came up with this program, and there are a lot of products now being developed every year. And principle number 4 is again design for safer chemicals, and which is a very nice example I gave here. And this is a conventional method versus a green method, like coming up with the vitamin B2. And then there are one more thing I want to point out here is in our teaching labs, the mercury and its salts are completely removed because they were ending up in our hazardous waste, and disposing that hazardous waste was getting very, very expensive. So we just removed. And then number 5 is again use safer solvents. Then this is a list of solvents they came up with at the pharmaceutical industry roundtable a few years ago. Right now, it's kind of a golden rule. And then design for energy efficiency is another principle. So you all know that like using alternative methods opposing to this heating method, you can always come up with the energy efficiency, and then you can have the reactions done at low energy. And then use of renewable feedstock is now coming up very fast, because this is again comes from the environment, goes back to environment. So that is a very cute thing about it. Polypropylene now is being produced from sugarcane, and this industry now is coming up at a revolutionary level. Again, this is again to produce plastic. As a matter of fact, plastic is going to disappear in next few decades. That's what I'm thinking. So, and again, synthetic adipic acid also same way. So right now, conventional method from benzene is outdated. So they are now using from glucose using biotech methods. And always reduce your derivatives because derivatives take multi-step, adding and removing the protective groups. So where you're using a lot of materials, so that can be avoided where possible. And then catalysis, we all know catalysis is known for centuries, and where you not only get a good economy, but at the same time the energy used is less, and it can be repeated. The catalyst, whatever you're using, can be reused again. And the design for the degradation is one of the things now industries are looking at it. This is a simple, a product that we use in our daily life. When we used a branched, derivative in this opposing to the straight chain, because they found that sodium dodecyl sulfonate is now being used with a straight chain so that it will go into environment with a degradation in few days, opposing to its branched one. So this is how I think the design for degradation is now catching up the movement. Then real-time analysis for pollution prevention. This is we all know as synthetic chemists, and you're doing other chemistry. Then use and design safer chemistry so that you can work in the lab under safer conditions. This is entirely a different arena, which I have given presentations how to build a safe lab so that we can produce safe and safer chemistry, and you can go home with safety. So now let us look at some real world examples. These will connect to the green chemistry, then again to the directly to the economy. So with the COVID, we all know there are now multiple companies across the globe doing the same thing, the vaccine. But Pfizer was the first company to produce the vaccine in United States, and in where I lived, Pfizer did his business in Ann Arbor until 2005, and that entire property, physical property, has been now bought by University of Michigan and converting to the research labs. So here, biochemist can understand in a minute, but as a chemist, I would like to focus you to this messenger RNA, because that is nothing but a spike protein. So that is being sent to the cell. And then the messenger RNA, what it does is it will do its job, and so that spike protein is being produced here on a cell, or normal cell. When actual virus come with the spike protein, and the immune system will kick in, and then you see the rest of it. So will be the lives are being saved. So that's the beauty of it. So here is a nano chemistry, or a green chemistry is embedding the messenger RNA in a lipid nanoparticle is a green chemistry here. Then plasticware now is replaced by PLA, that is a polylactic acid. You know the life cycle of it, and it comes from Mother Earth and then go back to the Mother Earth. So which is very nice, and this is catching up real fast. So the first the usable plastic cup was produced in the United States about 13 years ago. Right now, it's slowly entering into restaurants and other places. And with a small modification now, this can be used for hot beverages and also slightly acidic or basic beverages. And this can be easily degraded back to water and carbon dioxide. And this slide just came to me this morning. This is a group like in Michigan, Detroit, Michigan. So what they are working on is, it's R&D level. They are talking about fractionated distilled corn oil, and which they will be producing with a lot of functionalities to produce them into greener polymers. And these green polymers, they have wide variety of applications in the industry. All the green products like adhesives, sealants, coatings, additives. And this is what is going on, and this is an opportunity for anybody to get in touch with this group, and then work in collaboration, and then like come up with these products. These are products of tomorrow. That's all I can tell you at the moment. The same group again, using the soya bean oil, and then pulverized like a rubber from used tires, which is a huge waste. And at a proprietary level, they are now coming up with a lot of products, secondary products, which are used in auto industry and some other places. So this is also, it's a nascent opportunity for a collaboration. And then here it is the biodiesel byproduct is the glycerol. So when the biodiesel is being produced in USA, the glycerol was a headache because it was a byproduct. So then the chemists started converting into propylene glycol with a simple couple steps with the using catalysis, and that is a polypropylene glycol is now an ingredient for the silk products. The Sorona is one of the companies dominating in this field. And then also this same propylene diol or propylene glycol is again a starting material for smart carpets, green carpets. Although they're a little bit expensive, people seem to prefer that. And then again, bioplastics. This is again a slide I caught from during my trip back in India. This is a company came up with in Nizamabad, and this government has some subsidies to this company, and they produced a plastic that is biodegradable according to the pollution board of Hyderabad. It goes back to Mother Earth in 30 days to 180 days, depending upon what they have used. And I suspect polylactic acid is one of the ingredients along with their proprietary materials. So the need of the hour is at the moment to get into, come up with this kind of products by this kind of companies, not only in India, but across the globe. And most importantly, governments should think, because in the United States, there's a little bit, what should I say, a glitch. Companies are coming up with products, but the plastic companies, they lobby at a really high level with the government, and they are pushing this back a little bit. But sooner than later, I think citizens will prefer, and a lot of businesses stopped using plastic in United States as well. So, but there's again, it's a voluntary and behavioral change. So like I said, the green products, clean products, this is a program designed by US EPA, and a lot of small companies participate, and they come up with zillions of products. This is a few I just put it here. These are all glass cleaning and grease cleaning and surface cleaning products, which they are completely devoid of ammonia. Otherwise, back in the day, all these cleaning products used to have ammonia, and ammonia, again, it's difficult to, when it goes to environment, it's difficult to degrade. And this another example is ozone laundry. This is again a future technology here, which is nascent now. When this comes into picture, when this is available to common man, I think the place we live is going to look much cleaner. So here they took advantage of the ozone, which has an half-life of 30 minutes. So when ozone, it dissociates, it kills the bacteria and viruses instantly. So this ozone laundry, right now there are some companies are now coming up with a commercial units, and it uses 80% less natural gas and 50% less energy savings, and then the chemicals used will be reduced by almost like 75%. So which is very nice. And this holds a very good promise. Right now it's going through some baby steps, and sooner than later, I think it will catch up globally. Then again, we all know greening the kitchen. It started with polylactic acid. Again, they are using all wood, the plant materials in a different way to come up with these products. After single use or multiple uses, it goes back to Mother Nature. So now the third part of my presentation is this is a little bit. I want to spend a little bit more time on this. This is the teach the teachers. So this is where you want to catch a little bit ideas of your own and building your own, and then benefit in your teaching methods and also to the students. So as you know, today's students are this building blocks of, and again, inventors of tomorrow. So one of these, each of these, if you go back, will use one or more of these green chemistry principles. Here, the source reduction is the key thing. That is waste minimization, pollution prevention. All this they will they club together to this initiative. I simply put in the left side. This is a melting point apparatus, and which even conventionally people they use in undergrad labs to train to determination of melting point. And back in the day when we were in the college, our lab demonstrator used to put an entire bottle of benzoic acid there for us to get trained. And at the end of the class, the whole glass used to disappear and then end up in trash. But right now, we can, keeping that in a source reduction in mind, the entire lab can be trained on this technique with, here I put 50 grams, 100 grams, but for the conventional one, but you can do in about few milligrams actually. So you can be that smart. So students will learn, but you don't dispose anything as we used to do in the past. And this again a micro technique. The micro technique has been developed in our on our campus to teach the undergrad students. As you see, all these reactions we use in the undergrad level, oxidations, reductions, substitutions, and all these things. In conventional way, each student we spend about close to $10, and also the large amounts. And that in micro teaching, while using micro apparatus, so we have reduced the cost almost to 90%. At the same time, the hazardous waste also was reduced by 90%. So the faculty, you can take this as a challenge, and then you can design, and these kits are available, or you can if there is a glass blower, you can just make your own. So this is one of the good initiatives one can embark on. And then again, waste minimization, utilities conservation, especially water. I know historically the man fought over land. Right now, man is fighting over water, and in future, the man is also going to fight over the air. So I hope we don't live up to that extent. But what I'm trying to say here is, in lab, lots of water is being used, and that waste, that water goes into the sewer, and again it's recycled. Recycling is again an expensive process. So research showed, in fact, we measured on our campus, single pass water usage using this condenser in a research lab uses average 230 gallons of water per year, and this is one single condenser. So you're talking about multiple condensers, multiple labs, multiple buildings, and our campus has about 80,000 population, and the millions of square footage of lab space, and many of these condensers. So this can be reduced, and we started an initiative through Sustainable Lab Program. We replaced this with a recirculating chiller, which I think I bought this for about $3,000 or $4,000, but right now this cost came down very much. And this is again one like an outlet will go to inlet of condenser, and then again this outlet will go to inlet of this condenser. So the recirculating liquid, that is a glycol, ethylene glycol solution in water, and that is the medium. And it can go to about -5 degrees to almost like 20 degrees without any problem. So this is where I think we want our reactions, I mean like our solvent to be recycled at this temperature. So this is a very cool thing. And another one is called Findenser. This is designed by Hidolf in German company. And they have proprietary material here, and there's nothing used, no circulating water here. And the solvent is being refluxed, then again sent it back. But the only limitation is here, you can use solvents up to the boiling point of 120 degrees, I think. Beyond that, I think you're going to lose the solvent. And then the energy and utilities conservation in the labs can be accomplished. Again, reflex condenser using water and heat to do a reaction. The same reaction can be done by microwave synthesizer. Right now, there are CEM Corporation is the product is displayed here, but there are several companies now making. I understand there is a company in Bombay also is making one. So again, you look at it. Look at here, undergrad teaching lab. We are consuming almost like 2,400 liters of water consumed in about 30-minute experiment. Just one experiment. So that was replaced by this unit. It's a simple microwave designed, and the technology is same, engineering is same, what we use in our kitchen, but this is kind of produced more like to apply in the lab setup. So with all controls and gadgets. So this is now being used on our campus to benefit in some teaching labs. So another teaching lab experiments using this microwave digester, as you see here, Deal solder and some condensations and bromination. Bromination is the one I really, really love it. This is so nice. There is no red-looking bromine vapors in the lab. They simply use a sodium bromide, and you can see the kids at that age, they love this reaction because you can see within the reaction vessel, the sodium bromide generating atomic bromine and molecular bromine, and then again bromine disappearing, reacting into reactants, and then you get your bromination product separated and purified very easily. And aromatic substitution, hydrolysis, all these things can be now done in our machine. Thereby not only teaching good chemistry, but ending up with less and lesser waste. And this is a very popular undergrad chemistry experiment. Now this is I would say this is a very green technique. This is a banana ester synthesis simple, here the acid is catalysis using, and then acetic acid, and then it's we'll just get a very nice acetate, and the whole lab is looks like a banana at the end of our experiment, and the kids love it. And this is a little bit challenging. We all know that metals are being measured by atomic absorption spectroscopy, or ICP-MS or ICP, inductively coupled plasma spectrophotometer. But for the sample prep is the ugly step here. So the fuming nitric acid, we need fuming nitric acid, and that is almost 70% plus. And we have to cook this almost like 2 to 3 hours, and your entire chemical fume would looks like red like this. And it's a messy, whether it's a teaching lab or research lab or anywhere you're doing. So this what we did is we completely converted this into a green method. So what we do is we take only 20% of nitric acid, which is nothing. And so you can also take a little stronger acid if you want digestion to be completed. So you do that in microwave digestion under closed conditions, and it takes about 20 minutes versus a couple hours. So which is again produces lesser hazardous waste here, and again teaching the right chemistry and in the right way, right manner. And recommended green solvents is again, this is a product of pharmaceutical roundtable committee, and also this was again like researched by several companies. Here I've taken Pfizer, Smith & Kline, Glasgow Smith & Kline, and again this Sanofi French company. You can see all these solvents they have researched and then they have presented here. Preferred, usable, and undesirable. Well, as a chemist, you have to use sometimes undesirable solvents as well, but where possible, try to use a green solvent. And there are many green solvents available now. And this is, there are so many examples in the literature now. I just got this just to show you. And to get this like a heterocyclic product, they've done research and comparison in solvent in DMSO, DMF, and then water and dioxin. As you see, simply put the water, when they used as solvent, they got a very good result. And it's a true green reaction. And this is again, I would like to present this to you, to the teachers, is the Presidential Green Chemistry Challenge Award. I think it was introduced in 90s, early 90s, yeah, mid 90s by President Clinton. And this was the sparkling like a step to the green chemistry. And since then, every year, this event typically takes place in Washington, D.C., in a government building, which I attended a few of them. And every year, 5 to 6 awards are being given to the best researcher, best teacher, best product, and best company, and a small company, medium company, big company. So I just brought a couple examples here. In 2020, Genomatica, California-based, was recognized for producing a 1,3-butylene glycol from sugars using biotechnic methods over conventional methods. It is coming from fossil fuels. Fossil fuels, we as a chemist, you can do it, but you don't want it. So this is primarily used in cosmetics to retain moisture. So there's a $1 billion, like a market. And another example I just put it here is Pfizer won the award for this Zoloft. This is again a antidepressant, and which is again widely used. And this again they just did away with the conventional method and again transformed into green method. So thereby they like saved not only time but steps, through steps, and they have reduced the hazardous materials from generating and disposing of. So you can, as a teacher, right now I'm talking about 1995 to today. So that's 25 years. 25 years times about 5. So you're talking about 100 to 150 awards, and each award has a chemistry there. And this you can take as an assignment to your students, and also to the selectively you can choose like as a quiz to the student teams, wealth of information on green chemistry, because there's nothing but green chemistry. And the United States government has invested heavily on from this angle. And right now, major companies did not respond for some time, but after a few years, turn of the century, then when Pfizer got this award in 2002, then a lot of big companies started investing. And again, like I said, now they are coming up with a sustainability report every single year, and they highlight what they have been doing to address green chemistry. Now they call sustainable chemistry, what they're doing and how they're reducing, how they're helping the environment, what kind of energy they are using. They are not using any conventional energy. They are using renewable energy like wind energy, like solar energy. So all these things are now being plugged into the annual report of many companies. And this is again antidepressant, the award winner in 2002 by Pfizer. As you see here, these are the chemicals: titanium chloride, toluene, and like methylamine, hexane, THF. All these are being completely eliminated with just methylamine. And then with a simple catalysis, then they came up with the end product. So this is saved cost, time, and improved the yield. So this is a true green chemistry example. And then again, the Pfizer also won another award from this presidential green chemistry for their ibuprofen green route. Towards left, as you see, so many steps, and again some protective groups and releasing and so on and so forth. On the right hand side, they've simply used a few steps, including simple hydrogenation and palladium as a catalyst. So this scheme won the presidential award. So one can study this in your classroom. And green analytical chemistry, this happened in my own lab. We were measuring PCBs, that is a polychlorinated biphenyls, using a conventional method that is again approved by it's called a TO4, that is a toxic organics number 4 method, EPA method. And what it takes is taking 350 ml of hexane and then extract this using succinylate extractor for about overnight. And then after that, you remove the solvent, and hazardous waste generated for each sample is 500 ml. So this was happening. So we were giving the results to the end user in about a couple of days, because it takes so much time to extract and so on and so forth. So what we did is, in our lab, we invested in this small unit. This is Dynix. They produced it. We are one of the early users of this. It is called ASE. There's Accelerated Solvent Extractor. The number is 200. They named, but after that, so many other models came up. What we did is, each of these has a small tube. So we packed this. It's called polyurethane medium, where we collect these PCBs from air, and we packed into this tube, and we used 30 ml solvent, and extraction time is 5 ml, and hazardous waste generated is now completely 500 to 50 ml. So this company Dynix, based on our method, they produced an application method, and not only that, they also modified this unit. So being our public institution, this is all, we cannot hold any profit-oriented things. So this all we just gave away, and this is a reference. You can read in detail. So how we reduced this. So this is I would say this is a classical green analytical chemistry example in my own lab. And these are some reference materials. There are so many organizations now, and Green Chemistry Institute is one of the best. I recommend. So right now they come up with a newsletter, wealth of information on green chemistry. And then Royal Society of Chemistry, UK, and then Beyond Benign in USA, it's in Boston. And Yes Lab is in UK. That's where I gave an invited talk there. And Clean Production Action, again, USA, Michigan Green Chemistry Clearinghouse. And this was again funded by the Michigan government, state government. And International Institute for Sustainable Lab, again, USA. Green Chemistries Foundation, India, this is from Mumbai, and Green Chemistry, United States, United Nations Industrial Development Organization. There's so many. And if you can break into one of these, you can become member, and you can learn a lot, and you can not only learn, but you can teach. And now dedicated journals are Green Chemistry used to be alone, but after that Journal of Chemical Education came by, and then Trends in Green Chemistry Letters, just like tetrahedral letters. So a lot is going on now. So now even I have seen some green chemistry papers in Journal of Organic Chemistry, in some other journals occasionally, and even tetrahedral letters I have seen. So right now green chemistry books, there are plenty. So including the first theory and practice of green chemistry by John Warner and Paul Ernestus. Paul Ernestus was called to White House to advise to the president for one term, to Obama. And then again he went back to his assignment. And then again Google has many books you can just buy. Make sure that you buy, your library has, and as a reference material. So conferences on green chemistry. Look out conferences, participate, present, interact, and collaborate. And ACS holds two major conferences every year. But in addition to that, ACS Green Chemistry is holding an annual conference on green chemistry and engineering. And the Royal Society of Chemistry is also holding regular conferences. International Institute of Sustainable Lab also is hosting an annual conference. And there are many others. So if you get into one journal, then you know what, it opens up your scope of understanding what's going on in the world. And these are some of many books, very popular ones. And particularly this Indu, she wrote this green chemistry textbook quite a few years ago. This is very nice. She just retired, I think, from University of Delhi. And there are many others from India as well. So please invest your time. And this is again James Hutchinson is one of the pioneers. He's from the West, actually. I met him a couple times. So he also completely transformed his teaching methods on his campus using green chemistry. And then again, what are the drivers for this green chemistry? Because now, like yesterday, you've heard our keynote speaker, Dr. Mehta. So much worrisome. So the globe is now going somewhere where we don't have control, and by the time we take control, the damage is going to happen beyond beyond fixing in many cases. Ozone is only one example, and plastic is another one. So right now the plastic need to be completely should be removed, because our water bodies are being disturbed, not only drinking water, but also the sea water. So there's so much is going on. So I just went on a cruise, and I have seen some areas inside several thousands of miles away in ocean, plastic is floating. So who is responsible? Us. So that has to be eliminated, removed, improved.
Sorry to interrupt you, sir. We can close it by a minute, like we are running short of time.
Yes, I am almost done. This is my last slide. So these are all the drivers of the world economy to the green chemistry. So please digest. And again, I will tell you, dream, whether you're a student, faculty, or staff. So dreaming, leads to aim high, and one day, you solve a problem that we're facing today. Thank you very much.
Thank you so much, sir. Thank you so much, sir, for your informative talk on green chemistry leading to sustainable development. into the learning and teaching methods. You explained us all the principles of green chemistry with real-time examples, and few examples like PLA cups and automatic industry, how they are using textile industries, ozone laundry, which was a very good example, sir. And also you have taught us how teachers can use green chemistry principles to reduce chemical waste and having a greener experiments in our lab. So we thank you very much, sir, for your informative talk, and we look forward for your cooperation in future also, sir. We'll look forward for more talks from you to our students also, sir. Thank you so much, sir.
Thank you very much. Like I said, now due to lack of time, anybody can contact me through my WhatsApp or email, and I'll get back to you. Thank you.
Thank you so much, sir. Ma'am, over to you, ma'am.
So you cut me off. So
Actually, I'm not the host here, sir. Vijayalakshmi ma'am or Annapurna ma'am, are you there?
Okay. All right.
Dilima ma'am, you can.
Yes, I will. Right. It's my honor to introduce the second invited speaker of the day, Dr. A. Balasubramaniam sir. He is an analytical biochemist working as a research associate professor in the University of Cincinnati. He is an active scientist. His area of interest is mass spectra based characterization and structural determination of protein and nucleic acids. He did his postdoc in the University of Kentucky with Professor Arthur Hunt in the field of RNA processing endonuclease. He has more than 35 peer-reviewed publications, several projects in his credit, and 4 patents and faculty development programs also. He presented several oral and invited lectures over the globe, and he is currently affiliated to American Society Mass Spectrometer and American Chemical Society, and also he is a member of American Association of Advancement of Science. He taught several courses for undergraduate students for exclusively biochemistry. Overall, he is a good educator, researcher, and is a science enthusiast. With this information about sir, I would like to take the opportunity to invite him to present the lecture. Thank you, sir.
Thank you, ma'am. Thank you, Dr.
I'll take a minute here, sir. Sir,
Yeah,
Balasubramaniam, sir, I'll take a minute here.
Sure.
Actually, I was also in another parallel technical session, so I could not welcome you properly. Sir, on behalf of Department of Chemistry, University College for Women, and as the convener, sir, a very hearty welcome, sir, to you to the conference. I'm so happy that you are here and you will be sharing your information, and we are very, very fortunate to have you, sir. I'll also take the opportunity here to thank Sudhakar, sir, our earlier speaker, for his excellent lecture. Over to you, sir, please.
All right, thank you. Thank you, Dr. Vijayalakshmi and the team for the invitation and the opportunity to present our research, what we are doing in Department of Chemistry at University of Cincinnati. So today I'm going to talk about detection of post-translational modifications in proteins. We do bioanalytical chemistry. I was not very sure how it would fit into the theme of your conference, but then Dr. Vijayalakshmi was persistent. Of course, it's related to the health, so that's why sustenance is important part of any living organism. So I thought, okay, let me make a presentation on what we are doing. So these are the things we do. So we look at post-transcriptional modifications in RNA. So our goal is to look at the significance of modifications, chemical modifications in RNA and proteins. So we look at what are the various types of modifications that are present and then their location in the sequence. We deal with a number of RNA samples, of course, sample preparation and LCMS method development are the key parts of our research. And then we're also interested in post-translational modifications in proteins. So they're part of the additional changes that you see in proteins, like disulfide bond formation, isoaspartate modifications, and persistent organic pollutant attacks. So today I'm going to talk about detection of disulfide bonds and isoaspartate modifications. POP detection is still ongoing. Maybe we could make a presentation later on. So I thought I will talk about mass spectrometry in brief, so that people who are not familiar with this technique or the approach can have some idea. And then liquid chromatography coupled with mass spectrometry, what we call hyphenated techniques, where the power of mass spectrometry is enhanced further when you are dealing with complex mixtures. And then finally, we'll look at a few examples where we detect the post-translational modifications in proteins like disulfide linkages or xenobiotic modifications like isoaspartate modifications in proteins that are resultant of thermal insult or heat exposure. Right. So when you look at mass spectrometry, it's nothing but a sophisticated balance or a scale where we are measuring the mass of molecules in the form of ions. So we are looking at the mass of the molecules, and when you are dealing with unknown compounds, so by measuring the molecular weight, you could identify them, you could quantify them. And if you are dealing with some impurities, or if you're dealing with some active ingredient, you could identify impurities present or co-purifying along with the active ingredient. And then you could determine the structure and chemical properties of the compound, so you are interested in. And then you also do the isotopic ratios if you are using stable isotope labeling in your compounds, and then you are monitoring their flow in the system. So just in brief, mass spectrometry measures the mass to charge ratio of gas phase ions. So that means it cannot work with neutrals, right? So only the charged molecules can be subjected to electrical and magnetic fields, and then the mass analyzer analyzes their motion so that you could compute the mass to charge ratios. So the output of the MS analysis is basically a plot between the signal intensity, which is represented as a relative abundance, and the mass to charge ratio. So M is the mass and G is the charge number. So if you have a neutral mass of 1000 Daltons with 2 positive charges, you would see the signal at around 501, depending on the mass accuracy. So sometimes you also get a high resolution mass spectrum, depending on the mass spectrometer you use. And if you have a high resolution mass spectrum, you could determine the charge state by looking at the isotopic peaks of the molecular ion. So these are the isotopic peaks of the molecular ion. So in general, any mass spectrometer has 3 components. One is ionization source, where you introduce the sample into the gas phase, and then the ion separator or mass analyzer, which would sort the ions based on their mass and the charge. And then finally, the ion detector, where the electric current generated by the detector after reaching the ions would be amplified and then processed to get the mass spectrum. Now, if you look at the ionization source, there are a lot of different types. These are all high energy, ionization sources, whereas this one, matrix assisted laser desorption or the electrospray ionization, these are less energetic ionization where you could preserve the structure of the labile compound, right? And then if you're looking at mass analyzers, you could use either magnetic field or electric field or a combination of both to sort the ions and then get that structure. Right. So now, if you look at the ionization capacities of the or ionization process of the labile compounds, people use either matrix-assisted laser absorption, association, dissociation, where the sample is mixed with a matrix which absorbs laser energy and then transfers energy to the molecule, and then the molecule gets introduced into the gas phase and then would be introduced into the mass spectrometer. So here you could preserve the structure because the laser energy is absorbed in the matrix, not directly by the compounds. Now, if you are using liquid chromatography as a front-end separation, you could resolve the molecules on a column, and then the chromatographic eluent is introduced into the ionization source, where the solvent is evaporated by drying gases like nitrogen, and the ions are introduced into the mass spectrometer because you produce charged droplets here as we apply electric field, or you spray the eluent in the high electric field. Now, you have a variety of mass analyzers. So that's why mass spectrometry is never boring because you have so much to learn. You have time of flight mass analyzer where the ions are accelerated and they're to certain and then they're allowed to drift in the flight tube and then finally reach the detector. So the time taken to reach the detector is measured and then computed to get them MOHG values. So you may have two TOFs with a collision cell where you could fragment the molecular ions and get the fragment ions. So if you are interested in getting the structure or the sequence of a labile compound like a protein or nucleic acid, you use the collision cell and two-stage MS analysis, what we call MS-MS or tandem mass spectrometry. And then you have quadruple mass analyzer, what they call triple quad, which is mostly used for quantification, where you're dealing with known compounds, where each quadruple is basically 4 hyperbolic rods, and then you use variable electric field to stabilize the movement of ions while it is reaching the detector. So you could use the second quadruple as a collision cell, and then the fragment ions that are formed from the molecular ion can be sorted in the quadruple 3 to get the MOHG values. And you may have a hybrid mass spectrometers where you could use quadruple as well as time of flight, or you could have ion trap where you could store the ions and then you could do multi-stage MS analysis, right? And then you also could use the magnetic field as well as electric field to trap the ions and sort the ions based on their resonant frequencies and compute the MOHG values. Now, these are the latest mass spectrometers that are coming into the market or have come in the market. Say, for example, Thermo Fisher Orbitrap Fusion Lumos, which uses Orbitrap mass analyzer, which has a spindle-shaped electrode, and the ions rotate around this electrode, and then another electrode will measure the oscillation frequencies and then compute the MOHG values. So the advantage of these mass spectrometer is that you have high resolution, about 500,000, and then high mass accuracy. So the mass error is pretty low. And then you could do multi-stage fragmentation and more than one type of fragmentation, like high energy collision dissociation at the C trap and the normal collision induced dissociation at the ion trap, and then faster cycling time. So that means you could get multiple spectra in a span of milliseconds. So in fact, you get about 45 spectra per second, including MS analysis by this instrument. So there is another instrument from Waters, which basically resolves the molecules based not only based on the size, but also based on the shape through what they call ion mobility separation, right? So as you see here, so as you subject the ions to ion mobility separations multiple times, what they call pass. So you improve the resolution and you could resolve even the isobaric species which have the same mass, but they differ in shape. So that's how you could resolve them. And of course, there are also high mass accuracy instruments because of the hybrid mass analyzers. So now, when you are overwhelmed with so many different types of mass spectrometers, naturally you want to know which mass spectrometer is suitable for your analysis. So and you want to apply these criteria. So what kind of resolution you want for your analysis, and you want to look at the shape differences, or are you dealing with any isobaric species, or what kind of accuracy you want. So accuracy is basically the measured M/G value, which is closer to the true value, right? So we'll see why the mass accuracy is important in a moment. And then what's the mass range you are trying to measure? So are you looking at biological molecules which are larger? Are you looking at small molecules? And then how many analyses you want to conduct, or what's the scan speed, right? How fast the instrument is able to conduct the analysis, right? And then do you need a lot of fragmentation techniques in order to get the structural information or the sequence information? So all these criteria will determine the type of mass spectrometer you choose, right? So now the question is why mass accuracy is critical, right? So here is an example. You have this M/G value, and if your mass error is pretty high, so 100 ppm parts per million, or in terms of Dalton, it is 0.066, then you have very high number of possibilities, possible ions, right? But as you decrease the mass error, right, the number of possibilities also decrease, and you get a unique elemental composition within the given range. So high mass accuracy means unique elemental composition and high confidence while assigning specific signal to the compound, right? So that's why mass spectrometry is a powerful technique which is used for untargeted or targeted analysis with high sensitivity or selectivity, so which is critical for clinical analysis and biomarker discovery. So if you're doing, making discoveries or trying to associate some developments to the disease state, yeah, mass spec is the best way to do that. And then pharmacokinetics, drug metabolism studies, environmental testing, food testing, so on and so forth. And or even biopharma and biopharma testing, where you want to have very rigorous testing of the components and the output. All right. So now I would like to switch gears and talk about the front-end technique, liquid chromatography, and why mass spectrometry in combination with chromatography, liquid chromatography, is a powerful approach. So first thing is first, so liquid chromatography help in separation and characterization, and you could do the structural analysis, you could do trace quantitation of small molecules, proteins, peptides, nucleic acids, polymers, so on and so forth. So basically, the front-end separation, liquid chromatography separates the mixtures of multiple components, and then you could establish the molecular identity of the individual component. So it multiplies the power of mass spectrometry. and it is highly suitable for analysis of heat labile compounds. So it would open the library of nature, open the door to the library of nature's complexity. Although it's powerful, but you still have to, consider some questions whether LCMS is a right approach or technique for your analysis, because it's complex and then it needs sophisticated instrumentation. So the thing you want to ask is, do you need a lot of information? Is your sample complex, right? Is your sample contains polar, ionic, or high molecular weight species? So if the answer is yes, yeah, you could go for LCMS. Otherwise, you could use other techniques without requiring the mass spec, or you could even use the GCMS where you are not dealing with polar molecules. All right, so that's in brief about mass spec and LCMS, and now I'd like to give some examples of detection of post-translational modifications in proteins, starting with native modifications, which are disulfide linkages. So they are made sometimes within the cell or sometimes outside the cell, right, because of the oxidative environment. So here is an example. There's a situation. So there is a protein called Arabidopsis thaliana cleavage and polyadenylation specificity factor. Now this factor has RNA binding activity as well as ribonuclease activity, right? But the RNA binding activity is not affected by the reducing agents like DTT, dithiotritol, or glutathione, or dithionitobenzene, or so on and so forth. But the ribonuclease activity is adversely affected by the dithiotritol. So indicating that there could be a disulfide bond which is cleaved by the DTT, and probably it's responsible for ribonuclease activity, right? So we wanted to get molecular evidence for that. So we looked at the amino acid sequence of the protein, and we see a number of cysteines in the sequence. So that means any of these cysteines could be associated with the disulfide bond formation. And this protein has what they call CCCH motifs, or C3H motif. There are 3 such motifs in the sequence, right? So in the previous studies, we showed that if you mutate these residues, cysteine and arginine, then it would, the protein loses the ribonuclease activity. So we use both the proteins to investigate where is the disulfide bond, right? Are there any multiple positions or at one position? So whenever you're doing peptide analysis, first you want to know what are the peptide pattern of a protein, right? So you use a software called Prospector or any other software, and you get theoretical digestion products, right? And then see what are the peptides that contain cysteine. So it will give an idea.
One second, sir.
Sure.
Shiloh, can you please mute yourself, Shiloh?
All right. Yep. Thank you.
Continue, sir.
Yeah, no problem. So you have, you get a list of peptides that could have cysteines and their molecular weights, right? So for example, in this case, this is the peptide coming from one of the motifs. And if the cysteines are free, so free sulfhydryl groups, then you have this molecular weight, right? But if it is treated with alkylating agents called iodoacetamide, then what will happen is it would add an additional molecular weight. right? So because you are adding an alkylating group. So if it is in the disulfide bond formation, this one is shorter by 2 Daltons or 2 units. But if it is reduced, then it is higher by 2 Daltons or 2 units, and but you are alkylating, you get a higher molecular weight. So so that is represented here. So basically this in silico digestion, what we call, gives some guidance on what we are looking for, right? So what we did was initially we basically developed or designed the experimental scheme to detect the disulfide bond. So we know that dithiotritol reduces the disulfide bond to sulfhydryl groups. So if we have a situation where dithiotritol is used, then and then followed by the iodoacetamide, it will cleave the disulfide bonds, it would add the alkylating agents, and then you could do the trypsin digest. So that's the enzyme that cleaves the protein at lysine and arginine residues, and you could do the mass spectrometry. On the other hand, if you omit the DEPT, right? So the cysteines that are involved in the disulfide bond are not available for alkylation, right? So in that case, you would not see the additional mass attached to those peptides, right? So this is the way we thought you could look at the altered mass shifts of the cysteine containing peptides to see whether they are involved in disulfide bond formation or not, right? So initially we did the multi-MS analysis where we used the single linear TOF mass spectrometer, and we observed a peptide ion at 1176 when DEPT was omitted, right? But when the DEPT was included and then treated with iodoacetamide, we saw 1292, which is basically two alkylating groups addition to the peptide. Whereas here we saw 1176, which is 2 Dalton less than the predicted molecular weight of the peptide, where cysteines have 3 sulfhydryl groups. What about the mutant protein? Now, mutant protein did not show any peptide ions for 1176 or even 1292 after DEPT, but they exhibited identical profile with 1483 that corresponds to the altered sequence, right? Indicating that this peptide has a double disulfide bond, and upon DEPT treatment, it is cleaved and getting alkylated. Now, as I said earlier, there are multiple cysteines in the sequence, so we could not get clear signals for those peptides. So that's why we went for LC-MS analysis, where we use the X-bridge column and then formic acid acetonitrile-based mobile phases and the gradient chromatography to separate the peptides and subject it to the mass spectrometry using FTICR mass spectrometer. So now, before going further into the sequencing and then identification of the peptides, I would like to show how the peptides are fragmented through collision-induced dissociation in the MS-MS analysis, right? So you have 3 channels for fragmentation, so on the peptide backbone. But what happens is during CID, one channel of fragmentation is preferred. So you get a series of B and Y fragment ions. So B fragment ions will have N-terminal end, and Y fragment ions have C-terminal end. So you get a ladder of fragment ions where 2 fragment ions differ by just 1 amino acid. So by looking at the MOG values of the fragment ions, you could compute the sequence, right? And there is another type of fragmentation called electron transfer dissociation, which would lead to the C and Z fragment ions. So we'll see that in a little while from now. So
We go to the next
first,
one, madam.
first we looked at the peptides that are observed in the MALDI-MS analysis. So we reproduced them in
I
the
was actually
LC-MS
looking at that
analysis. So
reaction,
indicating
enzymatic
that
reaction.
what we
I
are
thought,
seeing in the MALDI-MS
I
is
thought I'll ask, but
consistent.
then, okay, ma'am, it's over now. I just wanted to ask her regarding the mechanism.
But then if you look at the peptides from other CCCH motifs, they're all alkylated under no DTT conditions, indicating that these peptides, CCCH motif 1 or 2, they are not involved in disulfide bond formation. Only the cysteines in the motif 3 are involved in disulfide bond formation. So this way we could show that there is indeed a disulfide bond present in this amino acid sequence, and that is required for nuclease activity, right? So that's one example. Then next one is we want to look at the xenobiotic modifications or isomerizations of the aspartate residues in a protein, right? So now, when do you form the isoaspartates? It may form through deamidation or dehydration from asparagine or aspartate to get isoaspartate, where the peptide backbone shifts from alpha carbon to the beta carbon, right? And that leads to the protein inactivation, and then even more damage to the cell. So, but cells have repair mechanisms initiated by this enzyme called protein isoaspartyl methyl transferase. It uses SAMs, acid-nesyl methionine, to form methyl ester and then succinamide, and then to get the L-aspartate back, right? So, but if this system is disturbed, then it can result in pathologies. Now, how do we detect these isoaspartyl modifications? So see, normal CID cannot detect it. So that's why electron capture dissociation or electron transfer dissociation is used, where electrons are basically absorbed by the positively charged ions, and that leads to the radical cation, and which is unstable and dissociates at a specific position of the backbone, resulting in the C and Z fragment ions, right? So, but if there is an isoaspartyl modification, then you get a diagnostic fragment ions with C fragment ion plus 58 units and Z fragment ion with less than 57 units, right? So this way you could identify the isoaspartyl modification. So we use this instrument called LTQ-XL ETD, where we use fluorantine as an anion, radical anion, to transfer the electron to the multiply charged peptide, and which makes radical cation, and then would undergo the ETD dissociation to get the C and G fragment ions, right? So here is the protein our collaborator is interested in. So this is present in expressed in seeds, and it is required for translation process of the messenger RNAs, right? So now when this protein is present at normal temperatures or room temperature, you don't see any diagnostic fragment ions for the isoaspartyl modification. But when it is heat stressed, then you see these diagnostic fragment ions. So that means, heat stress or thermal insult can cause these isoaspartyl modifications, and they can be detected by the mass spectrometry. Okay, so that's all I have for now. So I would like to thank my collaborators. So we share facilities with Dr. Limbach, and then The disulfide linkage project was a collaboration between Dr. Hunt and myself. And then the Isomerizations modifications with Alan Downey and myself. And these are the current graduate students in the laboratory and undergrad students. And this picture was taken recently, last November. One of the students was defending her thesis. And then we get our funding from NIH and NSF. With this, I'd like to thank you all for the attention and the opportunity, and I'll be happy to answer any questions you may have.
Yes, this is open for the questionnaire from the participants. Any questions? Thank you very much, sir. So this is formal vote of thanks, sir. It's my privilege to propose vote of thanks on behalf of Chemistry Department, University College of Women, KOTI. So, sir, you are delivered very interesting area, sir, in the mass analyzer. So you have explained the recent mass spectroscopy instrument also, sir, and you have why the mass accuracy is needed to detect the compounds or the complexes or the proteins or biological compounds. You have explained excellent, sir. By using a liquid chromatography, it is coupled with the MS. By using that also we can evaluate the compound in a accurate way, sir. You have explained that also. You have explained the recent that is protein molecules, how you have by using a mass spectroscopy, how you have analyzed that. You have explained whole thing. Thank you, sir. Thank you. Thank you. In this area, you are enlightened us, sir. It's a very nice lecture, sir. It's really we are privileged to have you, sir. Thank you very much.
Thank you so much for the opportunity. So I never met you guys before, so it's a first meeting. So it's nice to get introduced to you and get to know about you. Thank you.
Thank you, sir. Thank you very much, sir, for your excellent presentation. It was very nice to have you here on this platform, sir. And hopefully, sir, we'll keep meeting in the future. We'll continue this collaboration, sir. Further in all our academic and research endeavors will be there, sir, with you. And hopefully you will be there with us to extend all the support to our faculty as well as the students.
Sure.
Thank you, sir. Thank you very much. Yeah, thank you.
All right.
Thank you, Neelama madam. Shall we have the next session? Sudhakar, sir?
Madam, good morning.
Yeah, over to you, sir.
Thank you, madam. Good morning to everyone. First of all, let me introduce myself. This is Dr. C.H. Sudhakar Reddy, working as Assistant Professor in Department of Chemistry, University College for Women, KOTI, Usman University, Hyderabad. It's my great pleasure to introduce today's third invited speaker, Dr. Radhakishan Motkuri, who is going to talk with us about chemical advances for sustainable development. He completed his BSc, MSc from Usman University. He earned PhD from University of Hyderabad in the field of nanoporous materials for supramolecular chemistry and catalysis applications. After he completed his Alexander von Humboldt Fellowship on rotaxanes and supramolecular chemistry, he finished his PDF research on molecular rotors and boron chemistry. Now he is working as a senior engineer, material scientist with the Pacific Northwest National Laboratory, Richland, Washington, US. Dr. Motkuri has over 23 years of experience in inorganic and material chemistry with the nanoporous materials. His area of research interest is engineering of nanoporous materials, carbon capture applications, water purification, contaminant sensing and removal, supramolecular chemistry, and nanotechnology. He has published more than 75 papers in various international journals with high impact factor. He has 7 patents and he got several awards and recognition like R&D 100 branch award from AirJoule self-regenerating dehumidifier and Dr. K.V. Rao Research Award. Especially he awarded 5 times from PNNL as a outstanding performance in 2010, 12, 13, 16, and 2017. He is a editorial member, board member for several journals like Inorganic Chemistry, ACS, Inorganic Chemistry, Nature Publication Group, as a guest editor in Catalysis Today also, reviewer for multiple journals and grants. With this brief introduction, I would like to welcome to Dr. Radhakishan Motkuri sir to present the lecture. Thank you, sir.
Good morning, everyone. Thank you, sir. Dr. Reddy garu. Thank you very much for your.
Thank you, sir.
Yeah. Thank you, Dr. Vijay Lakshmi garu. Yeah. I'm feeling so happy to see you all, especially Vijay Lakshmi garu is my classmate, MSc classmate, and Dr. Umesh sir was my teacher at AB College. Dr. Professor Mehta was, of course, he is the father of Indian chemistry. Looking at everyone, feeling so proud and feeling so happy to present at this workshop. Thank you for giving me the opportunity.
Thank you, Dr. Radhakishan, for being here with us. So nice to have you. So on behalf of Department of Chemistry, University College for Women, I once again welcome you, sir, to the conference, and over to you, sir.
Wait. Can I share the screen?
Yes, sir, please.
Can you see my screen?
Yes, sir. We can see your screen.
Wonderful. Good morning, everyone. I hope you enjoyed the previous two talks, and you are going to enjoy my talk too. This is mainly I'm going to talk about the engineered nanoporous materials for potential applications in the environment, which is really important for our society at this point of time. So basically, I'm a senior principal scientist at Pacific Northwest National Laboratory in the US. Maybe I can just give a glimpse of what is a national lab in the US. So there are 17 national laboratories in the US. Like I think most of you know that, like for example, CCMB or IICT, those are the CSIR national labs. Similarly, we have in the US 17 national laboratories, and the corner, let me put a pointer here. So this is the northwest corner of the US. We have located at Washington State. That is my laboratory. So mostly we'll work on like various national, regional, and international areas. And this is an aerial view of our laboratory. And specifically working on the science, energy, environment, nation security, Department of Homeland Security, with almost $1 billion of spending. This is more than that right now. I'm just showing why I'm showing all those things, the basics, like things of my library, because once upon a time it's only US citizens are required, but now everyone can apply for the positions in this laboratory. This is a national lab, and more than 5,000 right now, 5,000 staff from all over the world, especially from the USA, and also a lot of Indians too. So I want to show that where we are working on. So coming to the topic today is nanoporous materials for potential energy or environment applications. Specifically today, I'm going to emphasize mostly on the environment. So the nanoporous materials are like various materials like zeolites, metal organic frameworks, covalent organic frameworks, silica, and many other materials like porous carbons. So these are the porous materials. I'm not sure how far you know about the porous materials. A simple example is when you purchase some electronics, you'll get a small sachet, small packet in the box saying that do not eat. That is a porous material, maybe mostly zeolite A or something like that. What is the purpose of that material is to take out the water or the moisture from the box throughout the shipment, from the package to shipment to reaching to your house. That is the porous material. And that porosity, how we can tune the porosity, how can we engineer the porosity for real world applications is my work here. So I'm here in PNL from last 15 years and worked on various fields of the research, coming from dehumidification, absorption cooling, fluorocarbon adsorption, catalysis, battery, separation, water separation, cleaning, and also the security. Specifically today, because of the title and topic which is aligned to the workshop, I'm going to present about the PFAS research. What is PFAS? Its full name is perfluoro or polyfluoroalkyl substances. Why do we care? I'm going to there. These are poly or perfluoroalkyl substances. These are more than 4,000 different molecules. The main problem with them is it is having the highest, strongest CF bond. If you look at it, this CF bond is so strong. Fine. What is the problem? This PFAS are like different chains, different structures, and all together more than 4,000. And that is a big problem to the human at this point of time. How and why? Let's go to the next slide. What's happening? Especially when the military people or the people where they're working on the firefighting foams, like when there's a fire, using a foam. That foam containing the PFAS molecule and coming to the groundwater, okay, and coming to the human bodies. That was like 10 years or 20 years back. But recently, the researchers found that there's not only one source of contamination. There's a lot of sources for the contamination. For example, simple pizza boxes, a coffee mug, a paint, a camera rolls, and solar panels, heating pans at your kitchen. When you're heating a non-stick cookware, the PFAS are coated there. Okay, and paints and even, for example, because of COVID, we are using masks. What are you doing mask after? If you are using cloth mask, of course you're going to wash it. But if you are using disposable masks, what happens? You are going to throw it out. When you are throwing all this stuff, pizza boxes or French fries or burger boxes or all those things, when you are just throw into the garbage will go into some place where, because of sunshine and rain and seasons change, the material coated on that things will go into the water, groundwater, and coming to your body. This is a pictogram where from different years it's showing the growth of this PFAS contamination all over the US. I'm showing just US, but this is going all over the world. Say, for example, if you look at this picture of the world, most of the countries in the world are having this issue. And so, okay, there are a lot of contaminants in the water. How can we solve the problem? What we can do? The question here is like the PFAS are having at least 4 years of life. All know half-life. What is half-life is? Like the material, if I take a gram of material today, after 4 years, it will become half a gram. Then after 4 years, it will become half of that gram, so 250 milligrams. Similarly, it has a 4 years of life, meaning that the contamination is never ending. It's keep on like continuing with the concentration in water. And there are 6 million people already in the US. Alone US are having the problem of this PFAS exposure. And there are so many different molecules, like 4,000 plus. And finally, the EPA, Environmental Protection Agency in the US, said that this is a 70 parts per trillion or 70 nanogram per liter is a health advisory for the PFAS. You may ask, what is the 70 ppt or what is 70 nanogram per liter? Maybe a simple example I can explain you is a Olympic swimming pool water. Olympic swimming pool. You all know when we see Olympics, oh yeah, swimming is one of the great activity there, right? It's a 50 meter, if I remember right, it's a 50 meter by 25 meter and 2 meter deep, something like that. If you take a swimming pool of water, the current technologies are take the full swimming pool with a lot of all filled with water. If you add a kilogram of sugar, okay, a kilogram of sugar. There are technologies at this point of time from various companies, like including US, India, and other countries. We are able to take out at least up to 100 grams, means 900 grams you can take it. Remaining 100 grams, you have to be very careful, you have to hard. But PFAS, can anyone guess the concentration of 70 nanogram per liter or 70 parts per trillion is just to take one speck of salt or sugar, or just one grain of salt. If you have a salt in your hand, take one and put it in a swimming pool of water. That concentration is sufficient for giving the problem to the body, that low concentration. There are no other technologies at this point of time. Very rare, there are technologies, but very rare at this point of time, because the problem is not that old. So just 20-year-old, and people discover the problem like 30 years old. So still people are struggling to find the problem. And you may see, for example, there are good awareness movies on the Netflix or Amazon Prime. You may get YouTube. One is Dark Waters, one is The Devil We Know. These are the two good movies that we can tell about this PFAS problem. And scientists already, the medicinal scientists specifically already discovered how they are going to affect the body. Say, for example, they have given like at least 10 or 24 out of 4,000, 24 of them, they researched it and how they're going to affect on the immune system, lipid system. Some of them are for the blood system or cancers. So a lot of the medical technologies are already facing an issue of this PFAS problem. And recently, the Senate, in the US Senate, also discussed about this problem very seriously, how to tackle this problem. So one can understand. So I'm giving this the problem of PFAS. Now we are working as a coming to my topic of nanoporous materials. Nanoporous materials are the materials that as I'm explained you, the material like in a kind of like a zeolite or metal organic frameworks. So we have developed over the 15 years of my time here or my PhD, we have developed lots of materials like metal organic frameworks, covalent organic frameworks, zeolites, porous carbon. We have prepared a lot of materials that have a unique database that can selectively and sensitively take a lot of molecules. I was working on the capture, CO2 capture, working on the methane, working on the water, working on different things. And we also started working on PFAS in 2015 for the first time, when we come to know that the problem is getting bigger and bigger. So previously we worked like different contaminants like technates or chlorate, nitrates. Those are very easy to work with because their concentrations are big, meaning that those concentrations are like a kilogram of sugar, what I explained, in a swimming pool of water. But the PFAS problem is 1 grain of sugar in swimming pool of water. So that the problem becomes more harder and harder. So based on our experience, we have did for many things, like for example, on the understanding the fluorocarbons, how the fluorocarbon is interact inside the pore, and how this pore engineering, how can we do the pore engineering, pore topology, and changing the porosity and surface area, and also do the modeling studies. How all those studies we have done. And so I think almost I published more than 100, close to 100 publications already on this, specifically on the nanoporous materials for various applications, and specifically for fluorocarbon and fluorocarbon related molecules, how the interaction comes. So utilizing this experience, we started working on the strategizing how we can tackle the PFAS problem. So when you look at PFAS problem, so now I'm bringing both together. So introduced you the PFAS, what is the problem, current problem, introduce the materials, what we are working from the last maybe 20 years or 15 years, how can we bridge them together to get into a right thing. So when we looked at the research on the PFAS problem, what are the main constituents, main things we need at this point of time? So these are the current strategies one can think of, like, sensing, and then capture and destruction, meaning that, so first of all, if I have a well, or if I have a lake water, if I have some groundwater, first of all, we have to find a technology that can detect at that low concentration how much of PFAS is there in that water molecule. So which is called sensing or detection, which is one of the important aspects. Okay, I found, like say for example, in Hyderabad we have, so like 10 different places from Banjara Hills to Dilshur Nagar to KOTI or whatever. We got some water sources from your university, KOTI, Women's College. You got some water from Usman University campus, Hyderabad University. We got some waters. So we have to find technology that can be sensing what is the concentration of PFAS. Then one have to find the capture methodology. Yes, these are the concentration X at KOTI, Y at Hyderabad, somewhere else, and Z at somewhere else. So you have to have the capture methodologies. Let us go in detail about how what we have done from our side. In case of sensing, how they are doing right now, there are methodologies like Professor previous presenter specifically told about the mass spectra. That's one of the best useful instrumentation that can be useful for detection of the PFAS too. So LCMS, like tandem mass spectrometry or DOP or PIGE or those kind of instruments are very good. But the problem is we cannot do in situ, meaning that you have to take the water, send it to the laboratory, and laboratory will boil the water to bring the low concentration, like take out a lot of water, and you have a concentrated solution. Then you can inject in a mass spectra or NMR or something. Then you will understand how much is left. Based on that, they will reverse calculate how much is left in that. So these are expensive, especially in the US. If you want to send a water sample to a laboratory, it is $500 per sample and 5 business days. Just for 5 business days and $500 of sample per sample. That is current methodology for the detection. So by understanding that, we come up with a new technology. So we have did couple of so from 2010s, we have worked on various sensing detection methodologies that we have used nanoporous materials and an impedance analyzer. What we have done is, like here is a capture probe. Capture probe is like nanoporous materials. When there is when this is very good, the electrode platform, the passing on the current is very strong. So you can measure the strong current. But when the capture probe is captured and analyzed, then there is an impedance will happen that will tell you how much of the material is captured. That was well-known methodology for the impedance analyzer for other things. We tested that one for successfully tested for a calcium and technetium, but still the technetium and calcium, and I think if I remember right, nitrate and chloride too. But those are really easy because their concentrations are so high, parts per millions and parts per billions, which is really good to work on. But when we came to PFAS, nothing was showing in our spectrum because the concentrations are so low. Initially, we thought there's no PFAS in the water molecule. But when we send the sample to a laboratory, by paying $500, almost we paid 6 samples, $3,000, and we got that there's a PFAS, but we could not able to get using the existing methodology. Then what we did is that we combined our nanoporous materials in a impedance analyzer and a microfluidic platform. 3 things together, we were successfully developed a sensor or detection methodology that can detect the PFAS at that low concentration. So this is a microfluidic platform. It's like it's a small chip which is like less than size of your credit card, for example. When you like zoom it here, this is the channel where we are putting the nanoporous material, metal frameworks or the zeolite or the developed material already, and embedding here and passing the water contaminated PFAS. Immediately when this capture happens between the material and PFAS, we'll see the impedance. We patented this work, and recently we got around 100 finalists of this the technology, because in the world, as far as my knowledge, maybe I'm wrong, sorry for that, there are only 2 detection technologies are available in the world. One is from Italy and one is from PNL, from us, our team at PNL. So we're working, of course, this is still at the laboratory bench scale right now, but we're working more on the commercial aspect, working on the licensing to give a bigger to help to make use of this technology to the real world and to the people. And we also compared how the results are, our results are showing compared to the existing methodology. Like I said, MSMS, TOF-MS, all those are showing limit of detection of the similar range of 1 nanogram per liter to 25. And PNL lab on a chip chemical technique, electrochemical technique is almost giving 0.5 nanogram per liter, which is equally good to the existing ex situ methodology. Our method is in situ, and it can be done within a day, just within a 24 hours. I don't think 24 hours, I think 10 hours, we can get the results. Generally speaking, it's like less than few hours, but because of still we are optimizing the system, because when you are flowing the water, this the material also flowing along with that, and we're getting some trouble. Otherwise, it will be like minutes, like an hour or two. That's our intention. But at this point of time, this is a methodology or a microfluidic methodology with impedance analyzer with nanoporous materials, 3 combination together. We have developed this technology where the contaminated water with PFAS, when passing through the maze kind of a microfluidic channel, when there's a capture happens here, and you'll get the impedance analyzer, when we can detect as low as 0.5 nanogram per liter. As US EPA, Environmental Protection Agency, said 70 nanogram per liter is a limit, and we are way lower than that. That was one of the great progress from our side. Well, we have done the detection. What next? What we can do that? So maybe you are using water filters at your home. Everybody, of course, everybody's using in water filters. What are the water filters? What are the materials you're using in the water filter? I don't know whether you know or not, but most of them are carbon-based materials. So these carbon-based materials are very inexpensive. They're very good, mostly the granulated activated carbons, and those are really good for taking out a lot of water contaminants. So the filters are mostly made with activated carbons. So even the PFAS, they have tried with the granulated activated carbon. Yes, they have taken very good of PFAS from the water where the contaminated water with PFAS. But the problem happened there is because of the surface areas of these carbons are very low, meaning that the surface area of carbon is 200 to 500 meters square per gram. Per gram of material, you have at least 200 meters square per gram. So by adsorption of the PFAS, you are having the carbon and you're piling up a lot of carbon because you keep on absorbing that. And once it's saturated, you have to throw it out. The problem is you cannot throw the material. Why? Because once you throw in the garbage, again, this PFAS will go from carbon to the ground. Ground has a potential, can pull all the materials again to the ground. So what is the advantage of the carbon? So we have a methodology that can destroy the chemical, which destroy the bad chemical. This is PFAS are really bad, destroy. So we have developed a methodology for the capture too. So when coming to the carbons and other exchange resins or reverse osmosis, these can be done, but low capacities of PFAS and slow kinetics. And as I showed, there are 4,000 different PFAS molecules are there. Only the longer chain can be taken, but not the shorter chain. That also a current problem. So to solve the problem, again, as I mentioned, like we have developed a multiple materials with a different porosities, different surface areas, pore volumes, surface functionalities, a lot of materials. Almost in my laboratory, we have developed almost like 200 to 270 different materials. Some of them are reported, some of them are not reported, some of them are composites, some of them are like, core shell, yolk shell, different kind of materials, where we have tested individually different kind of molecules. And why? Because to understand the host guest chemistry clearly, whether this material is good for this. If yes, why? Why not this material? and how can I improve the capacities? How can I do the structure property relationship? Can I improve the capacity? Can I improve the sensitivity or selectivity? Or all those work we have done permutations and combinations with the materials and the molecules, all of fluorocarbon containing molecules. Then we have done some molecular modeling simulations, whether our experiment is right or not. So we have done the simulation studies, and also did the in situ characterizations, say XPS, or like a beamline, like a EXAFS, XANES, like expensive instrumentation using the beamline to see whether the fluorine is connected to inside or outside, connected to the metal center, not metal center, functionality, all those studies. Then established a database that say this material is specifically good for that. This material is specifically good for this. So we have the database right now. Then we started the filtration. Simple. How can we use it? Say, for example, taking the solution, water, simple water with the PFAS, adding a material and stirring like 24 hours to 48 hours. Then you can see the before and after, you can see the capacities. The commercial carbons, what I told, like current existing carbons that we are using in our filter beds, water filters, everything, that is this is the capacities compared to the materials that we developed. How like almost like way higher. You must say that what is the advantage? Yes, if there's a water, say for example, you have a 5-liter water at your house. If you consider a town like thousands of gallons of water, if the capacities are very low, you are creating a lot of secondary waste of the carbon that containing the PFAS. But then, for example, now you have tons of carbon with PFAS contamination. You don't know what to do. You cannot throw it out because it will come back to the ground. Because of high capacities in our materials, what we can make is, instead of tons, we can make it in kilograms, or at least called quintals, where we can work on the materials separately. I can tell in the next couple of slides. So then we have tested independently, like how far this going, like when it's going completely down. This is a carbon material compared to our materials, and we have shown something is happening inside the pore or outside the pore, or which is really important because we don't want surface phenomena, we want a pore interface phenomena. Structural property should be very important for that. Then we have done all those studies, and TEM, XPS, and all the studies showed that yes, this is happening inside but not the outside of the material, so that it will be, we can have tune the material for the right purpose. Maybe you can you may say that tune the material. So tuning or engineering the material, meaning that a civil engineer, maybe you all know a civil engineer can construct a hospital, a school, or a house with the same brick and cement, but different directions, right? You have a big hall in the school with and the classrooms, but the same brick can be used as a hospital, the different methodology, different style. Similarly, at nanoporous style, at nano level, can we do the engineer? Can we pull the pore? Can we push the pore? Can we functionalize something on the pore? Can we do defect? Can we create a defect in the pore to have a specific selectivity and sensitivity towards the right guest molecule? Guest here is PFAS molecule. So we have tuned the materials to get the right direction, and we got a lot of materials already for these two different PFAS, these are the two major contaminants out of 4,000 family of PFAS. And you can see like a couple of materials did not take any of them waste, but still we have done almost like 26, if I remember right. Yeah, I think recently, last week, 26 different materials we tested for, and with one of the best one is here. This is stock solution before and after. You can see how far we were able to take out these materials. Then the best material, whatever showing here, we tested next to different kind of PFAS, because as I said, there are 4,000 different molecules. Out of them, 24 are really studied into the human body, which is really bad. Then we can we found the materials for specifically, and all those 20, not 24, but we have done almost 7 to 8 different molecules already, and a few more are there. So we can see compared to the carbon material and how the capacities, how much absorption happening in our material that we engineered, these nanoporous materials. You can see how far they are different from the carbons. So we have established, but of course, each material is a different material, but different capacities. So finally, then coming to the destruction. Yes, we did sensing, capture. How can we destruct? Meaning that I cannot throw the material, what I showed in the previous slide, into a garbage, because it will go back to the ground again because of rain, sun, and all those things. We don't want that. What we have done, we are developing, of course, in this sensing and capture, we are way advanced, but in the destruction, we are still working on the catalysis, because my PhD work mostly worked on the zeolite based catalysis. Then what we are working is thermocatalysis, or we do some kind of a thermocatalytic or photocatalytic ways to destruct the CF bond, so that we can completely destroy the molecule, saying that it will never ever come back. That's our motto. We are still working on the destruction at this point of time, and because of time, I cannot show you more things on the destruction. But sensing is very advanced. Capture in the middle, and destruction we started at least just before the pandemic. Now we are working seriously on how we can destruct the material completely with treatments, the plasma treatment, and all those things with the other team. So finally, I would like to say that we have developed the methodology for the nasty chemical, the PFAS, capture, sensor, and destruction. And we have developed the technology of sensor towards patented and licensing to the companies, where this company can produce the instrument. Of course, this may come like next year, following year. We are working seriously on that, because it can be useful for every human being on the planet. That is our main motto for sensor commercialization. And if you want to see something on this, I was interviewed by national channels for the podcast, making the podcast on the PFAS specifically, and explained what is the problem and everything on the YouTube. It can be available. You can just search by PFAS podcast, Mochkuri, you can find here. But one thing I want to caution you all here before going further is, don't think that this material is very hard, very toxic. It is not that easy to work with. You have to be very extremely careful while working, because as I said, one speck, one grain of salt in a swimming pool of water, that concentration is sufficient to deteriorate your body with a cancer or so many things. So at PNNL, even for purchasing this PFAS chemical, you have to take special permission. Why we are purchasing, what are we doing, and how we are mitigating this chemical. All those things we are working to get purchasing the chemical, and working on how we can take out in the waste thing. So those kind of things are very important going forward. So I'll suggest you, please, if you want to work, very good. I welcome you people to work on this, but extremely caution. This material is really nasty. Finally, I would like to thank our team, because I did not do anything here. Only my team did all these things, and I just guided them, or just collaborated with them, or worked with them. And these are my team, my postdocs, and my PhD interns, my collaborators, and from universities, various universities in the US, and the industries, to test real water samples, because that's important, because we cannot get the real water sample. So, and working with for example, water agencies, like city water agencies, like companies working for city water agencies, to see all those PFAS water in the contamination water. So I would like to acknowledge my team, like who's funding me from so many years, the DOD, DOE, and our PNL LDRD, that giving the funding to do all this research. And in the beginning, I showed you one on a slide that security. We are working on other things like security workshop in India and Bangladesh sometime in May 2022. If anyone is interested in the security of the project, security of the chemicals, or chemical security, supply chain security. I know this is different. I don't want to advertise this one there, but I saw the opportunity because it will be helpful for human beings for the security of chemicals, not the safety. So far I talked about safety, but the security of chemicals. That is also working. You can email me if you want more information on that. So finally, I would like to say thank you for your kind.
Ramya, she wants to present. She has some meetings. She wants to present.
Thank you, sir.
Sudhakar sir, I have a question.
Anybody? Okay, tell.
Yeah.
Ask him, madam.
Yeah. Very good afternoon. Good morning, sir. It's a very nice presentation, actually.
Thank
And
you.
I have one question. And at the during the capture analysis or capture of this PFAS material, you said you are interested in studying the host guest chemistry of supramolecular. And anyway, comes under supramolecular chemistry, as of I know.
Yes.
And there are lots of thermodynamics involved in this, like delta G parameters, like all enthalpy, entropy parameters can also play a major role during the host guest chemistry. Have you any time?
I understood your question. Excellent question, actually. That's really good. So the entropy, enthalpy will definitely have a great effect on this host guest chemistry. Say, for example, if you're working a material, a nanoporous material like a MOF, and you're working with a CO2 or methane or the gases or liquids, you have so many molecules in the pore. So definitely you can understand how the guest is behaving inside, whether the energy is absorbed or energy evolved, right? You can easily calculate. So simple example is that take a water absorption in a nanoporous material. When it absorbs, there's a heat evolved, latent heat of vaporization. Simple example. Because the number of molecules, water molecules, are so high that one can see how much is the change in the enthalpy, entropy, kind of things. But here the problem is one molecule in the big pore that is way higher.
Okay, sir.
You know what I mean?
Yes, sir. Yes, sir. I understood. And
so the concentration are so low. That is the main problem to understand the heat, entropy, and enthalpy. But it's an excellent question, actually.
Yeah. Thank you, sir. And one more question I have. Because of the present day scenario and because of the lifestyle the people are going through, and we are bound to use certain things like electronics and all other things, and refrigerator is mandatory and air conditioner is mandatory, and in that we will be using as a coolants, right, the chlorofluorocarbons. Yes, and that is also kind of materials, right? Yes, sir. I have seen the molecule in the list, chlorofluorocarbons.
Yes.
And yes, and after this usage of it, anyway, we are dumping without any concern, environmental concern. We are doing it. And can we expect this technology will be imbibed into the future generations whenever electronics are coming up? Is this technology can be useful in developing the better electronics in this to the society?
You asked a second excellent question, actually. I only showed about this PFAS contamination in the waters where we got the R&D 100 finalist, but I got the R&D 100 2017 award on what you're talking about, the fluorocarbons, how chlorofluorocarbons will interact and how they can be utilized for efficient cooling methodology, absorption cooling. So I of course that's a completely different topic, but the absorption cooling right now, because refrigeration, whatever you're using in the coolant is really problematic for the ozone layer. But the new coolant, like for example R1233ZD or R1234YF, those having zero oxygen ozone depletion potential and zero global warming potential, both of them are really good. Right now, these are the very good coolants. And now we have developed the materials that can selectively host that material. When they host, these materials host the fluorocarbons of R1233ZD or R1234YF, there's energy evolved or energy dissipated that we utilized for a cooling methodology. And we deployed on a Navy ship. But why? Because a Navy ship is having almost 50% of this tank is used for air conditioning. So we changed that Navy ship from 50% to like 15% because our size of the material is so low. So that is completely different topic, but that's really good. Yes, the new technologies are coming, and I really will be happy to explain you more, or you can read my papers on the adsorption cooling. Just this year, maybe like last month, we published a paper in Accounts of Chemical Research on the adsorption cooling and pore engineering. You can look at it. That is specifically talk about how one can tune the materials for efficient cooling.
Thank you so much, sir. And actually, it's a broad area, and each topic is a kind of 2-hour lecture, I guess.
Exactly.
And really, it was really very interesting to listen to you, and it's thought-provoking. And as the teachers, and we should inculcate this kind of knowledge to the students to whom we are teaching it. Thank you so much, sir. Thank you for the opportunity. Yeah.
Exactly. When Dr. Vijay Garu, when she asked me about it, I thought of presenting adsorption cooling, but I want to inculcate about the PFAS problem in India, and people are using a lot of like non-stick pans, and try to. My only intention here is to say about the problem and how one can use. Think about it. How efficiently I can use non-stick pans. I stopped using non-stick pans completely from almost like 10 years. We are using different kind of pans, non-PFAS coated pans, or maybe using masks. So though masks, the pandemic everybody's using, we are using cloth masks, double cloth masks, because I know the problem, at least, so at least giving a glimpse of the problem and solution and where it's coming from, and one can think about how can everybody, because this is one person cannot solve this problem. It is a complete society problem. Everybody has to understand and work on it. That's why I presented this specific PFAS topic compared to other topics,
Thank you, sir. Thank you for selecting a good topic. Yeah.
Thank you, sir. Radhakrishnan, sir.
Thank you so much, Radhakrishnan. It's wonderful to listen to you. Excellent work, excellent research work, and I think it has given us certain goals, not only to the staff but also to the students. To take care of the environment where we all are living in. So that excellent work and excellent presentation from your end. Thank you so much, Radhakrishnan.
Thank you. Thank you for the opportunity.
Thank you, sir. This is the formal vote of thanks. On behalf of Department of Chemistry, University College for Women, KOTI, Usman University, Hyderabad, it's my privilege to propose a vote of thanks to our speaker, Dr. Radhakrishnan Motkuri, sir, who spared time from his busiest schedule to grace the occasion. Today, we had an opportunity to hear your thoughts on engineered nanoporous materials for potential environmental applications and research on PFAS for polyfluoroalkyl substances and current strategies for PFAS remediation and sensing, capture, destruction. And this will surely be going to encourage to students, research scholars, as well as teachers also, sir. My sincere gratitude to Dr. Radhakrishnan Motkuri, sir, for gracing the occasion and sharing his valuable information today, sir. Thank you. Thank you very much, sir.
Thank you for the opportunity and wishing you all the best.
Thank you. Thank you.
Thank you, sir. Thank you very much.
Now invite Dr. K. Ashwini, madam, to take over the session.
Thank you,
good morning. Good morning, everyone. Shall I continue?
Over to you, madam.
Yeah. Good morning, everyone. I welcome all the participants to the fourth session of this two-day international conference. Today, we have Professor Jayanti Subalakshmi ma'am for this session delivering a talk on molecular materials. The organizers of two-day international conference on chemical advances for sustainable development and the entire chemistry department of University College for Women, KOTI, would like to extend a warm welcome to Professor Jayanti Subalakshmi ma'am. Thank you, ma'am, for joining us all. Let me take this opportunity to introduce you, ma'am, to the audience. Professor Jayanti Subalakshmi ma'am completed her MSc in 1997 with distinction from Andhra University. She received her MPhil degree in 1998 and PhD from University of Hyderabad under the supervision of T.P. Radhakrishnan sir. After completion of PhD, she moved to Research Institute of Electronic Sciences, University of Hokkaido for postdoctoral study as a JSPS fellow funded by Japan Society for Promotion of Science. She joined BITS Pilani Hyderabad campus in 2009. as a lecturer and very soon got promoted as assistant professor in November 2009 itself, later to associate professor in 2015. She is the recipient of the Best Research Award in 2004 by Dr. K.V. Rao Scientific Society. She received Distinguished Woman in Science Award in 2009. She has over 35 publications in reputed international journals. She has filed patents for 3 as a principal inventor, but out of which 1 has been granted very recently, November 2021, 2 are under examination. A couple of her works were recognized and received Best Poster Awards in various international conferences. She has contributed book chapters. She has completed 2 major DST projects as principal investigator, and currently 2 proposals are under review. She is a life member for several scientific societies like Indian JSPS alumni, etc. She is also a reviewer of research paper of RSC and Elsevier publications and examiner for several PhD theses. She is currently guiding 5 PhD research scholars, and at BITS Pilani, she has been convener for doctoral research committee, member of academic research division, and various others. Thank you once again, ma'am, for joining us. We are looking forward for your talk on molecular materials. Ma'am, over to you, ma'am.
Am I audible?
Yes, ma'am. Yes, ma'am.
Okay.
Welcome to the conference, ma'am.
Thank you, Dr. Vijayalakshmi, and thank you, ma'am, for your kind introduction.
Thank you, ma'am. Over to you, ma'am.
Yeah, so I think the audio is also visible, right?
Yes, yes, ma'am. It's clear, ma'am.
Yeah, I'll share the screen. Just let me know if it is visible to you all.
Yes, madam. The screen is seen, ma'am.
Okay. Just a minute. Dr. Vijayalakshmi, is it fine?
Yes, ma'am. We can see the slide, ma'am.
Okay.
Yeah,
So may I start?
Yes, ma'am. Please, ma'am.
So thank you one and all, and especially the organizing committee members for giving me an opportunity to deliver a talk on this auspicious occasion of conducting really a very good initiation of a 2-day virtual international conference on chemical advances and the sustainable development accompanied by the same. So, however, I would like to convey that BITS Pilani is mostly focused on the teaching aspects, but we are very much supported, and we began research from a decade back in the Hyderabad campus. So from yesterday, I've been listening to many eminent speakers who have done a very excellent research in the advanced sciences, and a very good lecture was also given by Radhakrishnan sir. So I would like to focus our research, providing it deals with the advancement in the sciences and also the sustainability aspect, which has been the theme of the current day conference. So basically, I would like to focus on the molecular materials, especially on the organic species and the donor aspect of pi systems, along with the polymers. So I would welcome you all to this talk, and to have a brief introduction about the molecular materials before we go directly into the research work. These are like a little different from the traditional solid state materials, which are actually constituted of atoms or ions, while in a molecular material, we can see the property of the molecule itself, or the molecular ions, which actually are the building blocks for the resulting properties. And while the traditional solids like inorganic salts, metal oxides, covalent solids, and many others have been the initial part in the development of the material side, the bulk state or their comparative application was related ultimately to their constituents, atoms or ions. Therefore, the molecular material plays a significant role these days to compare or correlate the structure and properties. And beyond that, molecular materials also exhibit a very unique property, like they are dissolved in the solvents, they get melted, they can be sublimed, and they break down very comfortably into their individual constituents, which retains their attributes and the properties that are manifested by them in the solid state. So to have a brief overlook of the development of molecular materials, especially related to the organic molecules, in the early days, fundamentally from the silicon or many other inorganic metals have been basis for the conductivity aspects when related to the bulk materials. However, the organic conductive materials, which were discovered in 1862, polyaniline was identified initially, and later people tried to focus on the electrical conductivity aspect pertain to the organic molecules. And in that aspect, perylene-bromine complex was successful. And later, people tried to extend the application of the materials related to optical properties along with the lasers in the 1960s. And then tremendous research was accomplished related to optical as well as nonlinear optical materials. In 1973, the first, namely true organic metal, was identified when the organic electron donor, tetrathiafulvalene, was reacted with the organic pi acceptor, tetracyanoquinodimethyl, and comfortably at the room temperature, very good electrical conductivity was observed, up to 500 to 1000 Siemens per centimeter. So later, people tried to focus on small organic molecules, especially like organic solar cells, which are gaining interest these days, and their applicability is due to the fine tuning of the band gap, which will lead to the absorption of the solar energies and convert the corresponding electrical component. So later, many molecules were functionalized, and then conjugation aspect was taken into consideration due to the variation of the color in the absorption spectrum. Later, nanomaterials were developed, which were utilized in several aspects, like people are familiar in the luminescent devices, sensors, bioimaging applications, and so on. So from the fundamental single molecule to the nanomaterials, there has been a continuous development and focus of organic chemists in the contribution towards the development of molecular materials. However, the first organic material which was considered to be a conductor was a simple charge transfer complex that was obtained by reacting TTF and TCNQ. So this is tetrathiafulvalene, and TCNQ is tetracyanoquinodimethyl. At the room temperature in the solvent, very good crystals were obtained, and the interaction among these ions correspondingly lead to their charge transfer property and a very good electrical conductivity. So basically, this is the pi electron, a donor and the acceptor. They form an ion radical pair, and then the movement or the delocalization is facilitated from the donor to the acceptor via extended pi conjugation up to the cyano group. So the first oxidation and the first reduction suggested the homolumo gap of 0.17, very low band gap. And the reversible reductions of the TCNQ moiety and reversible oxidations of TTF has attracted the people to further continue the research and try to design many more organic molecules where even the pi conjugation can contribute to the conducting aspects. And not only that, the pi electrons are very much active to respond the molecules for optical property like luminescence. So many electron donors are shown here, which I'm not reading because the names are clearly specified and you might be familiar with this. And the acceptors like tetracyanoethylene and the benzoquinone with a substitution of fluoranyl, chloranil, all these are prominent. And later, people try to work on the fullerene and then the carbon C60, later graphene, and then the furthermore functionalization of graphenes have actually come into the scientific communities. So the major difference between the traditional materials and the molecular materials is that initially we try to design molecules and then try to get the miniature with a very small dimensions. And here I would like to focus on the tetracyanoquinodiamethane, especially in this talk, because we have reached to a very good advancement from the basic properties to the application of these molecules as memory switching devices and solar cell properties. So we try to functionalize the tetracyanoquinodiamethane, and the functionalized species are named as DADQs just because they are the amine derivatives of the core moieties. And then we try to explore their application. So the fundamental fragment of the developing and then establishing into a device starts from the design of the molecules. And how do we achieve these applicative properties? Basically, we try to look for the interactions like electrostatic pi interactions, because these are very good rich electrons, and then the covalent bonds, hydrogen bonds, and so on. So here the organic materials or inorganic metal complexes, charge transfer complexes, thin films, closed gas systems, all these are like taking into account various interactions that are basically needed to be investigated. So all this, we actually call it as a fabrication of molecular materials with different interactions. Can I close this window? How to minimize this one? I'm just looking. Okay. So the elements or the compounds are the basic entities. We try to perform various chemical reactions and then try to look for the physical approaches to, fabricate them into materials. And this is the traditional pathway, which most of the people are familiar. However, when we look at molecular materials, we try to identify the element compounds that are present, try to perform the chemical reactions, and then get the final molecule of desire, which would be of applicative identity. And we try to fabricate with different techniques and then design the material aspects of the molecules. So this is the, in short, we can say that while the traditional materials have a one-step fabrication, the molecular materials follow two-step methodologies, because we should get a molecule ultimately from the chemical reactions, and then we can try to take it into a device. So since I'm focusing on the fragments or the derivatives of the tetracyanoquinodiamethane, the core moiety will be the aromatic ring with the cyano substituents. And it is very interesting that the subtle changes of the amines on the delta plus carbon lead to a drastic change in the properties that are experienced by the various derivatives that are obtained. So this is like a broad overview of the significant molecules that have been developed. The above ones are reported in the literature, and we have developed several new molecules, which I'll show you in the coming slides. However, when you have the same amine moiety, then we call it as a symmetric substitution. And when we have a different amines on the delta plus carbon as substituent, we call it as an unsymmetrical DADQs. So we basically focus on the optical, semiconducting, nonlinear opticals, and the fabrication of these molecules into devices. So optical materials can be categorized into electroluminescent dyes and pigments, fluorescent nanoparticles, aggregation induced emission, solid state emitters, and liquid crystals, luminescent liquid crystals, laser dyes. However, we have focused almost on these parameters, and we are trying to move ahead with the other aspects which I have described. So electronic materials are mainly dealt with the semiconducting aspects or the semiconductor properties that we actually try to expect. So they are concerned with the design, like extended conjugation or having some the plus I effect, minus I effect, and so on. We try to synthesize, characterize, and apply these organic molecules or polymers to get desired electronic properties. And the most demandable is conductivity. So what is the advantage of organic molecules relative to this? Organic electronics deals with the lighter and more flexible opportunities and very low cost electronics, where the vacuum processing is not required, lithography is not required, and the substrates have very low cost, like we can make the fabrication on plastic, paper, or even cloth, and direct integration happens. So we have used this technique of direct integration and without any lithography or the vacuum processing. Basically, the cost which can be compared with the organic molecules when compared to the inorganic like silicon is that the this costs $5 per feet square, whereas this is $100 per feet square. And the organic materials have a low capital, whereas silicon needs very high, and the device size is like approximately 10 feet, and we can roll because they are flexible and have very ambient or simple processing techniques, whereas we need very ultra clean room and multi-step lithographies when we deal with silicon material. And small disadvantages are there, like they are high resistance and they are not that good conductors of electricity, because the electron mobility actually have some smaller bandwidths, and the shorter lifetimes are also there. However, this can be adopted as an advantage when we try to work with the fluorescent molecules. However, they are more stable, okay, in the working conditions. And now thermally stable organic molecules have been developed, many. And the major advantages when compared to the inorganic materials is that they are biodegradable. 90% of them are made from carbon, hydrogen, or very little other elements. So the expansion of organic electronics opens up a doorway to many exciting molecules which have advanced applications, and these would have been impossible fully with the inorganic materials like copper or silicon. And the resistive switching memory, where the organic molecules have been used as the read and write memory devices, or we can also call as on and off switching properties. Now, many bulky molecules like oligocene derivatives have been synthesized, which have very good stability, and they work on the solid state, and they have good contribution as the transport carriers. But we have focused to apply the same technique with very small molecules, especially the derivatives of the CNQ. Likewise, the optoelectronic properties, which like photovoltaic cells, the solar cells, in this field also, many molecules like especially polymers, extended alkyl chain, extended conjugation molecules have come into the market, where the push-pull structures with very rich electron donor and the electron acceptor linkages have been utilized and developed. And TCNQ, on the other hand, is applied in the non-fullerene organic solar cell. However, with a large amount of TCNQ, which is considered, and power consumption efficiency was like 8.2%, which is like higher than the device where TCNQ is not added. So the role of core TCNQ played a significant involvement in increasing the power consumption efficiency of the solar cell. So we try to actually develop pure organic derivative, which can be, exhibiting a solar cell property. So to begin our journey with the derivatives of TCNQ, basically we react the TCNQ with primary, secondary amine, and sometimes it forms a cyclized molecule also. And it's a simple reaction in a one step where we can get a symmetric substituted molecule or asymmetric substituted molecules. And as I have shown in the previous slide, several of the derivatives, the effect of alkyl chains and all have been investigated. And the reason for choosing the TCNQ moiety in our laboratory is that it is a easily reducible component, and it can exist as a radical anion. It has a reduction potential of minus 0.3 volts. And this property helps us to utilize the molecule in the development of fast transfer complexes. And it can also form salts with rich metals, and lithium, TCNQ, and many other molecules have been studied by various chemists. However, we focus on the substitution reactions like either mono or disubstitution, which we call it as a symmetric and the unsymmetric DEPTs. Now, recently, a group from Professor T.P. Radhakrishnan's labs have found that the enhanced fluorosis in the solid state or aggregated state is observed in the aromatic amine substituted DEPT, and the role of the dihedral twist or the critical role of the aggregation in the enhancement followed by the twist angle has also played a major role. So I'm just highlighting. If you have any queries, please interrupt and get it clarified. So I'm just beginning how from the smaller aspect, we have moved to an advancement to justify the theme of the conference as chemical advances and the sustainability. So an ethylene spacer, when we use as a substituent on the TCNQ, we could find interesting property of nonlinear optical rather than the linear optical property. Reason to choose spacer group ethylene is that it is an essential part of many polymers, provides flexibility, easy to fabricate because the conformational changes on the ethylene provide the feasibility in working with these ethylene spacers, and they influence on the property of the functional polymers as well. And it was also noted that the ethylene linker gave complexes with very good helical property as well. So due to these reports from the literature, we choose ethylene spacer, and the amines, all the three which we reacted have a different heterocyclic moiety like a piperidine, a pyridine, and pyrrolidine. Now, when we try to react the TCNQ with very simple, these three amines, interesting features were observed. Now, all the three amines have resulted in the symmetrical substitution where we got substituted derivatives. And interestingly, even all the three had a similar molecular twist, approximately 57. Now, the property, if we observe, only one among the three, that is the pyridine substituted amine, was showing a second harmonic generation. Very important aspect for the physicists who work with lasers, where this is a nonlinear optical property. And here, the chemical entity should have a capability of generating a photon with twice the energy when compared to the incident frequency of the laser. Or we say that the moment we try to place this compound in the laser, the incident light, if it has a wavelength of say 1054, the emitted light will have half the wavelength of the incident light. So it can change the wavelength of the lasers. That is the attractive feature of the second harmonic generation, or we call it as a nonlinear optical property. And this property is achieved only if the dipoles in the crystal lattice are not in the anti-parallel. The moment they are anti-parallel, resulting dipole cancels and we cannot get this property anymore. So only one among these three has shown required orientations of the dipoles like a zigzag manner with which we could achieve the analog property. And interestingly, when we try to compare the ethylene spacer substituted amine without any heterocyclic moiety, we see that that twist angle is only around 40. So an increase in the twist angle of around 16 degrees and the orientation of the molecular dipoles can change the behavior of the molecule from a linear to a non-linear optical orientation. So this is called as anti-parallel. If you look at the delta minus sino are present quite opposite to each other. And the same is the other case. Here we see that there is a zigzag orientation. So this is called as fine-tuning of the material property related to a simple core fragment of TCMQ. And almost the SHG was 6 times urea. Generally, like we take KBr as a standard in the IR spectroscopy, urea is taken as a standard for nonlinear optical studies. And any compound which shows the NLO or the second harmonic generation above urea is considered to be an appreciable molecule to be contributed in that category. So we got 6 times urea with a simple one-step reaction where the choice of heterocyclic moiety along with ethylene spacer played a crucial role. Now we thought of introducing one more moiety where you have a cyanophenyl piperazine derivative and a piperidine derivative. And these moieties were reacted with the TCNQ. We found a like helical type motif. It's not a true helix, and much more attracting feature was bendable property of the moieties, which people are now working to fabricate them on the screens so that we get bendable devices. And the more research on this is being, under progress in our laboratory. So I'm just highlighting today on the effect of these side chains to cause a drastic change in the properties. Okay, of course, the fundamental chemistry lying behind these properties are the very, very fundamental interactions like hydrogen bonding, a supramolecular assembly, non-covalent interactions, and so on. But properties are quite different. So I hope it will be interesting when we proceed further. At the moment we try to now react TCNQ with a carbonyl substituted morpholine derivative, quite different amine which people didn't explore earlier. The reason of choosing this is having a carbonyl moiety and the lone pair of electrons were in continuous conjugation. Now, this has resulted in a quite contrasting property, which was surprising, and it was unexpected that the moment we try to grind this material with KBr, it started recognizing KBr, which is usually not observed. It is unprecedented because KBr is used as a standard for infrared spectroscopy, isn't it? To study the functional group identities, stretching and other frequencies as a fundamental characterization techniques, especially for solid state materials. Now, the moment we try to grind this material with KBr, it tried to recognize. So KBr was actually interacting with this in the solid state. Of course, isolation and purification of all these compounds is quite challenging because we have to account for the zwitterionic nature, and it is really difficult to work with zwitterionic molecules. And polarity is an issue because TCNQ itself is a polar molecule. Now we try to link amines to that, we get much more polar. So crystallizing and then studying the solid state property and then trying to direct to the material application takes quite a long time. Of course, 8 to 6 months. Usually we take it. So these two compounds are all the time being obtained as mixtures and not as an individual components. So we have to separate them by the simple polar non-polar solvent technique. And then we found that the reason for the recognition, I'm again repeating, I'm telling the highlights of the work. The reason for the recognition was extensive CH pi interactions. The aromatic ring, the electrons with the CH of the moieties of the substituent. And compared to both, interestingly, though the second molecule, monoderivative, had a very less CH pi 1 compared to the first one, the substituent was quite in a different plane and compared to the other fragment. This could lead to the feasibility. This is above the plane, the carbonyl group, for recognizing the potassium. And then many other ions were detected, but we found the reason for the fluorescence of the enhancement in the solid state was due to the aggregation that was carried out by adding the water content to the DMSO solutions. And we could see that one of the molecules showed a quite a uniform response while the other showed in a different way. And this is accountable again to the zwitterinic nature. The dye substituted is more zwitterinic, so it is prone for the aggregation when compared to the other. So when we try to grind the simple, pristine state of the substituted derivative with the various salts of the potassium, we can immediately see the different colors, which leads us to a thought that some solid state reaction is actually happening. So it's a solvent free technique, and ions can be recognized by simple grinding. Within 1 minute, we could find the change in the color. So characterization was again challenging because we could not get the IR of the pure molecule, because the moment it is grinded, it is showing the color change and potassium is recognized. So we characterize this first studying the IR on recognition of potassium, where the carbonyl stretching frequency varied and the intensity of the peak was slightly less, leading to the elongation of the carbonyl, and potassium is recognized. And the drastic enhancement of fluorescence in the recognition phenomenon was observed, which also proves that the potassium ion is sensed. Now, how to know that whether the same is happening in the solutions as well? We did the control experiments in the solutions, and we could not find any difference in the emission intensity even after the 1 month of standing for the solutions where the potassium bromide and other salts were added to the PCNQ derivatives. So detailed investigation of other counter ions like thiocyanates, ammonium, all these are being explored in the lab. And when we studied the computational calculations, then we came to know that as the grinding time increases, potassium ion is approaching the phenyl moiety of the aminophenyl carbonyl species, which means that along with the electrostatic interactions of the potassium and carbonyl, even cation pi was favoring. And this was a quite new result. And we published this in the ACS omega. So we proposed the mechanism that the disubstituent is interacting or sensing two potassiums and the mono one with one. So the extended conjugation at the delta plus carbon plays a crucial role in sensing the potassium ions. Similarly, when we try to substitute hydroxyethyl piperazine, we see that the ethylene spacer is having an heterocyclic moiety on the left corner, whereas NLO, we tried it on the other end. So leaving the polar moiety free. Now, this molecule has resulted in an enhanced fluorescence of the solid state where green emission could be identified. And apart from that, the interesting aspect is that this molecule showed resistive switching memory device property, where the data can be read and then we can write it, or it is like an on-off mode. So we choose ITO as the substrate, and the process has been done like cleaning it with the isopropyl alcohol and deionized water. And the compound was dissolved in the corresponding solvent. We did it in DMF, that is coated. Then we heated it up to 150 degrees, used the shadow mask, and then coated aluminum electrode. So now we have an polyethylene terephthalate with ITO and our molecule, and we could make it into a device. So the fabrication procedure is described here. This solution was spin coated on the plasma clean at 150 degrees centigrade, and aluminum top electrodes were coated. However, the interesting aspect is that this device showed a very good, transparency, and it could sustain the voltages when we sweep from 0 to 3 volts, 3 volts to again 0 volt. Similarly, 0 volt to -3 and -3 to 0. This is called as a reversible study of learning about the switching property. And then the set and reset voltages for 2.26 and minus 2.88. So up to 30th cycles, we could see the reproducibility, which means that continuously the memory could be like read and read and write mode was attained. And along with that, we could also like compare it with the on and off type of devices. So this figure indicates that even with the bending, like we want to have a sustainable devices. So we tested the bending because optical fibers are all dealing with the not the rigid anymore, but the flexible or the bendable system. So in spite of several bendings, the retainability of the data could be achieved. And this phenomenon of sustaining the property with many bending characteristics shows that it can be used under low power flexible device applications. And these are the extended study to show the reliability, like after several repeated cycles of the resistor switching, low and high, you would maintain, and up to the diameter of 5 mm, the reproducibility would be obtained. And this is like a critical fixed state for the materials. And I am not going in depth into the mechanism, but would like to focus that this switching depends upon the amount of the electron donor that is happening from the ITO, from our molecule. And we can especially focus on D and E, where we can see the positive and the negative bias, that once the feasibility of the transfer of electrons is there from the ITO to aluminum, we can see the forward, and once the negative bias attained, all the electrons move towards the aluminum and it is like an off mode. So this is like an on mode and the other one is like an off mode. So we developed the band diagram, and this work was published in Organic Electronics. Similarly, when we try to make the derivative of cyclopropyl, carbonyl piperazine instead of the aromatic. Now, one of the group has reported that when we have phenyl carbonyl piperazine, molecule showed phosphorescence. Mostly, many of these derivatives exhibit fluorescence alone. Now, we tried to retain this carbonyl and substituted continuously the aliphatic moieties with a carbonyl. Now, the cyclopropyl and the cyclocarbonyl piperazine, and we substituted due to the extensive intermolecular interactions and the supramolecular assemblies, of course, along with the fluorescence, which is quite different at the ambient and the UV light, we could observe that the band gap was within the range to apply it for the photovoltaic devices. And we try to apply this molecule as a solar cell feature. So again, we took ITO-PET, quoted the BCCPDQ. It's a code for the cyclopropyl, carbonyl functionalized TCNQ, and then aluminum electrodes were coated. And we, took the SEM image, identifying all the layers of the substrate, ITO, our compound, and so on, and did the photovoltaic applications where the power conversion efficiency was calculated using the standard formula. And then we could observe that when compared to the direct standalone device, when we tried to incorporate titanium dioxide nanoparticles on the ITO, the efficiency increased 2.26%, which was 10-fold more than the pristine without TiO2 nanoparticles. Though the efficiency, I agree that it's not that high, but when compared to the other organic molecules where bulky moieties were used, like pentacene, or blended with several other layered structure, our molecule shows an appreciable efficiency, because I didn't put the data here, but because we need to do furthermore studies on this aspect. But other molecules have shown around 0.56 or 1.5 and so on. So 2.26 is, an encouraging result, which we are continuing it further. And we proposed a band diagram where basically we try to choose the, electrodes in such a way that the band gap of the ITO should be less than, should be more than TiO2, and the coated material, whatever we design, that band gap should be again less than the TiO2. This is the fabrication technique which we use for photovoltaic applications. And obviously aluminum usually has the 4.3 electrode, and very good conductor, so it is mostly used in these devices. So we studied again the bending conditions like the previous molecules for the resistive switching devices, and we published just last week in Material Advances. So we have also tested to retain this device, like keeping it under the illumination for about 80 hours to 100 hours, and there was no deformation or anything. So we say that we are actually taken up towards the sustainability of fabricating devices with organic molecules which are biodegradable. And apart from that, when we try to make derivatives with the fragments of the anti-cancer drugs, not the core molecule, but a small side chain, and when we try to react with the TCNQ, interestingly, in one step, we could generate the TCNQ derivatives, which has shown appreciable anti-cancer activity. And for the first time, we have discovered the first generation anti-cancer drugs based on TCNQ molecules. And this was actually published in the Chemistry Select recently. And later, when we tried to again come back to the spacer moiety without an heterocyclic, like we did for solar cell, retaining the hydroxyl moiety, interestingly, we found that it has formed a cyclase derivative rather than either mono or disubstituted. And when we tried to functionalize it further, usually people working on the TCNQ molecules, they stop the derivatization up to cyclization or mono or di. But we try to further functionalize it, and when we functionalize this, we could get completely a benzene derivative where the cyclase ring has opened up. And interestingly, this followed the mechanism of Wills-Meyer pathway. I didn't include here, similar to the Wills-Meyer reagent. And then we found that contrasting optical properties were observed in the open chain benzene derivatives and the zwitterionic molecules. So with this, we could convey that simple benzene derivatives of appreciable fluorescence and even the enhanced fluorescence in solutions could be obtained, so that we can apply them for bioimaging, because the cyano is safe in the body. I mean, it will easily break, and there are no negative effects of using these molecules for biological applications. And when we try to functionalize the TCNQ with completely ethylene and a linear chain molecule, with this simple reaction, we could generate a blue emissive material rather than the red or green. So all this is due to the simple interactions that happens in the solid state, which we come to know through crystallographic studies. And not only that, this compound was surprisingly the highest quantum yield in the solids that were reported among these TCNQ derivatives. It's a very easy reaction. At 70 degrees, we take the comparative amounts of amine, which is quite safe, a linear aliphatic amine, and we could develop a blue emissive material. And this work we published in Journal of Fluorescence. And this is the continuation of the cyclase molecules, which I have shown that it follows the Wills-Meyer reagent. And the interesting aspect was that based on the hard soft acid-base concept, we have proposed the mechanism where...
sorry to interrupt you, ma'am.
Yeah.
Maybe we are going out of time, ma'am.
Yes. Can I take a couple of minutes? Yeah, I'll just fine. So substitution at the delta minus carbon has not been observed till to date, and due to the generation of the in situ in a one-part Wills-Meyer reagent, this could attack at the delta minus carbon, and it could generate the aromatic species. So this was a new mechanistic pathway for generating aromatic, amides from the TCNQ derivatives. And here the role of twist angle also played a significant contribution. And this work we have, published in the New Journal of Chemistry. I'll take only a couple of minutes to just conclude the talk. That
32 now. Yes, ma'am. Yes, ma'am. Please.
Just a couple of minutes. Can I take?
Yes, ma'am.
Because I'll just tell the highlights.
Yes, ma'am.
From the small molecules, when we move to the polymers, we focus on polyaniline, which is a very simple water-soluble polymer, and it can be fine-tuned into various electronic. Now, when we try to blend this polyaniline with or carboxymethyl cellulose, different morphological features can be observed. We can generate voids in the templated polymers, we can get needles or the rods. So the interesting aspect is that the inherent property of the templates would try to organize the polymer chains in a better way, because initially polymer chains are coiled and it is difficult to orient. But the electron donor and acceptor, due to the pi stacking, they try to align the polymers in the linear chain. So we try to make several polymer blends, and then we could get trisodium citrate processed polyaniline as a high tensile material, which we tested in our laboratory by using the texture analyzer machine. And this was showing a very good breakpoint, a very good elongation when compared to pure polyvinyl alcohol or pure polyaniline. So processed polymers have actually developed a transparent green polymer having very good mechanical strength. So I would conclude my talk, though I'm not projecting the slide here, that the simple fine-tuning of the intermolecular interactions can lead to the development of materials starting from the simple molecule, provided we have the design aspect by looking at the literature. And then from simple small molecules, we have developed the semiconducting, optical, switching memory devices, solar cells, and a very good tensile polymer, which is based on the polyaniline. So small molecules were based on tetracyanocyanidimethane and TTF, and the polymers was based on basically polyaniline because it's a water-soluble polymer. So thank you very much for giving me some more time to conclude rather than stopping it abruptly. So I first of all thank the funding agency, DST, under fast track scheme, SERB, CRG, and then our institute also gives us sufficient amount every year to carry out our research. We have a very good central analytical lab facility where all the equipments are present, and I welcome you all to, if you have any samples, you can approach. And I thank collaborators from the EEE, where we try to optimize the data related to the solar cell and switching device application, and we try to come with some mechanistic pathway. And beyond this, I first of all feel very happy to give a talk at the KOTI Women's College, because I have been hearing it since long time, and many of my friends have been our students we have in our department also. So I thank Dr. G. Vijayalakshmi for contacting me and giving me an opportunity to invite for giving the presentation, and Dr. V. Shashikala, along with the Vijayalakshmi, who has been an active participant, Sir Vijulata Madam, who is our senior in HCU, we know her well. And I thank all the organizing committee members, because you have spent a good ample of time, I hope about 1 month ago, and congratulate you all for conducting this, and wish that many more such come up from the, especially women colleges. So these are my students, and Anwar has submitted the thesis, and hopefully he'll be having his viva within a couple of weeks. Hemabindu is working on rhodamine, I have not discussed today. And Pawan and Shiv Ganesh work on the separation of impurities in active pharmaceutical ingredients. So overall, we join together at the material devices fabrication. So I would like to thank one and everyone, and I welcome you all to the chemistry department and the campus, BITS Hyderabad. Thank you.
Thank you, ma'am. This session is now open for questions, if we have any. Actually, ma'am, we had an opportunity to visit your BITS Pilani Hyderabad campus, and I should say that you have a wonderful campus, ma'am. It's very beautiful.
Thank you. Thank
all
you.
the classrooms and all were too huge for us.
Yes.
I hope other women's university also gets such an infrastructure.
Thank you. Yes, yes.
We are hoping for that, ma'am.
Yeah, because we have a lecture for 350 students at a time in
Yes,
1 hour.
we were there in one of the lecture halls also.
Okay. Thank you.
Thank you so much, ma'am, for joining us.
Thank you.
Shall I propose vote of thanks, ma'am? Vijayalakshmi, ma'am?
Yes, ma'am. Yeah, please.
Ashwini,
Just
ma'am,
a formality, ma'am. But we would never like to leave you and go after such a wonderful lecture on molecular materials.
Thank you. Thank you.
From the organizers of the 2-day international conference and the chemistry department of University College for Women, KOTI, I would like to extend a heartfelt gratitude to you, ma'am, for being with us. You have explained very well the applications of molecular materials, the uniqueness, the fabrication into different optical and electronic materials. Then you went on elaborating about the usage of materials into different resistive switchings, then solar cell applications. And I really appreciate that you are working on conducting materials wherein you don't have metals.
Yes,
So
metal-free, solvent-free.
Sustainable development which you are doing.
Easy
It's very
processability.
apt for our seminar.
Thank you. Thank you,
so
ma'am.
much, for being with us.
Thank you, madam. Thank you so much. Thank you, one and everyone.
Thank you, ma'am.
Thank you, Dr. Jayanti, ma'am, for your excellent presentation, for your kind time and sharing your research work with all of us. It's very, very inspiring.
Thank
and
you.
Overall, your invitation to us to approach you and your organization, it's really heartwarming to us, ma'am, and especially
Please
when
come.
we are looking at the facilities.
Yes.
It's a very good invitation, ma'am, for us. So definitely we would like to collaborate with you, ma'am, in future for various academic as well as research ventures.
Thank you. Please, I really welcome you all. Please
Thank you
get
so
in
much,
touch, and
ma'am.
thank you once again.
Thank you, ma'am.
Thank you.
I now hand over the session to Srivalli ma'am and Amina ma'am.
May I leave, madam? Dr. Vijayalakshmi, madam?
Yes, ma'am. Yeah, please, ma'am. Ma'am, I request you to kindly join us for the valedictory session, ma'am,
Sure,
at
sure.
3:40 p.m.
Sure.
At your convenience, ma'am.
Yes. Sure. Thank you.
Thank you, ma'am. Thank you so much, ma'am.
Thank you
for being here.
Good morning to this is Dr. Srivalli. Ma'am, can I start the technical session, ma'am? Vijayalakshmi, ma'am?
Yes, ma'am. Please, madam.
Okay. Thank you, ma'am, for giving me this opportunity. I would like to invite Dr. Vijaya Charan, madam, for the technical session 3, where madam is working as professor at Department of Chemistry, University College for Science, Usman University. Her academic qualifications are MSc Chemistry and Inorganic Chemistry with B.Ed and PhD. She has 21 years of teaching experience and 22 years of research experience in inorganic chemistry. 10 students are pursuing PhD under her guidance. She has published more than 20 research articles in national and international journals. Her area of research work is synthesis of catalysis, structural, phytocatalytical, magnetic, electrical transport properties of nanomaterials and study their characterizations and applications. She had presented papers, posters at various national and international seminars, conferences, and workshops. She organized workshops and seminars. She completed 2 minor projects. Her academic administrative achievements are: she was the head of department of University College for Women, member of Board of Studies for Chemistry in Women's University College for Women, and many more. She is a life member of Indian Science Congress Association, India, and a member in American Chemical Society. She received Seva Ratna Award for her services and Best Teacher Award by Indian National Congress Society in 2021. I welcome Dr. Vijaya Charan, madam, for the technical session.
Ma'am, I'll
Thank
take
you,
2 minutes,
Srivalli,
ma'am.
for the kind introduction.
Vijaya Charan, ma'am, I'll take a minute here, ma'am.
Yeah, sure, madam.
At the outset, ma'am, I would like to thank you, ma'am, for your kind acceptance of our invitation, ma'am, and to be present here in the conference. Thank you so much, ma'am, for your time. On behalf of Department of Chemistry, University College for Women, ma'am, I would like to extend a warm welcome to you and heartfelt thanks to you, ma'am, for
My
this
pleasure,
opportunity
ma'am,
to us.
always to be here. Thank you so much.
Thank you, ma'am. Thank you so much, ma'am, for joining us.
Yeah.
Over to you, ma'am.
Yeah, thank you. So,
yes,
will we start now? Like all the participants are ready now?
Yes.
Yes, ma'am. Okay,
So-
now I would call participant number OP33, Harilal from School of Chemistry, University of Hyderabad, India.
So
to
one
give
second,
his,
can I give one instruction to the participants?
Madam, this is Harilal.
Like,
So can I share my?
one second.
Yes, ma'am.
one
Yes,
second.
ma'am.
Yeah, please. 1 second, please. I hope you're all aware of the instructions of the presentations, and you shall be evaluated based upon the novelty. I think you know everything, and the way how you're going to present, and the time bound is also very, very important. And finally, you have to give the clarity of your research work in your time period. And based on that, your evaluation will be done. Okay. So all the best. Now you can start now. Okay.
Shall I share?
Harilal, sir.
Hi.
Yes,
madam,
yes, sir.
Shall I share my slides?
Yes, sir. Yes, sir.
Just a minute, madam. Now it's visible, madam. Hello.
Sir.
No,
sir.
it's not visible.
Sir.
Sir, kindly share, sir. Share the screen.
Yes, I am trying.
Share the screen, sir.
Sir, are you getting an option?
Madam, that I am sharing that, but unable to do that. Let's try. Can I log out and can I again relog out? Let's try once more because I am not able to sharing actually. That's why.
Are you getting the option, sir?
Yes, sir. Option is showing.
Okay.
Now, madam, anything is showing?
Yes, sir.
Can I help? So, madam, say I am doing like.
Sir, right now, sir.
No.
We have a green color option, share screen. So if you just click
Yes, that only I'm taking one.
You just click it and then it gets open. Then whichever you want to share, you can just select that one.
Here showing options, madam, like one participant can share at a time, multiple participants can share at a time. Advanced sharing options are showing like that. I am clicking one participant can share at a time.
No, sir. You just share screen and you have a share screen option on your screen, which is in green color.
Yes, that green color. Yes.
You just click it, then you can open.
Yes, madam. I am able to share now. Now, madam.
Yes.
Thank you very much. Sorry for the small disturbance. So, shall I start, madam?
Yeah, you can start.
Yes, sir.
So, good afternoon to everyone. This is Harilal from Sushajana Research Group, School of Chemistry, University of Hyderabad. My topic entitled is pyridine-based polybenzimidazole for the use in high temperature photonics and membrane fuel cells. So that polybenzimidazole is nothing but that is a aromatic heterocyclic conjugated chemical structure is called as a polybenzimidazole. So these polybenzimidazole structures are like that. Here what I am showing. These polybenzimidazole in the various forms, like for example in alkylation, if you do that, this one of the forms. So in alkylation form, so we can use this form in the fuel cell, water electrolysis, and flow battery, etc. And as well as in acid form also, we can you can also this material we can use in the fuel cell, hydrogen pumping, gas storage, and flow battery. And other application also, this material can be used in that aqueous solution and aqueous medium anion exchange form. So this is a material also we can use in the water electrolysis and flow back and by batteries, etc. So this is because of this material having high mechanical stability as well as chemical stability and mechanical robust also. So based on these properties, these materials are frequently using in this kind of application. So in this, so fuel cell is nothing but is the electrochemical device. In this device, so here I am showing the pictorial presentation of the electrochemical device. So electrochemical cell is nothing but it's combined the hydrogen, oxygen gases too with water as a byproduct, and it gives the energy. So that energy is coming is a very green. That is a very green. It is green energy for the society. It is a green energy. It is sustainable for the society. And it is in this electrochemical device, as a byproduct is the water. And here you see that in one side, if you pass to the hydrogen, and other side is the oxygen. These two gases are interact with the electrodes, that is anode and cathode. At anode, the hydrogen gas will split into hydrogen atom, and hydrogen as a proton, as in other node is the electron. The proton will through the membrane, it will exchange to, and it will reach its cathode side and interact with the oxygen, and it will give water. And the external circuit is the electron will pass to the external circuit, and it will generate the electricity. This is the simple phenomenon of the electrochemical cell. So in this electrochemical cells, various components are involved in that, and among that, the protonics and membrane is one of the component, and it is plays a very crucial role in for enhance the electrochemical performance of this material, this device. So in that, if protonics and membrane is the role is that to separate the anode and cathode, and to prevent the mixing of fuel gases, and to provide the proton conductive path. So for that, the protonics and membrane should have required characteristic properties like a high proton conductivity, long-term chemical stability, and it should be suitable at high temperature, as well as chemically, mechanically strong, and low cost, and really it is available in the market. So for that, I am here showing that nowadays the all vehicles are commercialized in the market as a fuel cell vehicle. So we know also recently our Honorable Ministry also, Minister the Nitin Gadkari ji also, he's now he travel in the electrochemical build up the car. So like that, the whole society as well as our modern society towards the sustainability, the sustainabilities are required. So that's why all governments and research scientists are focused presently in this kind of electrochemical cells. So in this we are targeting the polybenzimidazole materials because of the huge importance in the electrochemical fuel.
Excuse me, sir. You'll have 1 minute, sir, for interrupting. You're having last 1 minute, sir.
Okay, sir. Means now only started. Okay, I'll try to manage. So these are
wind up, sir, in 1 minute.
This is the polybenzimidazole material. So we can synthesize with various dicarboxylic acid with diamine in presence of solvent. So we characterize whole impact in the NMR proton IR, and we just simply showing here I am the polybenzimidazole how it are making, and this is see after the synthesized material looking like a fiber like shape PY/PBr materials. It is after that we dissolve this suitable. We choose the suitable solvent in DMSO and we cast it at high temperature at 100 degrees centigrade, and with beautiful membrane we got and flexible membranes. So these membranes we share the same morphology. So based on 15 PY/PBi, so these all novel polybenzimidazole are showing morphology like sponge kind of morphology. So with that, this morphology it is helpful for the absorption of the more phosphoric acid.
Sir, so your time is up, sir. Sir, your time is up. Sorry for interrupting. Your time is up, sir. 5 minutes is over, sir.
Conclude it. Conclude and then
concluded, sir.
Okay, sir. 1 minute, because that is 2-3 minutes. That is a disturbance happen. So okay, anyhow, I am trying to. So this is the acid loading. Because of the morphology of this novel type of polybenzimidazole, so it is absorbing more phosphoric acid, and it will giving the because of more absorption of phosphoric acid, it will giving the more proton conductivity this type of material compared to the piston PY/PBi. So finally, we take help up from Professor P.C. Ghosh from IIT Bombay, and with that, we set the real application whether these membranes are sustainable in the electrochemical cells or not, like that. So not. That's why we tested these membranes at a high temperature. So compared to the block 1 pristine with PY/PBi, so all pendant type PY/PBi, novel type PY/PBi membranes are high performance showing. So this is a summary of this project. So in this project, we synthesize various kind of dicarboxylic acid, and we targeted synthesis of various polybenzene, and finally we get the performance with compared to the pristine, we got high performance. So finally, I would like to thank my supervisor, Professor Tushar Jana, for his constant guiding, as well as my doctoral memoree and Dean School of Chemistry, and my collaborator PC Ghosh from IT Bombay, and my current lab and past group members who are working with me. And I would like thank you for UGC for fellowship, DSC for funding, and finally but not least, I my sincere thanks for the organizing committee who are organizing this wonderful event. Thank you, one and all.
Thank you, sir. Any questions from the audience? Madam Vijaycharam, any questions?
Yes,
Vijaya,
yes,
madam?
yes. Harilal?
Yes, madam.
What is the role of catalyst in a PEM fuel cell?
Madam, it will interact with the so it is the electrochemical reaction, it will enhance, madam. So this platinum, for example, platinum we are using in the electrochemical sense. So generally this is a interact with the hydrogen gases, and it will stick to hydrogen proton as a electron. So this is the role of this catalyst, madam.
So that you have missed out, because that is the main role of the catalyst, where it occurs at anode and cathode. Is it clear?
Yes, madam. Yes, but we are our interest is completely focused on membrane. So that's why we are highlighting that part only. So
what is the other name which is given for a polymer electrolyte membrane?
So we are giving that proton exchange membrane.
Okay, Harilal.
Proton exchange membrane, because it is in the acid media. So in acidic media, so it is act as a proton conducting. So that's why we are calling as a proton exchange membrane.
So one more question, Harilal. How does a PEM hydrogen fuel cell work?
Ma'am, 1 second, ma'am. Ma'am, 1 second. Swati, please mute, ma'am. Yeah. Madam, please continue, madam.
Yeah.
Madam, these type of fuel cells are generally already commercialized in the market, and huge reduce the cost of the system. So because of, for example, the membrane cost and the electrolyte means platinum electrocatalyst also, and assembling of the
Okay. We'll go with the second participant.
Second participant. It is J. Annapurna from University College for Women.
Yeah, you can.
Sir, please stop screen, sir.
Madam,
Harilal, sharing the screen, sir.
Harilal, please mute yourself.
It's okay, Harilal. Come on.
You please stop sharing your screen so that the others can share their screen.
Hello.
Stop sharing the screen. Hello.
Okay, madam.
Stop sharing your screen, sir.
Okay.
Ma'am, can I start, ma'am?
Yes, Annapurna, you can start.
Just a second, ma'am. I'm just starting. A very good afternoon to everyone. This is Annapurna from the Department of Chemistry, University College for Women, KOTI, Hyderabad. So my present topic is the analysis of the physicochemical properties of the multi-ingredient, multi-purpose floor, which is having an extended shelf life, which is useful for the diabetic and the pre-diabetic population. So my present work, in my present work, I would be discussing about the various different physicochemical parameters that we have tested in the lab, which will be showing that the multi-purpose floor, which is having a low glycemic index, it is also having an extended shelf life. So the carbohydrate, ma'am, are you able to see my screen, ma'am?
Yeah.
Next.
Has it changed, ma'am?
Yes, we are able to see, Annapurna.
So the carbohydrates, they are very wide.
Next. Go for the next slide.
The carbohydrates, they play a very vital role in the human requirement as an energy source. But since the diabetic people, they are deficient of metabolizing these carbohydrates, they have different types of disabilities, like for example, the obesity or the organ failure and all. So when the purpose of designing or the purpose of developing this multigrain atta or the multigrain function is nothing but it is used as a nutraceutical. The nutraceutical or a functional food. So functional food because it is having a function of reducing the glycemic index value. At the same time, it is also increasing the resistance of the person who is diabetic. So the methodology includes, we have procured the raw materials or the raw spices that are required for the multi-purpose atta. From in the multi-purpose atta, we have taken the wheat, ragi, maize, jowar, barley seeds, sago, soya, bengal gram, green gram, groundnuts, gingerly oil, cinnamon, turmeric, and ginger. So these all were being procured from the local markets of the Telangana, and all these raw materials, they were being macroscopically evaluated for the organoleptic evaluation, and then the sensory characteristics were being done. They were being rubbed, and then they were individually soaked, and then they were sprouted in order to make the powder, and this powder was being taken in the was being grinded. So the first test would be the total ash value. So the ash value, it is useful for determining the physiology. It can be of two different types: the physiological ash and the non-physiological ash. So for the next we have is the acid insoluble ash, so which is useful for detecting the presence of the inorganic salts. If any inorganic salts are being present, it can be detected with the help of the acid insoluble ash. Then the moisture content, a very, very important parameter. Since the food substances, they are present outside, when compared to the whole grain, the food substance or the flour, it is having more ability of absorbing the moisture. So therefore, it will be whenever any substance absorbs the moisture, the stability will be decreasing. Then the most important one is the alcoholic acidity value. So this alcoholic acidity value, it is helpful in knowing the stability of the sample. So as I said, as I said in the previous, in the introduction slide, that we have prepared a sample which is having an extended shelf life. So this alcoholic acidity value, it is helpful in knowing the shelf life of that particular compound. So for any food substance, the shelf life for any food substance to be used, acid value should be very less, so that, and this acid value goes on increasing upon storage. But for our sample, when we have stored it for a period of more than 2 years, even then the alcoholic acidity value has not changed, indicating that it is having a very high stability. So the alcoholic acidity value, it is measured by using a formula 24.52 AN by W, where A is the volume of the standard NaOH that we are using for the titration, and the normality of the sodium hydroxide that we have used is 0.01, and W is the weight of the weight of the flour which we have taken in the grams. So in the discussion, I would like to say that, because so many multigrain atta or multigrain flours are already available, so what would be our criteria for developing a new multigrain atta is, in this multigrain atta, we are having different types of we are having 4 different types of the flours, which are very, very good in the fiber, and also the beta glucan, proteins, and the enzymes, energy rich, good quality foods. So, and along with that, it is also rich in the minerals like the calcium, iron, magnesium, manganese, copper, and zinc, and also the antioxidants and the phytochemicals are also present, which are slowly and easily digestible. So, we are having also the spices like turmeric, cinnamon. So, the presence of these cinnamon and turmeric will be helping in increasing the stability or the shelf life of the sample. At the same time, we also have the fenugreek, which is being providing, along with the stability, it is also having the anti-diabetic activity. And one thing I would mention over here is the component present in the fenugreek, that is the ferulic acid. It is having the same binding site as that of the metformin. So therefore, it is understood that it is also having the anti-diabetic activity. And since the diabetes is not only confined to a specific age, so starting from very younger age to very older age, so when we are using this multi-purpose atta, we can make different types of the recipes, like for example, noodles. So children, they don't like eating some certain type of the foods. So when given in the form of the noodles or the pasta, they are they love them and they take it. And at the same time, when the person is critically ill and if he is not able to take the chapatis or the regular food, so at that time it can be given in the form of the soup.
Annapurna, just try to conclude.
And then it is also socio-economic, because we are taking only the components which are easily available in the market. And at the last, I would conclude that our present idea is, instead of using a tablet, or if it is better that we use a food substance, because always whenever a drug or a chemical substance is being used in the body, there is possibility of multiple interactions that have been taking place. So to prevent that, instead of taking a drug, it is better taking a food. So further, we would like to take up the preparation of the nanoparticles of these compounds, so that the ability of these, or the activity, anti-diabetic activity, and also the antioxidant activity, and the various different functions of these compounds can be increased. Thank you, ma'am. Last but not least, I would thank all the organizers, especially GVL madams and Alia madam, for giving me this opportunity for presenting my work. Thank you, ma'am. Any questions, ma'am?
Thank you, Annapurna. Any questions from the audience? Okay, Vijaya madam?
Yes.
Any questions from your side?
Yeah. So without taking drug, we can manage by taking this atta, this floor.
Ma'am, the thing is that we are working on it, ma'am. So we are included so many different types of the components. Like for example, we take the fenugreek seeds or the turmeric, and we also have taken the cinnamon. So all of them, they are having the anti-diabetic activity. So the thing is that we don't say that there is no chance that you have to use a tablet. But only thing is that, for example, if the father or the mother is having diabetes at the age of 40, so there is every chance that the next generation will also be having, or the chance is more for the next generation to have the diabetes. So by using this, we can prolong the time for which the diabetes can be attacked.
How are you going to increase the shell life of this?
Actually, I said, ma'am, we have taken the two compounds, that is the turmeric and the cinnamon. So these two are having the very good storage capacity, or they are very good relatives for the storage of the sample.
Moisture content is commonly required.
Mama, मैं सोने लगा, मैंने नहीं बिछाना.
Dr. Anupama, can you please mute yourself?
ऐसे बोलना.
Madam, Annapurna madam, and what is the moisture content which is commonly required for floors? How much percentage you can
Ma'am, this moisture content, it is actually a measure for, here we have taken it as a measure for the stability of the sample, ma'am. Actually, the moisture content, if it is less, then only it is preferable, ma'am, because as we store this, increase in the moisture content, because we are exposing to the, so therefore there is more amount of deterioration which can be taking place because of the moisture.
Okay, ma'am.
मैंने खा लिए नहीं, मैंने पहले ही इकट्ठे ले लिया.
Yes, madam, can I introduce the next participant?
Yeah, sure.
Next is Janvi Iyer from St. Francis College for Women, Hyderabad.
Good afternoon, ma'am.
Good afternoon.
Can I share my screen?
Yes, you can.
Ma'am, it shows that host has disabled participants share screening.
1 minute.
Are you getting this share option now?
Yes, ma'am. Ma'am, is the screen visible?
Yes, ma'am.
Yes, ma'am.
Okay. Good afternoon to everyone present here. I'm Janvi Ramesh Iyer, and I'm going to present a paper on 2D QSAR and molecular docking studies on isocombretastatin derivatives as microtubulin complex inhibitors, written along with Shrikant Shivan sir and Radhika Vendala ma'am. Combretastatin is a naturally occurring anti-cancer agent obtained from an African willow tree. Isocombretastatin is its non-natural isomer, and it has undergone several modifications to produce synthetic or structural analogs which were stable and had equivalent anti-tumor properties. These isocombratastatin structural analogs were used for the QSCR studies. They acted as microtubulin inhibitors and interacted with the microtubulin protein complex, which is a major cell cytoskeletal protein. This interaction led to destabilization of microtubules, resulting in cancer cell apoptosis. Methodology: ChemSketch was used. It is a chemical modeling program which was used to draw different molecules. A total of 101 inhibitory molecules were present, which had GI50 biological activity. GI50 indicates the concentration for 50% maximal inhibition of cell proliferation. The GI50 activity was converted to PGI50 activity by taking minus logarithm 10 of GI50 values. Next, the SMILE notation of molecules were uploaded in PKCSM, and the ADME and other descriptor properties of the molecules were obtained. The 101 inhibitory molecules were divided into test set of 38 molecules and training set of 63 molecules. The training set was subjected to the MLR analysis and 2D QSCR model development. The MLR, which was done using built QSCR software. The MLR analysis was carried out to determine the relationship among various variables. We take one dependent variable, that is the PGI50 on the y-axis, and several independent variables that are the descriptors on the x-axis, and we get an MLR equation. The test set molecules along with their ADME and descriptor properties were taken onto an Excel sheet where parameters like standard deviation, press, and cross-validation coefficient was calculated. The next step was docking. It finds the best fit or the preferred orientation between a ligand and a target protein to form a stable complex. Protein preparation was done using the Maestro-Schrödinger suite, and the protein was tubulin alpha 1B chain. The ligand preparation was done under OPLS3 force field. Grid generation was done using the GLIDE software, which specified the active and the binding site of the protein. Ligand docking was done to generate possible conformers for each ligand under standard precision mode. Results and discussion. The MLR equation was obtained by selecting various descriptors in a trial and error method till an appropriate equation was obtained. The descriptors selected were log P, surface area, water solubility, CaCO2 permeability, CNS permeability, molar refractivity, molar volume, paracore, index of refraction, and polarizability. An excellent MLR equation was obtained with a correlation coefficient R of value 0.905 and a regression coefficient Q2 of value 0.738. For model validation, the R square, that is the cross validation coefficient obtained from the test set of value 0.743 was compared to the Q2 value from the MLR. The R square and the Q2 had value above 0.7 and showed 70% correlation, which indicated it is a strong model, and the model was validated. Here we can see the correlation graph and the scattered plot. Docking results. Docking was carried out for all 101 inhibitory molecules, and the dock score ranged from -10 to -6. The dock score predicts the affinity between two molecules. Higher negative dock score is better as it corresponds to a stronger affinity between the binding of ligand and protein. Here I've mentioned few molecules with good dock scores. Here for molecule 29, we can see a dock score of -10.176. The NH group of the molecule interacts with the amino acid valine 236 position. Similarly, I've mentioned few more molecules. Conclusion: the combined ligand-based and structure-based drug designing computation approach helped in getting an insight into the structural basis of discovery of novel lead microtubulin complex inhibitors. 2D QSR analysis helped in understanding the structural activity relations of compounds, and good MLR equation was obtained. And the docking studies further improved the understanding of intermolecular interactions. The novel molecules identified can be further used in designing a novel or potent microtubule inhibitor molecules. Thank you.
Thank you for your presentation. Any questions from the participants? Okay, Vijaya madam, any questions from your side?
Yes, madam. What's that name? Jahnavi.
Yes, ma'am.
Yeah. Do structurally similar molecules have a similar biological activity?
Yes, ma'am. Actually, structural analogs are formed by only changing different atoms or atoms or groups at different positions, but they retain their ADME properties. The absorption or metabolism and how they work, they retain the properties.
Your answer is that they will have the same thing, isn't it?
Yes.
Every structurally similar molecule may not have the similar biological activity.
No, biological activity may not be same.
That is
I was
the
talking with
question
respect
what
to the
I'm
ADME
asking
properties.
you.
Yes, ma'am, biological activity will differ.
So 2D QSR is different with that of the 3D QSR, isn't it?
Yes.
So you have done only 2D QSR.
Yes, 2D QSR and the MLR analysis.
What is the main thing it is going to give, the information from the 2D QSR?
From 2D, here we try to understand how the PJ50, that is the biological activity of the molecules, and how it interacts with the various descriptors or the variables that we have selected. So the biological activity will get affected by these descriptors. So it is a correlation analysis. So we try to understand how these two variables are correlated to each other. And here we got a correlation coefficient R, Pearson's coefficient R of value 0.905, which shows that there is a high rate of correlation. It is a positive correlation. So the biological activity of the molecules is changing with respect to the variables or descriptors that we have selected. So that is what we mainly understand from the MLR analysis.
Okay, ma'am.
Thank you, ma'am.
Yes, ma'am. Can I introduce another participant?
Yeah, sure.
It's OP37 K. Sarita Rani from Government Degree College, Medak. K. Vinuta.
Yes, ma'am.
You can start your presentation.
Hello. Yes, ma'am. Good afternoon, everyone. Myself, I'm Vinuta. I'm going to give an oral presentation today on the topic Ensemble Pharmacophore Meets Molecular Docking, a novel screening approach for the identification of beta tubulin inhibitors. I'm doing my PhD under the guidance of Professor M. Vichilata ma'am, who is the principal of KOTI Women's College. Let us begin with the introduction. As we all know that malignant cancer is one among the serious life-threatening diseases. One of the important approaches for treating cancer is the destruction of microtubule assembly. As we know that microtubules play a key role in maintaining various cellular functions like cell signaling motility, cell proliferation, maintenance of cell morphology, and intracellular transport. In the present, on the other side, we have added dithiocarbamates have exhibited colossal pharmacological properties.
Excuse me, lot of disturbance is coming.
Especially the sulfur atom with dithiocarbamates possess a strong nucleophilic and redox properties. Because of this, we have selected dithiocarbamates also to be added in the designed molecules. In the present study, we have developed a pharmacophore model, that is the 3D QSR model, and molecular docking studies and tubulin inhibitors were developed. See, this is the methodology which we have used in carrying out the curve. Firstly, the X-ray crystal structure of the protein, that is beta tubulin protein, having the PDB ID 1SAO selected, and it was subjected to the protein preparation using protein preparation wizard available in the Schrodinger suite, and later it was subjected to minimization, and receptor grid was generated by using the glide module available in Schrodinger. Then on the other side, we have selected about 94 inhibitory ligand molecules from the literature, and the corresponding IC50 values of them have been converted into PIC50 values. And we went on for developing the pharmacophore model for it through a phase module available in Schrodinger. In order to build a 3D QSR model, we have the 5 different steps to be followed. One includes development of pharmacophore sites and create pharmacophore, find common pharmacophore, then score hypothesis, and finally build QSR model. After that, we have finally achieved in building the 5-point common pharmacophore hypothesis. And using that pharmacophore hypothesis, we have screened about 2 databases consisting of whatever database consisting of 95,000 compounds, and SNX energy database consisting of 91,423 compounds. Later on, these were screened with the hypothesis which we got, and finally we have achieved in retrieving about 5,082 hits from whatever database and 5,958 hits from SNX. And finally, the top 2% were subjected to SP docking and XP docking. Finally, we have been able to retrieve 152 hits from whatever database and 120 hits from SNX. Finally, the top 10% ligands which were retrieved were subjected for docking interaction analysis using LIDs. This is the statistical hypothesis of the results of the top 4 pharmacophore hypotheses which have been obtained. Among that, the first one, which is shown in red color, that is AAHRR. It is defined as the best pharmacophore model which we have generated. These are the corresponding bond angles and as well as bond distances of the corresponding hypothesis which we have got. This is A1, A1, R1, R2, and therefore the 5-point common pharmacophore hypothesis is AAHRR. And this is the 3D QSR visualization of the best active compound from the ligand molecules which we have retrieved. That is the 92, the compound ligand molecule 92 is considered as the best active molecule since it has the greatest PIC50 values, in which the first one, the green cubes represents the hydrophobic favored regions and the violet cubes represents the hydrophobic unfavored regions. And this the yellow cubes represents the hydrogen bond acceptor groups and the orange cubes represents the hydrogen bond donor groups. And this is the scatter plot which we have plotted by taking the expected PIC50 values as well as the predicted PIC50 values of the training and the test set compounds. Among the 90 inhibitor molecules which we have taken, 47 were divided as test training set molecules. And these are the corresponding dog scores of the derived hits obtained from SNX synergy database and whatever database, and these are the newly added by the pyrrolopyrimidine, all of which are having the highest dog scores when compared to the best active molecule in the set. And these are the ligand interaction diagrams of all the SNX hits as well as the retrieved hits of our database and the newly designed compounds. Among this, the A9 SNX hit has more than the best active compound has only one hit, whereas one interaction, one pi cationic interaction with lysine, whereas the remaining all others showed exhibited more than 2 interactions. These are the whatever data.
Vinita, just try to wind up. Your time is up. Okay. Just try to wind up.
These are the newly designed molecules which we have obtained. This is the conclusion. A 5-point common pharmacophore hypothesis was established by taking 90 inhibitor molecules and the retrieved hits were walked into this active site of PDP ISP. The results illustrate that the compounds retrieved from SNX synergy database A9, A4, A5, A10, A11 hits from whatever database O5, O11, O2, O3, O12, and newly designed databases, since this is consisting of a pyrrolopyrimidine nucleus in accommodation with the dithiocarbamate side chain, the interactions were found to be more when compared to the best active molecule. So thereby, as these are having the specified pharmacophore features, they could act as potent inhibitors against beta-tubulin molecule. Thank you, ma'am.
Thank you, ma'am. Any questions from the participants? Vijay Sharan, madam, it's open for you.
Yes. Vidita, your presentation is very fast because time bound, I think.
Yes, ma'am.
So actually, I have a question for you. What type of interactions generally a ligand can have with a protein?
It can have hydrogen bond interactions, hydrophobic interactions, pi-pi interactions, pi-pi stacking interactions, pi-cationic interactions, etc.
Okay. Its binding affinity and binding energies are same?
Dog score values are different from binding energy values. Binding energy values actually, the lowest, the more the negative value, the highest the binding affinity will be present with the protein target.
Okay, Vinita. Okay.
Thank you.
Okay, ma'am. The next participant is OP37 K. Sarita Rani from Government Degree College, Medak.
Yes, ma'am. I'm here, ma'am.
Yes, ma'am.
Srivali, madam, what about OP36?
OP36, she told that she won't be giving her presentation, ma'am. She had WhatsApped me that she won't be giving because she is having some urgent work. So she won't be giving her oral presentation. She had messaged me, madam.
Hello, ma'am, am I audible, ma'am?
Yes, ma'am.
This is OP37, madam. Shall I start?
Yes, OP37. Yes, ma'am.
Okay, very good afternoon to one and all. This is Sarita Rani, Assistant Professor of Chemistry from Government Degree College, Medak. Today, my topic is on synthesis of sulfur-doped graphene and its electrocatalytic application for hydrazine determination. Ma'am, is my slide visible now?
Yes, it's visible.
Okay, ma'am. So this is the schematic diagram, how we have synthesized this sulfur-doped graphene. So the precursors for the synthesis is graphene oxide and benzene disulfide. And the procedure what we have opted is microwave-assisted solvothermal. So the sulfur-doped graphene, which was synthesized, it was used for the determination of hydrazine. And this is how the sulfur-doped graphene was synthesized. We have taken graphene oxide in ethanol water in 10:1 ratio. And then we have added benzyl disulfide ultrasonicated for 1 hour. And then microwave irradiated for 6 minutes. So it's a fast process where after doing
Madam, you are only the first. Sorry, ma'am, for interruption. Only your first is presentation. The other slides are not visible, ma'am. Just slide down, ma'am.
Oh, they are not moving, ma'am?
They are not moving. Just. Yes, yes, ma'am.
What about now, ma'am?
Yes, now it's moving.
Okay, shall I proceed like this, ma'am?
Yes, you can proceed.
Yeah, thank you. So after preparation of this sulfur-doped graphene, we have we have done characteristic studies by TEM, SEM, and SAD. So this is the TEM images where we can confirm that we have obtained a wave-like morphology of this sulfur-doped graphene. And the spacings, that is, we have found the layers where the distance between the layers was around 0.34 nanometers. Then even for the SEM analysis also, we can see that there's a wrinkled structure where we can say that this wrinkled structure might be due to this sulfur heterodoped onto the graphene. And this SAD pattern shows that the formed synthesized it is having crystalline nature. And we also have thickness. The thickness of this sulfur-doped graphene was found to be around 8 nanometers. Then the characteristic study was also made by the FTIR and Raman as well as XPS. So this is the FTIR where we got a prominent peak at 2361 centimeter inverse, which shows that it might be due to the skeletal vibrations of SH bond. And this is nothing but this bond which is sharp at 3500. This is due to OH stretching mode. Here we can see the string peaks, which are around 1500, almost nearly 1400. So this is due to S double bond O stretching frequency. And even the Raman spectra, if you look at this, we got peaks, that is, this is D band, this is G band, this D band around 1330 centimeter inverse, and G band was found at 1580. Whereas this peak, which is at 2700 centimeter inverse, this is due to 2D band of sulfur-doped graphene. So by this analysis of that is FTIR and Raman, we can say that the sulfur has been successfully doped into the graphene. And this even by the XPS spectra also, we find a peak, a prominent peak at 162, which also shows that the doping has been done. So by taking that sulfur-doped graphene, which we have taken onto this glassy carbon electrode, this is a 3 electrode system. This one is acting as a working electrode, reference electrode. We have taken a silver chloride in 3 molar KCl, platinum foil as counter electrode, and electrolyte used as phosphate purple solution. And we have done the analysis by CV, that is cyclovoltammetry, where you can see the curves here. This black one is without sulfur doping, whereas this pink one is with the sulfur doped graphene. So here we have seen the current, that is peak intensity or peak current has been increased. And this is EIS experiment where the resistance was also very less. So with this, we can say that the charge transfer has been taken very fast, and then it is successfully used in the oxidation of graphene. Then this is again the potential, where we have changed the potential, and you can see this black curve where this shows the peak, high peak in intensity, anodic peak current is more, And by changing the potential also, we can see at around 0.31 volts, the high peak current has been detected. Then even chronoamperometric studies where we have added this hydrazine in successive addition, where we can see that it is showing a peak that is increase in the peak current as we go on increasing the concentration. So this is, it is showing a steady increasing.
Excuse me, ma'am, sorry for interrupting. Try to wind up.
Yes, ma'am. So this, what I want to conclude is the sulfur doped graphene is very useful. It is very selective. It is very sensitive, and it is very economical in the determination of this hydrazine. So in presence of other impurities also, we can detect hydrazine, and these are the recovery rate where it is almost above 99% in all the various samples that we have done. So this is the conclusion where the sensitivity was found to be 0.22 and detection limit is 0.25 micromolars. Thank you, ma'am.
Thank you, ma'am, for your presentation. Any questions from the audience? Vijayacharan, madam, next.
Yes,
it's to you.
Yeah. Sarita Rani?
Yes, ma'am.
Okay. So you have doped, sulfur doped graphene, na?
Yes, ma'am.
So how can you compare the activity with that of NS co-doped graphene? So instead of sulfur, we can also
yeah, we have nitrogen and boron.
Nitrogen as a donor and co-doping of this on graphene.
Yes.
So how can you say that which one is more showing more activity for the application of hydrazine? Application for hydrazine.
Yeah, yes, ma'am. That we have actually compared with the literature, madam. So for this, as I said, that here the limit of detection was very 0.25, whereas with other doped heteroatoms, it was just 0.5, madam. So, and that too, the response time is very less. That is within 3 seconds, we can easily get the result, ma'am.
So you are concluding that your sulfur doped is giving higher things,
higher result from. I did add that slide because the limit of slides is less, no, ma'am. So we have that comparative chart also.
Okay.
Okay, ma'am. Thank you, ma'am.
Okay.
Yes.
Thank you.
Vijay ma'am, can I call the next participant?
Yeah, sure.
Pooja Bajaj from IICT.
Yes, ma'am.
Yes.
You hear me?
Yes, you're audible now.
Are my slides visible, ma'am?
Yes, yes, your slides are visible.
Well, a very good afternoon to one and all. Myself, Pooja Bajaj. I am going to present my work entitled Mexene WO3 Composites for Gas Sensing Applications. This is the outline of my presentation. Mexenes are two-dimensional materials. Two-dimensional materials have captured the imagination of the researchers because of their outstanding properties. After the first discovery of a 2D material graphene, many other materials have been discovered like mexenes, xenes, transition metal dichalcogenides, and nitrides. Mexenes are synthesized from MAX phase precursors, which are ternary metal carbides having layered hexagonal structure. The general formula is Mn+1AXN, where M stands for transition metal, A is group 13 or 14th group element, and X is carbon or nitrogen. Though mexenes have very high specific surface area, there are challenges that they are highly unstable and they get easily oxidized when exposed to the air. So to overcome these challenges, we have made composites of the mexene to attain the stability. The precursor we use is Ti3AlC2, titanium aluminum carbide. To etch the mexene, the etchant used here is LiF plus HCl. The aim is to remove the aluminium, resulting in the sheets of the mexene having the composition Ti3C2TX, where TX stands for the termination groups. We make the composites by using sodium tungstate dihydrate precursor, resulting in the WO3 particles getting interspersed between the layers of the mexin, forming the composite WO3Ti3C2. The formation has been confirmed using XRD and FESM studies. From XRD, two important peaks to be noticed are the one at 39.1 degrees gets eliminated, and the other one is the formation of a low angle peak, which confirms the layeredness of the material. So the disappearance of the 39.1 peak and the formation of a low angle peak confirms the formation of Ti3C2TX. Even the composites were confirmed using XRD studies with a weight ratios ranging from 1:0.5 to 1:10. We can see that with increase in the concentrations of the weight percentages of the WO3, the WO3 peaks become more and more dominant. The morphology of the material was confirmed from the FESM studies. From FESM, we can see that the layered structure of the mexins has been formed. The layeredness was also observed in all the four composites except for the D. Because of the higher content of the WO3 mask up the layer of the mexins. The stability of the material was confirmed from the TGA studies. From the TGA thermogram, we can see that the mexins have gained the weight in the presence of the air, whereas the weight gain is relatively less when compared to the pure mexins, confirming the relative stability of the composites when compared to the pure mexins. We have chosen gas sensing studies as an application for this material. Gas sensors are a boon not only in detecting the hazardous gases, but also in preventing the disasters. Hence, these 2D materials are a good candidate for application in sustainable energy devices like gas sensors. We have done the sensitivity studies against the temperature from RT to 100 degrees Celsius. So we can see that for 1:1 composite, the sensitivity is found to be 96.5%, which is highest amongst all the composites, and then it decreases. The sensitivity again at higher temperature increases. We attribute that the sensitivity at higher temperature could be because of the WO3, and at lower temperature it is because of the mexins. The test gas we have chosen here for the sensing is ammonia. The stability of the material was further confirmed using XRD and FESM studies. So after the 100 days of the synthesis, we could see that the peak positions in the XRD remains the same, and the layeredness of the material is not lost even after the 100 days of the synthesis. The sensitivity was also carried out, and it was found to sense 89% even after the 100 days. I conclude. From TGA, we can clearly see that the composites are more stable when compared to the pure mexins. From the gas sensing studies, we can see that at the lower temperature, the sensing is because of the mexins, and at the higher temperature, WO3 is playing a dominant role. Amongst all the composites, 1:1 composite is having higher sensitivity when compared to other composites. The significant finding from this study is that the sensitivity is maintained even after 100 days, confirming the composite stability when compared to the pure mexins. I thank Principal Ma'am, Professor M. Vijayalata Ma'am, Head of the Department, Dr. G. Vijayalakshmi Ma'am, for giving me this wonderful opportunity. Thank you.
Thank you, Pooja. Vijay Madam, you can ask the questions.
Pooja?
Yes, ma'am.
Why you have chosen WO3? Why not SNO2? Because it is also a very good gas sensing agent, isn't it?
Yes, ma'am. Ma'am, WO3 is my first work, and my second work going on is with SNO2 only. Interestingly, the results with the WO3 are better when compared to SNO2, but I am even working on SNO2 mexins as my second work, ma'am.
So will you please give few examples of gas sensing materials like which are falling under this? You have already searched the literature, isn't it?
Yes, ma'am.
Can you give few examples of gas sensing materials?
Okay, you want me to tell the name of the sensing materials?
No, what are what are the materials which will fall under this, which are better suitable for gas sensing studies?
Yeah, I can say that amongst all the materials, 2D materials have got very good sensing results when compared to the 3D materials like TiO2, SNO2, ZNO. 2D materials like graphene and MXenes are surpassing those results, and the research is still incomplete. MXenes is very new material. It has been discovered in 2011. So for that reason, I have chosen this topic, and a lot of research has to be done on this particular material. Yeah, it's 2D material which shows good gas sensing than compared to 3D materials.
Okay.
Yes, ma'am.
Yes. Ma'am, can we go to the next participant?
Okay.
I next call Kalyani Kumari from University College for Women, KOTI. If not Kalyani, I think Rupashri Madam also is there. Rupashri Madam. Kalyani Kumari. Kalyani Kumari. Rupashri Madam. Vijay Madam, can we move to the next participant?
Yeah, ma'am. Yeah.
Okay, the next participant is Chinnari. Her OP 41.
Yes, ma'am. Am I
Chinnari.
audible?
Yes, yes, you are audible. So she is from Andhra University, ma'am. Okay, you can continue with your presentation.
Yes, ma'am. Ma'am, is my screen sharing?
Yes, ma'am.
Is it visible properly?
Yes. Yes, it's visible now.
Okay. Is it visible properly, ma'am?
Yes, ma, you can carry on.
Okay, ma'am. Okay, good afternoon to respected ma'ams and everyone. I am Chinnari Lekkala, research scholar under the guidance of Dr. V. Siddhaya, Associate Professor, Department of Organic Chemistry and FDW, Andhra University, Visakhapatnam. I am going to my work. An efficient synthesis of 2-MnO5-phenyl 1,34 thiodiazole from phenylacetic acids and thiosemicarbazide by a copper catalyzed oxidative decarboxylative cyclization. Generally, 1,34 thiodiazole derivatives have been elicited interest in medicinal chemistry and agriculture fields as herbicides and bactericides. There has been intense investigation of different classes of thiodiazole compounds such as 1,2,4 thiodiazoles, 1,2,3 thiodiazoles, 1,3,4 thiodiazoles, many of which possess extensive pharmacological activities. Among them, the compounds which are having 1,3,4 thiodiazole nucleus are known to exhibit biological activities such as antimicrobial, antifungal, antidiabetic, anti-inflammatory, anti-leishmania, anti-tuberculous, anti-cancer, anti-HIV, antioxidant, carbonic anhydrase inhibitory activities. Despite their potential applications, only a few approaches are available for the synthesis of 2-MnO5-phenyl 1,3,4 thiodiazoles. Generally, these compounds are synthesized by the reaction of thiosemicarbazide with aldehydes or carboxylic acid derivatives. However, these methods have some limitations as host conditions. Therefore, facile and convergent approaches for accessing an array of 2-MnO5-phenyl 1,3,4 thiodiazoles are highly desirable. Herein, we demonstrate a simple and efficient protocol for the synthesis of 2-MnO5-phenyl 1,3,4 thiodiazoles from phenylacetic acids and thiosemicarbazide via copper catalyzed decarboxylative cyclization in presence of copper iodide as a catalyst, oxygen as an oxidant, and potassium carbonate as base at 120 degrees for 4 hours. This is my reaction scheme. We are used different phenylistic acids with thiosemi-carbazide under copper catalyst, copper iodide and oxygen base and DMF at we got up to 93% of fields. We used many different catalysts or oxidants or base or solvents. We finalized that copper iodide is acting as a good catalyst, and oxygen is working as a good oxidant, and we demonstrated different bases also, like sodium carbonate, cesium carbonate, potassium carbonate. Among them, potassium carbonate is working as a best base for this reaction. Also solvents like this, we used copper catalyst mole percentage also. We finalized that 20% of mole, 20% of moles is good for this reaction, and different derivatives as we monitored up to trace of amounts to 93%. In conclusion, that we have developed a simple and efficient protocol for the synthesis of 2-MnO5-phenyl-1,3,4 oxide diazoles from the thiosemi-carbazide and aryl acetic acids via copper catalyzed decarboxylate to cyclization and DMF of 120 degrees for 4 hours under oxygen atmosphere. This protocol involves oxidative decarboxylation of aryl acetic acids followed by oxidative functionalization of imine CH bond. In this reaction, various aryl acetic acids were well tolerated and provided 2-MnO5-phenyl-1,3,4 oxide diazoles in good yields. Uses of easily available starting materials and substrates, operationally simplicity, avoid the using of expansive ligands are the advantages of this methodology. Thank you, ma'am.
Thank you, ma'am. Ma'am, Vijay Charan, ma'am.
Yes. Chinnari?
Yes, ma'am. Yes, ma'am.
So have you analyzed, like characterized your samples by any spectral things?
Yes, ma'am.
But you have not put any slides related to that. Huh?
Okay.
Any spectral slides are not there, and you have not explained any one compound also. You didn't do that. And another question is why you have chosen only the copper here as a catalyst for this particular type of reaction? Why not the other things can be used?
Actually, copper catalyst is cheaper, and it's very simple handling, ma'am. And also, it's not a harsh metal, easily oxidizable metal. So that's why copper.
You don't have any other metals which are easily oxidizable?
Of course, iron and remaining also easily oxidizable, but compared to iron and remaining, copper is.
Have you tried? Did you try?
Yes, ma'am. FeCl3 we tried, ma'am.
Okay.
FeCl3 we tried, ma'am. It is also gives good results. But compared to FeCl3, copper iodide gives good results, ma'am. Actually, for first question, there is slide limitation for 8 slides only. That's why
I'm not asking for all the compounds which you have synthesized. At least where that cyclization is taking place, that you would have explained by putting one compound, and you would have explained that. It's okay. Huh?
Okay.
Okay, ma'am. The next participant is M. Shravanti, working as assistant professor in University College for Women. Shravanti, are you there?
Yes, Srivalli ma'am, I'm there. Good
Yes.
afternoon.
Good afternoon. Start your presentation.
Yeah. Is my screen seen on the screen? Is my screen is shared?
Yes, it is shared.
Thank you. Good afternoon, ma'am. I'm Mrs. Jayanti, working under guidance of Dr. P. Sarita Reddy, Madam, Associate Professor from Department of Chemistry. Today, I'm going to present part of my research work, and my topic for today is green synthesis DNA interaction molecular dynamic simulations, docking, in vivo anti-inflammatory, biological and thermal studies of iron, cobalt, nickel, copper complexes derived from the Schiff base. Yeah, Madam, I have synthesized my ligand and the metal complexes by both conventional and microwave methods. Microwave methods found to be the safest, fastest, and economic when compared to the conventional methods. Further, the formation of the ligand was confirmed by the proton NMR spectra. The proton NMR spectra showed evidences for the presence of OH proton, and also all the aromatic protons were also characterized by proton NMR spectra. This is the schematic route for the metal complexes which are derived from the ligand. Here are the spectra which we have founded: IR, UV, TGA, and mass spectrums. I have showed it here. Further, characterization of the metal complexes were done where CHN analysis were carried out. The calculated CHN values were in good agreement with the CHN values which we were found, which has helped us in showing the molecular formula of the compound. Further, MS mass spectra has given us accounted for the formation for the mass spectra. What we got it helped us to propose the molecular formula of the complexes. Further, conductance of this particular complexes were studied where and all the metal complexes were proved to be non-electrolytes. The formation and coordination of the ligand with the metal complexes were accounted in better way from the IR stretching frequencies. The ligand which we have synthesized showed isomethane nitrogen stretching frequency at 1643 centimeter inverse, which was shown to be decreased in all the complexes, which is in perfect evidence for the ligation of the metal with that of the ligand. Further, phenolic oxygen of the ligand has been shown a positive shift in the metal complexes, which also supports the formation of the metal complex. And the OH moiety in the ligand has been drifted in the complex 1, which is also supported by the TGA studies. Further, magnetic moment what we got it were helping us, accounted us for the configuration and geometry of the complexes, geometry assignment. Further, UV absorption peaks helped us in assigning the band assignment. Now, nu2 by nu1 values were inconsistent with the geometry what we have assigned for the complexes. Thus, through all the spectral techniques, we could infer that the complexes were formed with that of the ligand. Further, to know the thermal stabilities of the complexes, we have carried out kinetic parameter study using Cote-Redfern's relation, where activation energy was positive, which says that all the complexes are said to be highly stable, and the negative delta S and positive delta G values will account for the non-spontaneous nature of the complexes, which says that the complexes are highly stable. Thus, my complexes are thermally stable and non-spontaneous. And delta H being positive explains about the endothermic reactions. Further, DNA binding studies were carried out in order to know the binding ability of the metal complexes with that of the DNA. The spectra what showed was showing hypochromic and bathochromic shift. This is because of the intercalation mode of binding of the metal complexes with the DNA. Further, the stability constant, intrinsic binding constant was calculated, and among the complexes, the copper complex was having high binding constant value, which says that it is highly stable. Further, to account for the intercalation mode of binding, we have carried out fluorescence emission studies. This is based on competitive binding studies, where ethidium bromide is taken as a classical interchelator. When it is being added to the DNA, the fluorescence would increase, and further on addition of any quencher would quench the fluorescence of the ethidium bromide DNA complex, and the same was found in the fluorescence emission spectra. So thus we can say that the complexes what we have synthesized have bound to the DNA through intercalation mode. Further, to support the UV and fluorescence studies, we have carried out viscosity studies, where again we have taken ethidium bromide as an example. Now on increasing concentration of ethidium bromide, viscosity also increases. Keeping this as a principle, we have carried out the same study with all the metal complexes, and the same reaction was noticed. Thus we can confirmly say that the metal complexes what we got are intercalating with the DNA. And further, we have carried out cleavage studies using ctDNA on agarose gel electrophoresis method. All the
Jayanti, try to conclude.
Okay, all the complexes were having good ability. Further, biological studies were also carried out. In vivo studies were carried out using carcinogen-induced inflammation studies. We have taken diclofenac sodium as a standard, and it was studied for ligand and the copper. Copper was showing high rate. The same way on HeLa, we have carried out the cytotoxic studies, and complex 4 was showing high response. And among the antimicrobial activities, comparing to that of the ligand, metal complexes were showing high rate. And further, we have developed, we have studied Argus pictures, and then geometry optimization was done. Docking studies were done in order to explain the binding stabilities, and simulations also were carried out in order to find out the stability of the complex which are found. So finally, we have derived complexes, and we have derived at the, we have said that the complexes bind to the DNA through intercalating mode, and the complexes showed higher activity. This is my topic, ma'am. And finally, I would like to acknowledge my supervisor, Dr. P. Sarita Reddy, madam, and also head of the department and principal of the college, and director CFRD for helping me out in getting the spectral data. Thank you. Hello. Hello.
Okay, Jayanti.
Ma'am.
Okay. My question is,
yes, ma'am.
Why you have put so much of all things in your title? I don't know, because you have kept the synthesis part and all the things of your complexes, and then DNA interactions, molecular dynamic simulations, molecular docking, everything you kept, and the title is like that, and you have not covered the whole things, isn't it?
Okay. Ma'am, actually, I have submitted my thesis, ma'am. I'm yet to get my reports. I thought if one oral presentation is done, I can put it, I mean, I can show it during my final Viva presentation.
It's okay, but there is no time for you to do this. And I have a question for you.
Yes, ma'am.
How can you say this is a green synthesis method? How can you justify this?
Madam, microwave synthesis can be considered as a green synthesis method in my opinion, because through microwave methods, we are using less solvents, and the time can also be minimized. So solvent usage would be very less, madam. In fact, I didn't use any solvents for synthesizing the ligand or the metal complexes.
You have taken so many metals, isn't it? Iron, cobalt, nickel, and copper. Out of those 4 things, which one you have found that it is very good, showing very good activity?
Copper was showing high activity, ma'am. After copper, it is
in all the aspects. In all the aspects.
Yes, ma'am. In all the aspects, copper was very good. Even in vivo studies, the values what we got, they were consistent with the diclofenac sodium, madam. I mean, we have studied inhibition, percentage inhibition of the PAW edema. So it was compared with the diclofenac sodium. It was on par with the diclofenac sodium, ma'am.
Okay. Okay.
Okay. Thank you, ma'am.
Okay.
Thank you, ma'am, for giving me this opportunity.
Vijaya ma'am, I think the next lecture is going on. We will again have the technical session at 2:40, ma'am.
Okay.
Vijaya ma'am.
Yeah, ma'am. Okay.
Vijaya ma'am, with your kind permission, can we have the lecture, ma'am?
Yeah, ma'am. Okay, ma'am. Okay, ma'am.
Thank you, ma'am. Thank you so much, ma'am.
Thank you, ma'am.
I take this opportunity to humbly welcome Professor Basavaya, sir. Sir, hearty welcome to the conference, sir.
Thank you very much. Thank you.
It's a privilege, sir, to have you amongst us, and we are very fortunate and we are looking forward to listen to you, sir. Over to you, Samya.
Thank you, Vijayalakshmi ma'am. Am I audible?
Yes, Samya, you are audible.
Thank you, ma'am. Thank you, sir, for accepting our invitation and joining us today. We are very glad that you are here with us today. It is indeed my pleasure to introduce Basavaya, sir, Professor, School of Chemistry, University of Hyderabad. Sir did his MSc and PhD in Organic Chemistry from Banaras Hindu University, followed by postdoctoral fellow at Department of Chemistry, Purdue University, United States of America. Sir worked with Professor H.C. Brown, who is a 1979 Nobel laureate. Sir, before joining University of Hyderabad, he worked as a scientist in National Chemical Laboratory, Pune. And his main field of research is organic chemistry and specialized in reaction and chiral catalysis. Sir has more than 150 publications to his credit, and Sir has guided 38 PhDs, 5 postdoctoral fellows. Sir has received many awards. Among them, few are in Indian Science Congress Platinum Jubilee Lecture Award in Chemical Sciences 2009. And Sir has been awarded as a National Best Teacher in Chemistry in the year 2009, and many more. With this brief introduction, I would like to welcome Basavaya Garu to deliver his lecture. Over to you, sir.
Thank you, Dr. Soumya, for a nice introduction. First of all, I would like to thank Dr. Vijayalata and Dr. Vijayalakshmi Madam for inviting me to do this talk. Today, I am going to speak about our reaction, Belli-Shillman reaction. Let me open my slide now. Can you see my slides now?
No,
Hello?
sir. No, sir. We can't see your slides, sir.
Can you see now?
No, sir. You have to share them, sir. Not yet shared, sir.
Can you see now?
Yes, sir. We can see your slides, sir.
Thank you. Today, I am going to speak to you about Belli-Shillman reaction and our recent contributions. Before I go to my lecture, I would like to speak something about philosophy of our research work. Before I speak to philosophy of our research, I would like to speak about philosophy of thinking. The way what we think is actually key for our success or failure in our life. I can give some examples. You can see here this number is 9. How one can think of 9? One can think 3 into 2. One may think 18 by 2. One may think 3 square, or one friend may think 18 square root of 81, or some may think 10 minus 1. Some may think 7 plus 2, or some people think lucky number. Therefore, object is 1. There are so many perceptions. So many perceptions. I give one more example. This you have one object. How do you think about this object? If you ask any mathematics student, he will say it is a rhombus without any hesitation. If you ask any chemistry person who knows about organic chemistry, he will say it is a cyclobutane. If you ask a student who doesn't know chemistry or mathematics, he will say it is diamond ornament. Or somebody may say it is a diamond in playing cards. We put this in print, you can see this is the object. Okay. A mathematics person will think it is a rhombus without any hesitation. A chemistry person may think it is a cyclobutane ring. A common man thinks it is nothing but a 4-line boundary. Or those who play cards may think it is a diamonds in the playing cards. The spades, hearts, clubs, and diamond. Therefore, object is one, perceptions are many. Therefore, how we think about object is very important. Okay. Let me tell you our philosophy of our work in Hyderabad University. In organic chemistry, all of us know functional groups play a very, very important role. I have given here 6 functional groups. All of you know these things. Carbonyl, it can be aldehyde, ester or nitrile or any keto, anything. Hydroxy group, amino group, nitrile, alkene and alkyne. I selected 6 important functional groups. I am going to describe the properties of these functional groups. One functional group. I described here ketone, or carbonyl ketone or aldehyde. If this can be converted into alcohol by reducing with appropriate reagent, or you can insert oxygen here. Okay, by inserting oxygen, then you get ester, or you can generate a carbon ion here. If you have CH2 group here, then you can do further functionalization, or you can add a nucleophile and get a tertiary alcohol. Therefore, one keto functional group, aldehyde functional groups, you can do several transformations. I have given here 4 selective transformations. Next, I selected alkene group, olefinic group. You can dihydroxylate here, the appropriate reagent for osmium tetroxide or something like that. Then you can get diol, or you can insert here any carbon or oxygen by appropriate reaction, cyclopropanation or cycloepoxidation. Or you can cleave homolytically with appropriate reagent. For example, ozonolysis, you can get 2 carbonyl compounds. Or you can hydrogenate to get the alkane. Next, I have selected hydroxy group. You can see, you can oxidize with appropriate reagent, for example, PCC or PDC to get chromium trioxide to get the corresponding ketone. You can dehydroxylate to get the corresponding alkane, or you can alkylate with appropriate reagent to get the halide, to get corresponding halide, chloride, or you can dehydrate. If you have CH2 here, then you can get olefin. Therefore, I have shown here 4 important applications of alcohol. This is one functional group. Suppose you have 2 functional groups in a molecule. If they are far away, several carbons apart, then they have their own properties, what I described here. But they are nearby, like this. They are nearby. Alcohol and alkene, they are in proximity. If their alcohol is 6-7 carbons away, they have their own properties. If they are nearby, you can have, in addition to their own properties, you can get the bonus property. For example, you can generate a carbocation very, very nicely, very easily here. You have allylic alcohol. Or this can form a very good substrate for glycine rearrangement or Johnson glycine rearrangement to get olefinic carbonyl group. Therefore, when 2 functional groups are nearby, in addition to their own properties, you will get extra bonus properties. For example, I give one example here. Next, I have selected olefin and ketone nearby. They are far away, several carbons apart. They have their own properties. If they are nearby in proximity, in addition to their own properties, we can also get some bonus properties, some extra applications. For example, this enone, you can add Miguel reaction to get the corresponding alkylated compound. Or you can dimerize. You can dimerize in Diels-Alder fashion to get the corresponding pyran derivative. Therefore, otherwise they are not possible, because this is the effect of proximity effect, neighboring group effect. Therefore, when 2 groups are nearby, you can see what wonders we can do. Okay, you can generate cyclic compounds, or you can generate highly substituted ketones. Okay, these are the examples. I have given 2 examples. Suppose if you have 3 groups in a row, okay, what will happen? Okay, you have three functional groups in a row, okay, they will have differently extraordinary properties, which can actually direct new chemistry or create new chemistry. Okay, if they are close, in addition to their own properties, these functional groups exhibit some different properties. Theoretically, okay, I selected three functional groups here. Theoretically, ketone, olefin, hydroxy. Three are nearby. If you plan an acyclic compound with three functional groups, okay, there are only four possibilities, not more than that. Theoretically, here in the first compound, you have olefin in the middle, carbonyl compound, both sides. Similarly, because olefin has two carbons, you can have also this side, okay, and two carbons. Olefin here, ketone here, hydroxy here. Similarly, in this case, you have ketone in the middle, hydroxy and olefin. Similarly, here hydroxy in the middle, olefin and hydroxy. But if you go to cyclic systems, all can be in the ring, all three functional groups. Okay? So many things will be there. Here, olefin in the middle, CO in the middle, hydroxy in the middle. Because of the, you can have several ring sizes, ring size and heteroatom presence can make them so many possibilities. Okay? All three in one cyclic system. This represents two in cycle, one out of the cycle. You can see two in the cycle, okay? Olefin in the middle, two in the cycle, olefin in the middle, two in the cycle, alkyl in the middle, two in the cycle, olefin in the middle, or ketone in the middle, hydroxy in the middle. Like that, you have so many possibilities. If you have two in the ring, one out of the ring, you can create hundreds of possibilities having different ring sizes and different heteroatoms here. And nitrogen, oxygen, sulfur, so many heteroatoms in phosphorus, all those things. So one in the functional group, okay, one remaining or in the out of circle. Okay, one in the ring, remaining out of circle. Here also you can have varieties of compounds made theoretically, and because of the ring size, the ring can be 5, 6, 7, 8, or bicyclic system also, and heteroatom. Therefore, if you want to make molecules with three functional groups, okay, in one substrate, there are so many possibilities. Okay, but the literature says there are not many methods known to make them. Therefore, what we thought is, our philosophy is, a compound contains three functional groups in proximity. It will not only give new directions, it also provide new concepts in organic chemistry. This is actually our vision. Accordingly, we plan, okay, to develop a simple and easy synthesis to make these molecules having three functional groups in proximity and investigate their properties. That was actually our objective, long-range objective, long-term objective of our research. Okay, to develop simple process, simple strategies to synthesize, okay, molecules having three proximal functional groups, if possible via CC bond forming reaction. And other objective is to investigate and understand and explore their properties and applications in various synthetic point of view. In that pursuit, okay, we actually found a patent in the literature and developed this reaction, okay, Bellis-Hillman reaction. Our main aim is to develop the reaction having three functional groups close to each other via CC bond. Okay, we have developed this reaction. This is a patented reaction. We developed it in Hyderabad University. Okay, the reaction involves the coupling of picard activated alkene and a carbonyl group or any electrophile, for instance. Okay, in the presence of appropriate catalyst, we generate a molecule having three functional groups in close proximity. Yeah, since amine is an organic compound, we call organocatalytic CH functionation, because this CH we are functionalizing and getting this big group, amino or hydroxy, whatever group we take. Okay. This we call as activated alkene. This is electrophile. This is a catalyst. The coupling of activated alkene with electrophile under the influence of catalytic influence of amine or any other catalyst, for example, phosphine, you get the corresponding multifunctional molecules with three functional groups alpha to each other or in close proximity via CC bond. This is CC bond formation. This is actually our reaction. Okay. Now, let us see the reaction mechanism. The first step involves the addition of catalyst. Here it is a DAPO, diisobicyclooctane. This is a catalyst. It adds on methyl acrylate in Michael type fashion to generate a deuterionic inhalate. The deuterionic inhalate reacts with carbonyl compound aldehyde to get the corresponding CC bond. Then catalyst is released to get the functional molecule. Okay, what we wanted, multifunctional molecule. There are three functional groups. Therefore, our objective to synthesize a molecule having three functional groups, ketone, olefin, hydroxy, is achieved in this manner. This is major compound. In some cases, you also end up in getting minor compound. This is methyl acrylate. Already I showed you earlier. This deuterionic inhalate, they add the same molecule to do double Michael reaction and finally get up this kind of diketone. It's major compound. This reaction only happens in the case of alkyl ketone because this is a very, very reactive species, or reactive than acrylates or acrylites. This is the path B. Overall path 1 and shown here. The major compound is this one. This major compound. This happens only in the case of methyl vinyl ketone. In the case of acrylates, acrylitrile, this will not form. Only this forms. In this talk, I am going to present our recent work on Belli-Silman reaction. This is an electrophile. You can easily make isoquinolinium salt. Okay, this is isoquinolinium salt. Metal. I will show you how to make this, how to use it. Alkyl aldehyde react with aniline or arylamine. First you get imine and heating. This reacts with silver triplet to get isoquinolinium salt. Okay. Then this will react further with acrylate or acrylitrile to give the corresponding Belli-Silman product. Here you can see functional groups are there: electron withdrawing group, alkene, and amine. Three functional groups. Further, you have done some other chemistry to do some other things here. This way, you have used in situ generated isoquinolinium salts as electrophiles for CC bond forming reaction with aqueous alkenes to get substitute isoquinolinium derivatives. This mechanism is proved by HRMS studies by taking mass spectrum of the intermediates. Okay. These are the final intermediate. You get amine, isoquinolinium salt, and adduct. The intermediates are proved through HRMS studies of the seeing their molecular weights. Next, I will go to less reactive components in Belli-Silman reaction. Actually, alkyl violent ketones, acrylates, acrylitrile, nitroalkene, they are very, very reactive species. Similarly, aldehydes, ketoesters, ketamides, fluoroketones, they are very reactive electrophiles. They are weak electrophiles or weak components. Acrylamide, they are less reactive in nature. Original sulfones or sulfoxides, they are also very, very less reactive in organic chemistry. Similarly, ketones, allyl halide, epoxide also very less reactive electrophiles. Therefore, these are not employed in Belli-Silman reaction because of their less reactivity. Therefore, we plan to use them to accommodate them in our reaction. Intramolecular Belli-Silman reaction. Intramolecular reactions are much faster than intermolecular reactions because of entropy and enthalpy favor those reactions. Therefore, what is intramolecular Belli-Silman reaction? This is activated alkene electrophile. You can do a reaction here with some catalyst. You get a band between activated alkene and electrophile. This reaction we call intramolecular Belli-Silman reaction. I give the examples here. This is the substrate. This amide, which is less reactive in nature, acrylamide unit. This is aldehyde. They are in one molecule. Okay. N can be 1 or 0. Okay. Now, if you do a reaction here, at these two carbons, That is intramolecular very similar reaction. Normally, intermolecular very similar reaction, acrylamides are very, very less reactive. Therefore, very, very few examples are known. For this purpose, we have made these derivatives by simple classical organic chemistry methods and did reaction with DAPCO. You get very nicely this CC1 forming reaction. You can see here olefin, hydroxy, and amide are in close proximity. These are many amis. How to make these molecules? Similarly, if N is 1, you can get 6-member ring. Here you can see olefin, amide, and hydroxy in close proximity. I show the application in Ester sites. Similarly, I have used spiro compounds to get spirolactones like this. This is aldehyde. You can do very similar reaction between the two carbons. You get the corresponding spirolactone fused with cyclohexane ring. Similarly, this is spirolactone fused with cyclopentane ring. Okay. In this way, we have proved the efficiency of acrylamides, which are very less reactive in a very similar reaction in intramolecular very similar reaction. You have also showed that they apply asymmetric manner for E are less, but if you use a different catalyst, better catalyst, you may get better NS selectivities. You have used ketones. This is less reactive amides. These are also less reactive. Therefore, the purpose of our work here is to use two less reactive compounds. This is less reactive. This is less reactive. Two less reactive components in intramolecular very similar reaction. Okay, these are made using classical methods. This reaction with DAPCO, you get a corresponding CC bond. You get very nice yields of the corresponding lactone. You can see olefin, hydroxy, and amide. Functional alpha. So now you have also done Day2 selective reactions of these molecules. We selected a compound having a chiral centric, chiral racemic compound, which is then Belli-Silman reaction of this racemic compound gives you these two molecules, syn and anti. Of course, syn is almost more than 93 to 99%, very little amount of transfigure. We explained that anybody wants to, you can see this our paper mechanism is given here in this. This is some other examples of the same thing, Day2 selective Belli-Silman reaction with chiral racemic ketone and also acrylamide. Now I will go to two-component Belli-Silman. I will tell you what is two-component Belli-Silman reaction. The two-component Belli-Silman reaction can be done in 3 ways. One is substrate containing activated alkene and electrophile reacting with a promoter or catalyst. Okay. This is also known as intramolecular Belli-Silman reaction. Or a substrate containing activated alkene and promoter reacting with electrophile. Otherwise, last variety is a substrate containing electron and promoter reacting with the, there are 3 types of two-component Belli-Silman reaction. I am going to give you, already I give this example. I will give you this substrate containing electrophile and promoter reacting with activated alkene. AM is activated alkene. This example I give you. This is a substrate. This is a promoter or catalytic site, a promoting site. This is electrophile. The 2 active sites are there. Promoter and electrophile. Nucleophile, electrophile. Both are there in the same molecule. Now, you add an alkyl vinyl ketone. Okay. Now, this can react with activated alkene. Then this can react with this one. Okay. In this way, you can perform. This is a 2-component. This is activated alkene. This is called 2-component Belli-Silman reaction. You can do reaction very easily. Okay. React pyridine to carboxyldehyde with alkyl vinyl ketone in the presence of Lewis acid. Okay. You get the corresponding interleaved derivative in one part operation. We have Belli-Silman reaction. This is what reaction is. You take pyridine carboxyldehyde, add alkyl vinyl ketone, add TMS triplet in acetonitrile, you get the corresponding interleaved derivative. Similarly, the reaction works well with activated alkenes, cyclic enones to give the corresponding tricyclic molecule having interleaved derivative. This interleaved derivative. This also works well with simple cyclohexanone. This is substitute cyclohexanone. I'll show you example of ketone now. Earlier we discussed aldehyde. This aldehyde. Ketones are less reactive compared to aldehyde, but in our case, this also worked well. Okay. This is a R is a alkyl group. Okay. This is a promoter site. This is a electrophilic site. Okay. Check this kind of pyridine alkyl ketone react with alkyl valent ketones. You get indolent derivative because this is very reactive. It further adds an alkyl valent ketone. You get minor amount of this Miguel type compound here. If you take cyclic compound here, that possibility is not there. Miguel type component. Straight away you get tricyclic molecule. You are done with isoquinone derivative to get the corresponding tetracyclic molecule. With this you get tricyclic molecule. In this way, we have demonstrated the application of ketones as well as quinolene derivatives as a two-component substrate in reaction with alkyl valent ketone to get the corresponding tricyclic or tetracyclic molecules depending on the substrate we select. I'll give the application. I described few reactions of Beres-Hillman reaction, how we have developed reaction. Now I describe applications of the adducts. See, I told you three functional groups in proximity. Okay. This is alkene or olefin and hydroxy group. Okay. The three of the alkene, the hydroxy group, amino group, electron with rank can be ester, ketone, and nitrate. Because they are in close proximity, you can tune them appropriately. They are nicely tuned to get variety of organic transformations. You have done so many of these kind of transformations. I describe very few of them. You can see how we get the molecule. This is the molecule having three functional groups, hydroxy or amino. Okay, this can look in 6 different possible ways. How we will get the molecule? Very important. If you look at this alone, this is allylic alkylamine. Look at this side, these two. Look at this side, this one alone, we get unsaturated ester nitrate ketone. Look at these two. Is hydroxy, ester, ketone, and nitrate. This is alone alkene, alone ester, alone hydroxy. There are 6 different ways of looking at the molecule. Therefore, you have done all 6 different ways of reactions and demonstrated the versatility of these substrates in organic transformations. Yeah. Further, you can arrange these molecules, you can transform these molecules into corresponding acetate or bromide, or this can be transformed into phosphonium salts, ammonium salts, or sulfonium salts. Therefore, again, these are intermediates. Phosphonium salts, ammonium salts, and sulfonium salts. Very, very reactive intermediates. Therefore, you have developed all these 3 intermediates and demonstrated their applications in organic transformations. I give some examples here. This is allyl bromide, which I showed you. This is the allyl bromide. If you react this with HBr or PBr3, you get allyl bromide. If it is ester, you get trans-chemistry. If it is net, you get stereochemistry. Now we have taken this cis compound where R and Br are cis to each other. This on reaction with sulfide or dimethyl sulfide or any other alkyl sulfide, get a sulfonium bromide, a very, very reactive species in organic chemistry. This we have used as a 1,3 dipole in our reactions. You can see this is I told you this is bromide. You can transform into the sulfonium salt, which can form a sulfonium elite, which is actually equivalent to 1,3 dipole. It can react with dipolarophiles. We selected diazo decarboxylates to give the corresponding pyrrolidine derivative one part. That was this pyrrolidine acts as a dipolarophile. This acts as a dipole. You can see dipole. Therefore, 3+2 circulation reactions. Or you can also call it as 3+2 annihilation strategy for applying for getting pyrrolidine derivatives. The reaction very simple to do. Very simple to do. Take allyl bromide. React. Add dialkyl diisocarboxylates in the presence of dimethyl sulfide and potassium carbonate. Stir sometime at room temperature. Finally, get the corresponding pyrrolidine derivative. This reaction proceeds through 3+2 annihilation strategy. Now I have described to you three different bromides. This is allyl bromide prepared from bellissimian alcohols. Okay. It has no stereochemistry. It is just simple molecule, no stereochemistry. You have here nitrile here. Okay. Here it is trans stereochemistry. IR and bromide are trans to each other. Here they are cis to each other. There is no stereochemistry. There is a trans compound. There is cis compound. How they behave in as dipoles, the three molecules. No stereochemistry, trans stereochemistry, cis stereochemistry. How the three will behave as dipole profiles. I will show you some example. Now, this is a dipole. You have taken dipole profile acetylene derivative. Acetylene derivative reacts with this bromide, which has no stereochemistry, gives you the corresponding spiro compound having acetylene derivative and also furan fused together. Get this compound. If it is no stereochemistry. If you have a stereochemistry, cis stereochemistry, you get different compound. You won't get this kind of spiro compound. You get this kind of epoxide. You get cis and trans epoxide 1:1 ratio. If it is this compound cis bromide, therefore this stereochemistry or directs the reaction how to go. If you take this compound, allyl bromide, which has trans stereochemistry, this gives you spiro compound having this stereochemistry, where AR2 and this aryl group are cis to each other. Exclusively this compound you get. Anybody want to refer, they can see the mechanism are given in this paper. Therefore, three compounds behave differently. Okay, this gives you a spiro compound when there is no stereochemistry. This gives you epoxide, not spiro compound. It is spiro epoxide, that is spiropyran. Therefore, there are different substrates. And it gives you this spiro compound with exclusive stereochemistry, aryl and this aryl. In this way, the stereochemistry of the allyl bromide directs the reaction to give the appropriate product. Now I will go to another slide, other applications, how to make this kind of, this is a very important actually structural framework for biologically active molecules. These are very recently known in 2016. They found that this kind of molecules show actually this property, TNF induced NF-kB activity, almost like anti-antigen drug. Therefore, we thought, because we developed in earlier slide I showed you, we developed a spiro compound, why can't we use the same principle to develop a simple method to make these kind of spirolactones? Now, how to make these things? We find very simple way. Very simple way. This is the bellissimian acetate. This is the bellissimian acetate, which can react with this kind of oxindole derivative, simple oxindole derivative. You can do alkylation here. It alkylates here. Then you can do subsequent cyclization here, using some appropriate oxidizing agent to get the lactone. This is actually our idea. First step is to do the alkylation, monoalkylation of oxindole derivative with bellissimian acetate to get the alkylated compound. This is the cinnamic acid unit. This using appropriate oxidizing agent to provide corresponding cyclic compound, which is spirolactone used with acetylene derivative. Okay, we take this. We have taken this oxindole, reacted with sodium hydride. You get the corresponding sodium salt of this CNA bond. Then it will react with alkyl acetate, allyl acetate, which is obtained from bellissimian adducts. Give the corresponding cinnamic derivative. This a reaction with PFA. Okay. Anybody wants it? Mechanism are given in this slide. This reacts with PFA. Okay. Then it gives the corresponding OC bond, that is lactone. This way we have developed very simple synthesis of alpha arylidyne gamma beta-lactones. Okay. It is all one part reaction. Straight away, you start here, you get straight away on this reaction. This immediately you can do without isolating. I think This is the mechanism already I given here. This is the way mechanism goes. Okay. You can get this is FIPA. Okay. Phenyl iodonium diacetate. This iodonium diacetate react with this iodine unit, give the corresponding gamma beta electron like this. I think half an hour almost over. I stop it here. Okay, this is I have to acknowledge my students. Okay, we have done all these years. 41 students actually in this. Most of the theses are on Belli-Silliman reaction. One of my students actually, Raju Zonnap Reddy, R.J. Reddy, works in Osmania University as a faculty. Raju Zonnap Reddy, main campus. So Bhavani also actually worked long back with me. She is also professor in Osmania University Chemistry Department. Okay. Now I have 3 students, postdocs working. Gangadhar Rao, Sivalal Banwat and Said. Okay. These are postdoc students. I thank them, all my students, by their enormous contribution on the Belli-Silliman reaction. Before I close, I should also thank funding agencies, DST, Department of Science and Technology, CSIR, the Council of Scientific Industry Research, and Hyderabad University for giving me the job. And thank you very much. Hello?
Thank you, sir. Thank you so
I
much
finished in
for
time.
your nice
You gave 30
presentation.
minutes time. I finished 30 minutes time.
Thank you, sir. Thank you so much.
Any questions you ask, I'll try to answer.
Now, session is open for questionnaire.
Vichulata is
Anyone
there?
from the audience like to post the question in the chat box also can be posted, or you can ask the sir directly by unmuting yourself. Sir, I myself have a doubt. Can
Ask
I?
me. Ask.
Sir, in most of the Belli-Silliman reactions, whatever you have shown, sir, I have observed that most of the reactions, whether it is 3-component or 2-component, it is taking a lot of time, like for the reaction to complete, like 48 hours to 72
there are
hours.
methods now. You can use catalyst lanthanum triplet will be faster. Silica gel it is faster. Original
Okay.
reactions are slow. Now there are methods to make them faster.
Oh, okay, sir. Okay, sir.
Solid
Thank
phase,
you.
medium, catalyst more, you can go faster. The methods
Okay.
known now. Even then, there are neat reactions. I think you have to do it. Mix and leave it. It will automatically take some time and get the compound.
Yes. Sir.
No workup necessary. Just just mix and leave it.
We can cut.
You get marked with the functional groups close to each other.
Oh, okay, sir. Okay, sir. Thank you, sir. Now I would like to take this opportunity to propose a formal vote of thanks to sir. So good afternoon, everyone. We have come to an end of the lecture for 2-day international virtual conference on chemical advances for sustainable development. So on Department of Chemistry, University College for Women, I would like to express our deep gratitude to our distinguished speaker, Professor Basavaya Garu, for making an excellent presentation and making this conference very interesting. Sir, you have, for half an hour, you have taken us into the world of Belli-Silliman's reaction. Even a non-chemist student can easily understand your presentation, sir. The presentation was so neat and so well organized, sir. Sir, we have learned very much about the 3-component Belli-Silliman, 2-component, and its application as a substrate for SN2 and also for 1,3 dipoles. Thank you, sir. Thank you so much for coming and sparing your time out of your busy schedule. Thank you, sir. Thank you so much.
Thank you very much.
I'll take a minute here, sir. Sir, thank you very much, sir. On behalf of Department of Chemistry, University College for Women, I extend my heartfelt thanks to you, sir, for your kind acceptance of our invitation, for your time, and for giving such an excellent lecture, sir. We are very much thankful to you, sir. Thank you once again, sir, from all of us here.
Thank you very much.
Thank you, sir. Thank you.
Shall I disconnect my presentation?
Yes, sir. Sure, sir. Thank you, sir.
Ma'am, can we restart our technical session?
Yes. Yes, Samya. Now we will resume back to our technical sessions. I request Srivalli madam to make the announcements regarding the timings. Srivalli ma'am, are you there? Ayub sir?
Amina madam.
No, that is done.
Okay.
Amina and Narmada madam's session is over in the morning itself, Samya. Okay. So on behalf of her, I'll make the announcement. Dear participants, oral presenters of the Group C, we will take a break of 10 minutes and we will resume. Yes, Srivalli ma'am, you're there now. Can you make the announcement? Okay. So we are taking a break of 10 minutes and then we will resume our technical sessions back again. I request all the Group C presenters to please be available. And soon after the technical sessions, we will have our valedictory session. Thank you.
Sir. Vijay Charan break adigaru. Vijay madam.
Vijayalakshmi madam.
Madam, Srivali madam.
Yes, ma'am. Shall we start the session?
Yes, ma'am. Ma'am, I hope Vijay madam has joined.
Yeah, ma'am, I have joined.
Thank you, Vijay ma'am, and sorry for that inconvenience. We have taken the break for Basavai sir's session.
Yeah, it's okay, ma'am. It's okay.
Welcome back, ma'am, to the conference for the next session of the technical session 3. Thank you, ma'am, once again for being here with us in the conference. So with your permission, shall we start, ma'am?
Yeah, we'll start, madam.
Okay, ma'am. Thank you, ma'am. Over to you, Srivali, ma'am.
Yes, ma'am. Thank you, ma'am. Good afternoon to all. The next is M. Vijayata, Assistant Professor from Women's College, KOTI. Vijayata?
Yeah. Hello.
Are you there?
Yeah, Srivali madam.
Yes, Vijayata.
Yeah.
Yes, start with your presentation.
Yeah, sure. Thank you. Good afternoon, everyone. Good afternoon, Vijayacharan ma'am. With your permission, I'll start my screen. Is my screen visible?
Yeah, it's visible.
Yes, Vijayata.
Yeah. Good afternoon once again. Myself, Vijayata. I'm doing my research under the supervision of Dr. A. Haripadmashri ma'am, Associate Professor, Department of Chemistry, Osmania University. And today my topic to discuss here in my presentation is on titanium nanocomposites, a comparative study with titanium nanoparticles using various characterization techniques. To begin with the introduction, my research field is on nanoscience, as nanotechnology is the emerging trend and key technology having wide applications. I extend my work on synthesis of polymer nanocomposites with some interesting properties. So for establishing these nanocomposites, it is better to have a good dispersion of nanoparticles in matrices. For that, we could do surface modification and some functionalized materials for that. So polymers, whichever we select, must be non-toxic, biodegradable, and biocompatible nature, in which I have selected for my work polyethylene glycol, which is a good polymer, hydrophilic in nature, and can have a good stability. So polyethylene glycol is commonly available in even wide range of molecular weights, where N refers from 400, 600, 800, 1000. So we have several molecular weight ranges of PEG. And the use of inorganic nanoparticles has been augmented by coating it with this thin layer of PEG. And titanium, I have selected for this composite material preparation, as it has its good versatility in nano form, and it is produced abundantly because of its high stability, anti-corrosive, and photocatalytic properties. So methodology, when I start my work, I started my work in all the following steps, like synthesis of nanoparticles, then synthesis of composites by surface modification of these particles using polymer, which is biocompatible, and characterization using various surface and other optical techniques. So this is just schematic representation where we are coating in the PEG nanoparticle. PEG is taken as a filler, and we are getting a good nanocomposite. And synthesis method, we used a simple sol-gel method for preparing pure titanium nanoparticles, where titanium tetraisopropoxide is being taken as a precursor, and for a hydrolysis solution I have chosen urea. And these two solutions were heated on a water bath for 1 hour, and the product is filtered, dried, and then calcined at 400 degrees centigrade to get a dry powder, and then carried by surface modification of these nanocrystals produced with polyethylene glycol. So usually this step is called even as pegylation. So pegylation of nanoparticle titania is also being carried out using the same sol-gel method, which is very simple. And here we carried out using two solutions, that is a precursor and a hydrolysis solution, and propanol was used in the precursor solution along with titanium tetraisopropoxide. And the characterization studies of these nanoparticles and composites were carried out using the following techniques, like X-ray diffraction, UV visible DRS, diffuse reflectance spectrophotometer, that is scanning electron microscopy, and BET surface area analysis. So after this characterization, we could see the size and morphology of PEG surface modified nanoparticles were showing differences when it is compared with pure nanoparticles. So this is the XRD pattern, XRD spectra, where titanium nanoparticle was clearly showing the formation of anatase phase, and its nano size is about 11.18 nanometers, that is crystalline size, whereas nanocomposite was showing pure formation of rutile phase. So there is a phase transformation from anatase to rutile, and the crystalline size is also 13.21. So this is a XRD spectra for both the compounds. And coming to UV DRS spectra, both the spectra were compared, where we can see that usually the absorbance range was between 330 to 420, but maximum wavelength was 330 for nanoparticle and it is around 343 for composite. There is a shift in the wavelength, and even band gap calculation was showing that it is only 3.09 for nanoparticle, but it has decreased to 2.99 electron volts for composite, so that we can say that band gap energy is also lowered when it is a composite material rather than a particle. And these are some morphological pictures of both nanoparticles and nano composites, which was clearly showing a well-defined spherical shape of composite was compared with not so much well-defined spherical shape with the nanoparticle, and agglomeration was also less. And this is the wet surface area isotherms, what we plotted, taking the relative pressure versus volume adsorbed. In this also, it is clearly shown that the adsorption is more for composite compared to nanoparticle. And we could get surface area where 151 is the surface area for composite and it is only 57 meters square per gram for nanoparticle. So coming to the conclusions, our study clearly exhibits that the surface modification of nanoparticles has enhanced the properties of these nanoparticles, and there is a better dispersion to form them into nanocomposites for advanced applications. And we can understand the intercalation process also very well when we coat our polymer with a nanoparticle or nanometal particle. And further scope of work is we extend our work to synthesize some silica-based composites, carbon nanotubes, graphene, so that we find the application of these materials in various antibacterial activity, photocatalytic degradation of dyes, pollutants, and even in antibiotic drug delivery systems. Thank you.
Thank you, Vijayta.
Yeah.
Vijay, madam?
Yeah. Hello, Vijayta.
Yes, ma'am. Hello, ma'am.
So you have explained about the anatase phase of titanium oxide and this rutile phase, isn't it?
Yes.
So out of this, which is going to act as a better photocatalyst when you compare?
Rutile is going to be acting as a better photocatalytic property, ma'am. It is more stable.
Not the anatase, which is having a large band gap when you compare with rutile?
Yeah, but when we compare with anatase, for certain activities, we find that rutile is being more stable, but photocatalytic activity, anatase is more good than
yes, that is right, because it has the large band gap when you compare with the rutile one.
Yeah, I'm sorry, photocatalytic activity, anatase is more good than rutile. But even stability wise, if we see even some phases where rutile phase is forming more stability than anatase phase of crystalline structure.
Okay, Vijay.
Yeah.
Okay, ma'am.
Thank you, ma'am, and thank you, organizers, for giving me this platform to give my presentation. Thank you once again.
Ma'am, can I call the next participant, ma'am?
Yes, carry on.
Next is OP44 Markandeya from Osmania University. Yes, sir. Markandeya, sir. Are you available? Ma'am, can I go to the next participant?
Go, Vali.
Markandeya, are you available? Markandeya, sir, are you available? Okay. The next participant is Muhammad Maulana Kareem. It's OP45.
Yes, ma'am.
Yes.
So shall I proceed, ma'am?
Yeah, start with your presentation, sir.
Okay, thank you. Madam, good afternoon, madam. Myself, MD Maulana Garim. I am scholar and lecturer in chemistry, working in Government Degree College, Managur. Today, I am going to talk on antioxidant and catalytic activities of biogenic nickel oxide nanoparticles from terminal aqueous extract. So this is my outline of the presentation, madam, and this is the introduction. So in the introduction, the nanoparticle, the nano word is derived from the Greek word that is nanos, means drop. And definition: nanotechnology is the design, characterization, production, and application of the structures, devices, and systems by controlling its shape and size at nanoscale, means 10 to 100. So this nanotechnology is summarized by Richard Feynman through his famous lecture entitled as "There is a plenty of room at the bottom" at American Institute of Technology. And this nanotechnology term is first used by the Professor Norio Taniguchi of Tokyo University in 1974. So this nanotechnology emerged as an interesting field of research because of nanoparticles at lower size. They exhibit fascinating properties like physical, chemical, and biological properties when compared to its counterpart, bulk counterpart. So nanoparticles approach, synthetic approach of nanoparticles. Nanoparticle synthetic approach, we have two types. One is top-down and bottom-up method, and we can prepare nanoparticles by three methods: physical, chemical, and biological. Physical method belongs to top-down method approach, and the last two methods belongs to bottom-up method. So nowadays, in the synthesis of nanoparticle, the biological method is center of the attraction of the researchers because of its simplicity and cost-effective, eco-friendly. So in this present work, I have used a terminal chiller fruit which contains water-soluble hydrosoluble tannins, so which can act as a reducing and stabilizing agents. And next, this material method. And first, I have collected the analytical grade of all chemicals from Merck and plant source from local market. And first, I have prepared the terminology of fruit aqueous extract, and then I gone for qualitative analysis for tannins, alkalides, carbohydrates, etc. After confirmation of the presence of these, I have used this extract for the preparation of nickel oxide nanoparticles using 1:9 proportion of extract and precursor solution. And then this reaction mixture is heated and magnetic stirrer at 60 degrees centigrade until the color of the reaction changes from pale violet to brownish green. After this color change indicates the preliminary provide the preliminary information of formation of nanoparticles, and then I centrifuged and collected the residue, and the residue is dried in oven. And now that collected residue, black colored powder that is subjected to the characterization. The characterization is done by using the following techniques: UV visible spectroscopy, FTIR, XRD, EDX, scanning electron microscopy, and transition electron microscopy. And then I have studied the application of this biosynthesized nickel oxide nanoparticles like scavenging activity against DPPH, and also I compared the scavenging activity of my nickel nanoparticles with the standard ascorbic acid. And then I have studied another activity, that is the catalytic degradation of camphorate in presence of sodium boron hydride. And this is characterization and the result analysis. In that result analysis, UV spectro formation of peak at lambda for around 400 nanometers lambda maximum confirms the formation of polydispersed nanoparticles. And then this FTIR, so here it confirms the presence of phytochemicals present in aqueous extract are utilized for reduction and capping agents. And the Zeta study, Zeta potential, I got minus 29 microvolts of Zeta potential value that indicates the formation of a stable nanoparticles. And this is XRD analysis. In that XRD analysis, I obtained 5 peaks, and these are the corresponding planes of these 5 peaks, and these planes indicate the formation of face-centered cubic crystalline compounds. And these values again I compared with the standard GCP card number of nickel oxide, that is 652901 card, and the values are quite similar, matches. And then I have done the surface morphology using SEM. In that surface morphology, we can see that it is I obtained irregular shape of nanoparticles ranging size of from 10 nanometers to 2 microns. And this is EDX, this is element analysis. This element analysis also confirms the formation of nickel oxide nanoparticles. And this is TEM analysis. In the TEM analysis, we can see that the formation of spherical shape of nanoparticles, and this histogram tells us the average size of synthesized nanoparticles around 30 nanometers. And this is selected area electron diffraction studies also confirm the formation of crystalline nanoparticles. Then this is the applications. I have studied the scavenging activity of nickel oxide nanoparticles along with ascorbic acid against DPPH. So here I found that dose dependent activity. I have found dose dependent activity for nickel oxide as well as ascorbic acid. And as we know that ascorbic acid has a potent.
Sir, sorry for interruption. You please try to conclude it, sir.
Oh, thank you. And next, I conclude that these biosynthetic nanoparticles can be used for treatment of industrial effluents, which contains organic dyes. And acknowledgement, I sincerely acknowledge my guide, Sri Dr. G. Vijayalakshmi Garu, HOD of Department of Chemistry, KOTI Women's College, and I also extend my thanks to organizers, those who provide this opportunity to present my presentation. Thank you very much, madam. Thank you, madam. Hello.
Thank you, sir.
Thank you, madam.
Vijaya, madam, questions from your side, ma'am.
Yes. Maulana.
Madam. Yes, ma'am.
Can you tell me what is the reason behind choosing biological bodies? Because you have told that you have synthesized in by taking the organisms, biological systems, isn't it?
Yes, ma'am. Not
biogenic
nickel
oxide.
Yes, ma'am. Yes, ma'am. Plant sources, madam. Because
why your approach is towards choosing biological bodies?
Because, madam, it is very easy to handle, and moreover, it has doesn't produce any toxic byproducts, and moreover, it is very cheap, madam.
That is the reason why you have.
And moreover, it contains, this my terminal Cebula fruit contains polyphenolic compound, cebulic acid, that is effective. It can be used as, it is very polyphenolic compounds. Those are what we say, reduce metal ions into the metal, and as well as oxidized polyphenolic compounds can form a capping agent very effectively, madam. So that's why
it can be easily cultured with intracellular metal uptake, I think, no? That is the reason. And why you have chosen nickel oxide? You have so many nanoparticles, gold, silver, zinc. You have so many things, isn't it?
Yes, ma'am. Yes, ma'am. But nickel oxide is a potent catalyst, madam. So I want to.
Is that you say that the others are not
like that, madam? Not like that, madam. Nickel oxide, less work is done on nickel oxide, madam. Comparatively, silver and iron, those are extensive work done on silver and iron, madam. So that's why I chose for metal oxide, madam.
Okay.
Yes, ma'am.
Ma'am, I have a question, ma'am.
Yes, Vinayak,
yeah,
sir,
please,
you can.
From the audience.
From the audience. I think it's Vinayak, sir.
I have one question.
Sir.
Sir, whether your material is UV active or visible active, because you haven't shown any slide showing the band gap of your material.
Yes, sir.
What is the band gap?
Band gap around 2.9, sir.
2.9. Okay. Have you determined? Determined the DRS analysis?
Yes, sir.
DRS?
Yes, sir. But I didn't show, sir, due to the restricted to 8. They told me to restrict 8.
Okay.
So that's all.
So you have done catalysis, whether it is under UV light or
no, sir. No, sir.
Under visible light.
Under visible light only, sir.
Under visible light. Okay.
Yes, sir.
You have used sunlight or any bulb or something?
No, sir. Sunlight only, sir.
Okay.
I have another question.
Yes, sir.
You have calculated the zeta potential for your compound. Did you calculate for the dye or the conglomerate?
Ma'am, sorry, madam. Can you repeat?
You have done zeta potential for your compound, right? Did
Yes,
you do it for the dye?
No, madam. Only for nickel oxide nanoparticles, I have done for zeta potential.
No, basically now, so that this application has been done, from years. Now it is saturated. So people usually even calculate the charge of the dye, and then if the charge is same as that of your compound, then the activity will be more. That is what it is been predicted. So in that case, people usually measure the charge of the dye as well as the compound, and then choose accordingly which dye is suitable for your compound.
So, thank you, madam. Next time I will do. Thank you, madam. I will incorporate.
Oh, okay.
Thank you.
Any more questions from the audience side? Yes, sir. Please stop your presentation, sir, so that the others can share their presentation.
Okay, thank you, madam. Thank you.
Next, I will call Markandeya Namini for giving
Yes,
his
madam,
oral presentation.
Okay,
Yes,
madam.
sir. Continue with your presentation, sir.
Okay, madam. Myself and Markandeya, I am doing my research work under the guidance of the Dr. Navanita madam. So my presentation is in silico spectral and DNA docking studies of ruthenium-2 polypeptide complexes. So introduction of this topic, ruthenium polypeptide complexes are one of the most extensively studied and developed system because of their interesting photophysical and photochemical properties. So from the previous literature reveals that the ruthenium-2 complexes interact with the DNA through partial intercalation mode. So ruthenium complexes are used as a molecular probes. Molecular docking is a kind of bioinformatic modeling which involves the interaction of two or more molecules to give the stable product. Depending upon binding properties of ligand and target that predicts the 3D structure of any complexes. Molecular docking generates different possible adduct structures that are ranked and grouped together using scoring function in the software. The term in silico refers to computational model that investigate pharmacological, physiological using methods. So this is the previously reported ruthenium metal complexes. So these are the docking binding mode with the DNA. So these are IR of MTPPI ligand. This MTPPI ligand has been synthesized by using 1,10-phenanthroline, 5,6-dione and 4-methyl-thiobenzaldehyde in the presence of ammonium acetate and glacial acetic acid for 5 hours reflects at 80 to 90 degrees. The synthesized ligand calculated and experimental IR data is correlated. So this is reveals that 95% ligand formation confirmed. So it is carry forward to the analysis. So the present study focused on the in silico interpretation of vibrational spectrum and equilibrium geometries and DNA docking of the ruthenium complexes using semi-empirical method PM3. So these are the 3 different ruthenium metal complexes. Here A is equal to ancillary ligand. So 1,10-phenanthroline, second one is dimethylphenanthroline, third one is 2,2-bipyridine. MTPIP is a intercalator ligand. So further the molecular geometry and electronic properties, electrostatic potential surface for the complexes was analyzed. This type of complexes synthesized their vibrational spectra, experimental and theoretical values are correlated to assess the 3D isomers, which are carried forward for the analysis. These are the 3D models of complexes. These are ruthenium complex 1, this is 2, this is 3. So 3D isomers have been created and these isomers energy minimization carry forward, and for this vibrational spectra has been calculated. It is found that theoretical and experimental values correlated well, and further these model were considered for the next docking studies. So these are the binding lengths of 3D conformers are ruthenium metal complexes. So these N1, N2, N3, N4 are the metal nitrogen ancillary ligand bond lengths. This N5 and N6 are the metal nitrogen intercalator ligand bond lengths. So these are the thermodynamic properties. So total energy of the metal complexes, total energy is more than the ligand. So these metal complexes are the thermodynamically more stable than the these ligand. So these 3D isomers. Next to topic. So next to HOMO-LUMO energies has been calculated. So these are the homo molecular orbitals of complexes. These are the LUMO, these are the homo molecular orbitals of complexes. So for the ligand, homo LUMO orbitals are highly focused on the entire molecule on the imidazole ring. So as it comes to the metal complexes, the homo orbitals are more focused on the intercalator ligands, whereas the LUMO orbitals are concentrated on the ancillary ligands and the ruthenium ion. These are the energy difference between the lutetium and LUMO and homo orbitals. This energy gap will shows that the ligand has higher value, so which indicates it is difficult to bind this, but the lower value of complex 3 indicates it is the more reactivity. So here complex 2 is less reactive, complex 3 is the kinetically more labile. So these are the homomolecular orbitals, these are metal complexes. So next, these are the data for orbitals. These homo orbitals, LUMO orbitals, the energy gap.
Sorry for the interruption, sir. I think you can conclude it.
Okay, madam. So this gap indicates the reactivity of the complexes. So from this homo LUMO orbital, we can calculate the absolute hardness, absolute softness, global electrophilicity, chemical potential, absolute electronegativity, global software. These all are homo orbitals is directly related to the ionization potential, LUMO orbital directly related to the electron affinities. So okay, madam. These are the electrostatic potential surface for the metal complexes. So these are the
Sir, sorry for interrupting, sir. Please conclude it, sir.
Okay, madam. These are patched up dissolution energies. The complex one is more bound to the DNA. So these are the DNA with metal complexes. Okay, madam. Conclusion: the ruthenium-2 complexes DNA docking study reveals that the ruthenium-2 polypeptide complexes bind to DNA predominantly. So by intercalation, the results show that the FIN and DMP complexes has a more effective binding ability than piperidine. So above indicating the role of the ancillary ligand in determining their specificity for DNA binding. Okay, madam. Thank you. So thank you one and all, madam.
Thank you, sir. Any questions from the audience, from the participants? Ma'am, Vijaya ma'am?
Yes. Are you Markandeya?
Yes, madam.
Nice work, but no clarity on all the things which you have explained. But I have a question for you. Can you tell me what is a good RMSD score in docking?
RMSD score.
Better docking pose, which corresponds to the binding mode of the ligand.
So complex one more bind than the other complexes.
No. Generally, I'm asking like, what is the good score of RMSD in docking? Okay, next.
Okay.
Any questions from the audience?
Yes, sir. Please kindly stop the sharing of your presentation so that the next participant can present it.
Okay, madam. Thank you, madam.
I next call OP46 Monica Kurhana from School of Engineering, Saurashtra University. Monica, ma'am?
Yes, ma'am.
Yes, ma'am.
Good afternoon, ma'am.
Good afternoon, ma'am.
Ma'am, can you allow me to share the screen? Hello.
Yes.
I'm not able to share the screen, ma'am. It gives a message that host disabled participant screen sharing.
Markandeya sir, please stop sharing your screen.
Stop, madam.
Please stop sharing your screen so that the other participant can share their screen.
Stop scaring, madam. I
No,
stop.
it shows I've started sharing.
I stop.
No, I'm unable to share, ma'am.
Madam, stop sharing. Stop this.
Try again, ma'am.
No, it's working.
Yes, ma'am. Try again.
Not working.
Now you try again, ma'am.
Same message, ma'am.
What is the message?
So it shares host disabled participant screen sharing.
Really, madam, please, sir.
I am logging from the laptop, so I have logged in from my desktop also. Let me try from there.
Is your internet?
Yeah, I'm able to share from desktop.
Okay.
But ma'am, I don't have a webcam on my desktop. So is it okay if I turn off my video and share the screen from desktop?
You can, ma'am. You can.
You can, ma'am.
Okay, thank you.
Yes, ma'am. It is visible, ma'am.
Are you able to hear me, ma'am?
Yes, yes.
Okay, great. So good afternoon, everyone. So my name is Dr. Monica Khurana, and I am working as Associate Professor at Sushant University, Gurugram. So today I am going to present on a topic revealing interactions of gold nanoparticles with lipid membranes by spectroscopic studies. So this is the outline of my presentation. In this presentation, I will be presenting about the introduction of lipid membranes, gold nanoparticles, and the techniques which I have used to characterize these membranes and the interactions of gold nanoparticles with the lipid membranes. I have used UV visible, FTIR, dynamic light scattering, and transmission electron microscopy techniques. At the end, I will be presenting the results and conclude. So first, this is a cell membrane. You can see the cell membrane is very complex. There are many biomolecules like proteins, other small biomolecules which are interacting constantly with the biomembranes. So this biomembrane is mainly composed of phospholipids. So we mimic this biomembrane or cell membrane in the lab by reconstituting the lipids. So since this membrane, 70% of the content of this cell membrane is phospholipids. Now the objective of this study is that to prepare the gold nanoparticles loaded lipid liposomes, which will mimic the original biomembrane or cell membrane, and to evaluate the stability of these nanoparticles incorporated lipid liposomes by UV visible spectroscopy, and to see the effect of the size of these nanoparticles onto these lipid membranes. And finally, the phase behavior of these nanoparticle loaded lipid membranes will be studied by FTIR, colorimetric and fluorescence. And finally, I will analyze the interactions of these nanoparticles with lipid membranes and will evaluate the data for different kinds of lipids present in the cell membrane. So here briefly, I will just explain how the phase behavior of the lipid membrane changes. DPPC is dipalmitoyl phosphatidyl polylipid. So at low temperature, the chains are very stretched and it's called liquid crystalline phase or laminar crystalline phase. And you can see at while increasing the temperature, the lipid chains are disordered, or these lipid chains are distorted, and it's laminar liquid crystalline phase or L-alpha phase. So now to study the interactions of the gold nanoparticles with DPPC, here is the proposed model that this is a lipid liposome in circle, and these lipid liposomes are interacting with the gold nanoparticles, and on the right hand side you can see the structure of the lipid. So now why gold nanoparticles? Gold nanoparticles are very, very interesting to study with the lipid membranes because it finds a lot of applications in drug analysis, drug discovery, and has a lot of biomedical applications. So these are biocompatible actually and inert in nature. So that's why gold nanoparticles find a lot of applications in drug discovery and biomedical imaging.
245%.
So now these membranes are prepared by the preparation of multilaminar vesicles and unilaminar vesicles, or these are called the liposomes also. So this mimic the original cell membrane. So lipids are dissolved in organic solvents, then it is evaporated under a stream of nitrogen, and under vacuum, dry lipid film is obtained. And then it is rehydrated with gold nanoparticles. So you get the liposome nanoparticle composites. So, and by doing 5-6 freeze-thaw cycles in liquid nitrogen and thawing it at above the transition temperature of the liquid, we get multilaminar vesicles. And these are a little bigger in size. If you want unilaminar vesicles of a particular size, then these membranes are extruded through a polymembrane filter. So UV visible spectra of these multilaminar vesicles which are prepared is taken. So on the left hand side, you can see the DPPC liposomes, and it has a lambda max value at 222 nanometers, 222 nanometers. And now you on the right hand side, you can see after incorporating 5 nanometer gold nanoparticles into the DPPC liposomes, the surface plasma band in the UV visible spectra appears at 525 nanometers. So it means the gold nanoparticles has been well incorporated into the DPPC membranes. So we can check the stability of the nanoparticles of DPPC membranes by UV visible spectroscopy. So black curve shows the gold nanoparticles of DPPC liposomes of 10 nanometers, and the red one shows the gold nanoparticles of DPPC liposomes after 1.5 hours. So it is clearly seen that after 1.5 hours, there is no change in the intensity of the UV visible band. So there is no change in actually the gold nanoparticles of DPPC liposomes after 1 and 5 hours. So these are stable at the measured conditions.
Excuse me, ma'am. Sorry for the interruption. Try to conclude it, ma'am.
Yes, ma'am. So TEM imaging has been taken. So on the top, you can see that TEM image of the multilaminar vesicles of DPPC. So the round structures of 0.2 nanometers. So since these are multilaminar vesicles, that's why they are of different sizes. So the circular shape is of the DPPC liposome. And here the TEM image of 5 nanometer gold nanoparticles. You can see in the 1:1 equimolar ratio of gold nanoparticles and DPPC, and on the right hand side, the B figure, that gold nanoparticles and DPPC in 5:1 ratio. So you can see as the ratio of the nanoparticles is increased, the clustering, the aggregates of the nanoparticles around the DPPC vesicles has increased. This is due to the interparticle gold nanoparticle interaction between them. So phase behavior of DPPC has been observed by FTIR. Black curve shows the DPPC liposomes. And then after incorporating the 5 nanometer gold nanoparticles in different molar ratios, the intensity of the bands has decreased. The 2800 to 3000 per centimeter wave number of FTIR spectra shows the polymethylene orientation of the polymethylene chains in the lipid membranes. So this area is of importance to us. So you can see after incorporating gold nanoparticles, the intensity of these bands have decreased. So it means there is a change in the structure and dynamics of the lipid membranes after incorporating gold nanoparticles. So the effect of temperature has also been seen because the lipid membranes exist in different phases at different temperatures. So the temperature scans have been done from room temperature to 50 degrees Celsius. The main transition temperature appears at 42 for DPPC membrane.
Excuse me, ma'am.
Yes, ma'am.
Excuse me, Monica, ma'am. Try to come
Yes,
to the conclusion,
two
ma'am.
slides more. Yes, ma'am. 2 slides. So we can see that clearly there is a change in the wave numbers after incorporating the gold nanoparticles into the DPPC membranes. So the dynamic light scattering of the gold nanoparticles of DPPC membranes have also been seen. So the liposome size is 300 nanometer. After incorporating the gold nanoparticles in different ratios, the size of the liposomes have increased and the zeta potential has decreased. Because gold nanoparticles are stabilized by citrate buffer. Citrate has got the negative charge, so it's minus 35. So when gold nanoparticles is increasing concentration in the lipid membrane, so the zeta potential is decreasing. So it is increasing actually the density in the lipid membranes, and the size is also increasing with increase in number
Yes,
of
ma'am. Please, ma'am.
So at the end, I would like to conclude that gold nanoparticle size is 0.3 micrometers as observed by TEM and DLS measurements. So the gold nanoparticles of DPPC liposomes are found to be stable after 1.5 hours of preparation by UV visible. FTIR shows that the antisymmetric CS2 stretching vibrations of 5 nanometer gold nanoparticles in the membranes have increased the wave number by 10 centimeters, and then of the symmetric stretching vibrations by 6 at the main phase transition temperatures, which has not been reported yet. So the significant increase in wave number of stretching and anti-stretching vibrations after incorporating the gold nanoparticles have clearly indicated that there are strong interactions of the gold nanoparticles with the lipid membranes. Thank you so much, and I would like to thank all the organizers and the session coordinators for giving me the opportunity to present my work. Thank you, ma'am. Any questions?
Thank you, ma'am. Any questions from the participants?
Yeah, ma'am, I asked one doubt. It's not exactly the question. Ma'am, will you please go to the slide number 12?
Yes.
Yeah, here you have explained that the decrease in the intensity is due to
incorporation of gold nanoparticles in the lipid membranes.
Structural changes or the intensity is decreased?
No, it shows that there are structural changes in the lipid membranes after incorporating the gold nanoparticles. Actually, it changes the fluidity of the membranes.
Okay. Okay.
Yeah.
Thank you.
Yeah. Thank you, ma'am. Any more questions?
Yes, ma'am. Vijaya, ma'am.
Yeah. Can nanoparticles move through membranes?
Ma'am, these are 5 nanometer gold nanoparticles. I have done studies with 10 and 30 also, but I'm presenting here 5 nanometer gold nanoparticles. So they are not actually, the thickness of the lipid bilayer is around 6 nanometers. So they actually, I have found that they are actually interacting with the lipid head groups. They are not incorporated in between, and they are not interacting with the hydrophilic chains of the lipid membrane. They are interacting with the head groups. Here you can see. They are interacting in the head groups, the polar part of the lipid membrane. They are not incorporated in between these micelles or vesicles. So these lipid chains are hydrophobic in nature. So they are hydrophilic. So they stay here around these all the gold nanoparticles, like you can see from the TEM images. So they are interacting with the vesicles. So these are the gold nanoparticles outside at the edge of the liposome.
I have one more question. Why it causes gold nanoparticles to aggregate?
It's the ma'am van der Waals interactions between the gold nanoparticles, intermolecular interactions between the gold nanoparticles itself. So they tend to aggregate.
Is that
It's
are
a
going to
property
change
of
the
it's a
color?
property of the gold nanoparticles itself.
So is it is going to change its color when it is shifting towards?
It will, but ma'am, we cannot see here because they are incorporated into the membranes. So when they are incorporated into the membrane, it's very dilute concentration. So so the membranes do not have actually any visible color. Otherwise, gold nanoparticles are around like reddish, bright red in color. Bare gold nanoparticles, but when they are incorporated in the lipid solution, they don't have any color actually.
Yeah. Thank you, Monica.
Thank you, ma'am.
Okay, ma'am. I will call the next participant, OP47, Mr. Balraju, sir.
Okay, madam.
Yes, sir. Balraju, sir, are you here?
Yes, madam.
Yes, sir. Start your presentation, sir.
Yes, madam. Madam, host disabled participant screen sharing, madam. It's coming. Hello.
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 Sir.
Madam, it is a problem to share my screen, madam. It's coming. Host disabled participant screen sharing.
Now you try to share, sir. Are you able to share it, sir, now?
No, madam. It's not possible for me.
You just have this share screen button. So
Yes, I am doing same, madam, but it is not
it's not
accept working, madam.
just a minute, sir. Now you try, sir.
Yes, madam.
Just minimize the Zoom, sir. You're already into the Zoom meeting. Just minimize that and then go to share screen option. In that, you'll be having your options. You can share it. If you close that Zoom meeting, you'll be going out.
Just you minimize that, sir.
Minimize it, sir. You open your PowerPoint presentation, sir, first on the screen. On your computer screen, first you open your PowerPoint presentation, sir.
Is it visible, madam, my presentation?
Yes, it is visible now, sir.
Okay, thank you, madam. Good afternoon, madam. This is Balraju Udari, Assistant Professor of Chemistry in Srinidhi Institute of Science and Technology. I am a research scholar in Mahatma Gandhi University, madam, under supervision of Dr. S. Kalyani, madam. And in today's conference, I am going to present design, synthesis, and biological evolution of amide derivatives of thiazolopyrimidines as anti-cancer agents, madam. And this is the overview of presentation. the thiazolopyrimidines. These are sulfur and nitrogen bearing heteroatoms, and these are having a significant medicinal importance. And comes to thiazolopyrimidines, these are a well recognized fused heteroaromatics and occupied a prime place in medicinal chemistry. These played a wide variety of biological activities such as anti-inflammatory, antimicrobial, anti-cancer, human cytomegalovirus inhibitors, anti-angiogenic, anti-diabetic, neuroprotective, immunosuppressive, and phosphodienocyde 3 kinase. So these are the biological activities of thiazolopyrimidine derivatives. And comes to literature work, these are synthesized from a variety of starting materials, and pyrimidine derivatives from the pyrimidine derivatives, nitrogen containing groups at a C5 position, that is a 5-nitro 5-amino pyrimidines. From these starting materials we can synthesize thiazolopyrimidines, and thiazolopyrimidines can be synthesized from pyrimidine derivatives with n functions at C5 position, that is a C5-nitro 5-amino 5-acyl amino pyrimidine derivatives. And this compound, that is a compound 1, can be synthesized from amino, nitro, or acyl amino derivatives of diethyl ester. Treatment with thiourea, urea, guanidine, 4,6 dihydroxypyrimidine can be prepared. This is the compound. This compound and on thionation with phosphorus pentasulfide, thiazole ring is constructed. And one more route, this is the route from the compound 3, that is a 5-amino mercaptopyrimidines with phosphogene, formic acid, acetic anhydride also gives thiazolopyrimidines. And this is the next route, and these are the various starting materials from which we can synthesize thiazolopyrimidines. And comes to my schema, this is the starting material 6-chlorothiazolopyrimidine on treatment with ethyl acrylate. On 4 novel steps it will give a compound 6, and this compound 6 derivatives of this amide derivatives of compound 6 are prepared, and they are sent for their biological activities. In conclusion, we have designed and synthesized a new series of amide derivatives of thiazolopyrimidines. The title compounds were characterized by analytical spectral methods, and further these compounds were sent to for analysis of their biological activity. My sincere thanks to giving this opportunity, Professor M. Vijayalata Madam, Dr. B. Shailaja Madam, Dr. G. Vijayalakshmi Madam, Dr. V. Shashikala Madam, Dr. D. Ramesh Sir, HOD of Chemistry, MGU University, Dr. Y. Prashanti Madam, BOS Chairperson, MGU University.
Sir, please try to wind up, sir.
Okay, Madam. Thank you, Madam.
Vijay Madam. Vijay Madam, questions from your side, ma'am.
What's your name? Balraju.
Yes,
Balraju.
yes, Madam.
Can you tell me why the thiazole is having a higher aromaticity?
Thiazole, Madam.
Yes.
Due to overlapping of pi electrons, Madam.
On which one?
this nitrogen and a ring.
Not on the sulfur?
Yes, madam, even sulfur too.
Now you have told that in your work you have not yet kept any spectral data. You
Yes,
have just
madam.
told.
Actually, this is under review, madam, this work. That's why I not presented any steps and spectral information, madam.
Okay, then, Balraj. Okay.
Okay.
Next, I will call the last participant, that is Hari Babu, Assistant Professor of Chemistry from Gadwal.
Hello, madam.
Yes, sir.
Okay, Srivali madam.
Yes, ma'am.
Can you tell me the number of this last presentation?
It is OP32, ma'am.
So what about 48?
48 is not there, ma'am.
Okay.
She did not. She did not turn up in the list, ma'am.
Okay.
Yes, sir. Sir, you can continue, sir.
Madam, it is visible, madam?
Yes, it's visible, sir.
Okay. Good evening, madam. I'm Hari Babu, Assistant Professor of Chemistry, working at Untitled College. So my today's topic is green synthesis of copper nanoparticle using aqueous alternative leaf extract in the study of antioxidant, photocatalytic, and antibacterial activities. So this work is done by the under supervision of Dr. G. Vijayalakshmi, Assistant Professor of Chemistry, Department of Chemistry, University College for Women, KOTI, Usmania University, Hyderabad. So my outline of the presentation is introduction, material and methods, result analysis, conclusion. So, madam, first of all, I collect the leaf alternative leaf. This can be widely available in our Gadwal area, especially in our college in the wild field. So first of all, I have to prepare the leaf extract, how the collection, cleaning, drying, and grinding of the leaf extraction. Next one, preparation of the aqueous extract and the photochemical staining of alternative leaf aqueous extract. And this can be the reaction mixture was heated on the nitrate at 60 degrees centigrade for 120 minutes. Then we can get as a nanoparticles. And after formation of nanoparticle, we can go through the characterizations. Characterizations are different type of characterization. For example, FTR, zeta potential, XRD, SEM, TEM, all these things. And the next one applications are, one is the antioxidant activity and the catalytic activity, and antimicrobial activities also you can see. First of all, I will give a small introduction about the nanotechnology. So nanotechnology deals with the understanding of control of matter at dimension between approximately 1 to 100 nanometers, where unique phenomenon enable novel applications. So more specifically, the nanotechnology is the imaging, modeling, measuring, designing, characterization, production, and applications of structure, devices, and system by controlled manipulation of size and shape at the nanometer scale. That means at the atomic or molecular and the macromolecular scale, that produces the structure, device, and the system with at least one novel or superior characteristic property, madam. So the nanoscale, how small is nano? We already know 1 nano is 10 to the power minus 9 meters. So this is the introduction about this one. And how we can go through the synthesis of nanoparticles, the synthetic approach of nanoparticle. There are two types. One is the top-down and the bottom-up method, madam. From the top-down method, we can bulk to go to the nanoparticles, and bottom-up method from atoms to nanoparticles. So there are different type of prepared methods. One is the physical method, chemical method, and the biological method. Among these the three methods, we can choose the biological method. I choose this biological method, madam. Why? Because of in this physical and chemical method, there are some hazardous byproducts can be formed. So that's why we can go choose the biological method. That means in the biological method have many advantages over other methods because of its cost effectiveness, simplicity, use of low energy, use of less toxic materials, and eco-friendly plant pots containing metabolites have reactive groups such as the amino acids, carboxylic, hydroxylic, and amides. All these things. Especially, I am showing here what are the type of phytochemicals are present in the plant. So these are the type of phytochemicals: alkaloids, amino acids, ascorbic acid, oxalic, carboxylic, polyphenols, flavonoids, alkaloid, terpenoids. All these are the phytochemicals are present in the plant extraction, madam. So this is a simple schematic diagram how the nanoparticles can be formed from the leaf extract to the nanoparticles. So these are the structures of the some phytochemicals, that is the flavonoids, proteins, and the carboxylic acids, polyphenols, all these things. This is also a simple schematic diagram how we can prepare the nanoparticles. First of all, we have to take the plant extract in one beaker, another one having the metal ionic sources. So mixing of these two and stirring at the magnetic stirrer by maintaining of 60 degrees.
Sir, sorry for the interruption, sir. It's getting late. Please try to wind up, sir.
Okay, madam. Right, ma'am. So how we can, first of all, preparation of leaf extract, how we can prepare the leaf extract, collection, washing and peeling and grinding. So order the Sicili's powder, 10 ml distilled water, heated and max stirrer, we get the leaf extract. And here, biogenesis of copper nanoparticle. Madam, first of all, you have to prepare the 10 ml of, add the 20 ml of leaf extract and 180 ml of 5 ml copper ester. There is a precursor. Many of the precursors are there for the copper nanoparticle, copper ester, copper nitride, or copper chloride, or the copper sulfate, many of them. I choose the copper acetate. So there is a formation of nanoparticles by adding of these two. Simply we can observe the color changes from the light brown color to dark brown. And after formation of copper nanoparticle, we can directly go through the characterization. So what are the characterization here? UV visible and UV visible spectrometry, Fourier transform, X-ray diffraction, energy dispersive, and the scanning electron microscope.
Excuse me, sir. Sorry for interruption. Please conclude it, sir.
Okay. So these are all the characterization done by me. These are UV visible, FTIR, zeta potential, XRD, SEM, EDX, and these are the TEM and SAD. These are the catalytic effect, antimicrobial effect. So, madam, I will explain a simple one as catalytic degradation and the.
Sir, the time is short, sir. You have already crossed the limit, sir. 5 minutes.
Okay. So, conclusion is biosynthesis of copper nanoparticle is one of the best alternative method, which facilitate the facile and rapid nanohazardous, cost-effective and eco-friendly. Biosynthesis copper nanoparticles show the substantial antioxidant and catalytic activity against the 2,2 diphenyl 1-butyl hydrazine and congoretide respectively. So the outcome of the present study is an effective approach to design an environmental friendly material for heating industry effluent that contain the organic dyes released by the various industries like printing, textile, fabric, and the other related one. And last one, first and foremost, it's my immense pleasure to have Dr. G. Vijayalakshmi Madam Garu as my research supervisor, and I earnestly present sincere gratitude for her guidance, encouragement, and blessings. And finally, last and least, I would like to extend my thanks to organizers for providing this opportunity. Thank you, madam. Thank you.
Thank you, sir. Vijaya Madam, questions from your side, ma'am.
Can you explain the mechanism of this process of DPPH, how the metal is interacting and how it is going to carry out the reaction?
Madam, diphenyl, 2,2 diphenyl. 1 minute. This is the scavenging activity. So, madam, actually, the scavenging activity, antioxidant. So, 2,2 diphenyl 1-butyl hydrazine, madam. So, without addition of actually, the reference we have to take as ascorbic acid, madam. Is a free radical. DPPH is a free radical. So, most of you have seen the scavenging activity in the using of DPPH. Why? Because of actually copper nanoparticle shows the potent DP-based radical scavenging activity, madam. It is a dose dependent, madam. When we can add the copper nanoparticles in the different quantities, that is a 10 ml, 20 ml, 50, as increasing of the quantity of the copper nanoparticles. So the scavenging activity will be increased. That means by simply we can see the observing of the absorbance OD value by measuring it by using a UV visible spectrometry. We can see the optical density. Whenever the dose dependent increases, the absorbance will go on decreases. So that's why then we can the percentage of inhibition can be calculated for the simple form of C minus T by C into 100.
Okay, Haribab.
Yes, ma'am. With this, we have concluded the session for oral presentation of C-list. And I'm very thankful to Vijaya Madam for sparing her precious time from a busy schedule and giving her presence for this as being an evaluator for this oral presentation. Thank you very much, ma'am.
Thank you, madam. I also enjoyed and learned a lot, and I thank the organizers for giving me this opportunity. Thank you. Thank you very much.
Thank you, Vijaya ma'am. On behalf of Department of Chemistry, University College for Women, thank you so much, ma'am, for giving your kind suggestions to all the research scholars, all the students, and you have very well interacted with them and given them very good suggestions. Thank you so much, ma'am. They will take these suggestions and they will try to improvise their work and work in that particular direction. Thank you once again, ma'am, Vijaya Charan ma'am, for being with us in this conference.
I'm glad.
Thank you, ma'am.
Okay, ma'am. Thank you.
Ma'am, I request you to kindly stay back for the valedictory session as well, ma'am.
Yeah. Okay.
Thank you, madam. Over to you, Vijayta. Vijayta, I think Principal Madam is also here.
Okay.
With us. Ashok sir has also joined. Welcome to the valedictory session, Ashok sir. Thank you, Vijayata ma'am, for joining us in the valedictory
Thank you,
session.
madam. Thank you, madam.
Thank you, sir. Thank you very much, sir. You're on time, sir. In fact, more early than that.
Good evening, sir.
Well, very good evening, madam. Hearty congratulations.
Thank you, sir.
Shashikala ma'am. Shashikala ma'am, are you there, ma'am? Dr. Sandeep, can you please mute yourself? Dr. Sandeep, kindly mute, ma. Vijayata ma'am, we just got the information from VC sir that he is in a meeting.
Vijayalakshmi ma'am, your voice is not audible, ma'am. You are muted.
Madam, you are muted. Ma'am, please repeat.
Yes. Ma'am, I am to inform you that VC sir is in a meeting currently and he will join us when he becomes free and he will deliver his message.
Okay, ma'am. No problem.
I hope Shailaja madam is also with us. Let's find out.
Shall I?
I'll just find out if VP madam is with us.
Sure.
Ma'am is not taking the call, madam. I think Shailaja madam is busy, maybe. Vijayata ma'am, shall we wait for some time? Ma'am, Shailja madam is joining, ma'am. She'll be with us in a minute. Shailja madam has joined, Vijeta?
No, ma'am, not yet. I can't see her. Annapurna? Can you please welcome? She joined?
He didn't join, ma'am.
No.
Vijeta, are you there?
Yes, ma'am. I'm here, ma'am.
Yeah. Shailaja madam has joined us. Okay. So Vijayalata ma'am, shall we start the session?
Yeah, ma'am. You can start.
Shall I?
Yeah, over to you, Vijayata.
Thank you, Vijayalakshmi ma'am. A very good evening to one and all. I am extremely overwhelmed to welcome you all to the valedictory session of two-day virtual international conference on chemical advances for sustainable development held on 12th and 13th of April, organized by Department of Chemistry, University College for Women, KOTI, Hyderabad. Technology is best when it brings people together. On this note, I strongly believe that all our participants had great time on this virtual platform for these 2 days. I sincerely appreciate and thank each one of you for your kind participation, making this program a grand success. To grace this occasion, today we have with us our guest of honor, Professor D. Ashok Sir, Professor, Retired Chemistry, UGC BSR Fellow, Department of Chemistry, University College of Science, Usmania University, Hyderabad, and our beloved Principal Madam, Professor Vijayalata Ma'am, and Vice Principal Madam, Dr. B. Shailaja Ma'am, to grace this occasion. I once again welcome all the dignitaries for gracing this occasion today. Now I would like to invite Dr. G. Vijayalakshmi Ma'am, in charge head, Department of Chemistry, and one of the conveners of this program to present a report on this conference. Over to you, Vijayalakshmi Ma'am.
Thank you, Vijayata. I deem it as a privilege to present the report on the 2 days virtual international conference on chemical advances for the sustainable development to the August gathering present here. Day 1, 12th April 2022, Tuesday, the inaugural session began with the welcoming of the guests by Jayanti, Assistant Professor, Department of Chemistry, followed by the significance of the conference explained by in-charge head, Department of Chemistry, Dr. G. Vijayalakshmi, suggesting that chemical sciences have the potential to provide solutions for the world's challenges in the future. Professor M. Vijayalata Madam, Principal, has addressed the participants on this occasion and has congratulated the Department of Chemistry for their excellent efforts in organizing the international conference and also for the selection of the speakers. Professor U. Umesh Kumar Sir, Head Department of Chemistry, University College for Science, Usman University, while applauding the organizing committee for conducting the international conference, has indicated that the conference is focusing on the globally relevant issues and recent developments, and more such conferences are needed. Chief guest Professor Badu Satnarayan Sir, Honorable Vice Chancellor, Karnataka Central University, Karnataka, has opined that such conferences need to be conducted to focus on key environmental issues such as wastage of chemicals, chemical pollution, industrial pollution, etc., and has to be addressed for the sustainable and safe future of the world. Keynote speaker, Professor Govardhan Mehta Sir, Professor, FRS University, Distinguished Professor, and Dr. Kallam Anjureddy Chair, has presented an inspiring and informative lecture on the topic, Chemistry, a Pivotal Science for Sustainability of People and the Planet. Sir suggested that chemistry can give solutions for the clean and green environment, solventless chemistry, etc. Sir also focused on the topics like circular chemistry, which refers to zero waste environments, zero waste chemistry, 3Rs, C2C chemical design, chemistry involvement as growth engine, 2 wake-up calls, renaissance of ammonia synthesis for sustainability, pitching for humility, etc. Then the inaugural session ended with a formal vote of thanks. The invited lecture 1 on the day 1, the speaker was Professor P.V. Ananthalakshmi Ma'am, Professor, Department of Chemistry, University College of Science, and Madam has presented lecture on the topic thermogravimetric analysis, kinetic and thermodynamic parameters. Madam explained about thermal analysis, thermogravimetric analysis, TG and DIG curves, Coates and Redfern method, different experimental methods, etc. Invited lecture 2 was by the speaker Dr. B. Biraya Sir, Associate Professor from Department of Chemistry, IIT Madras, and Sir spoke on the topic Bronsted acid catalyzed domino reactions for the rapid generations of polycyclic systems. Sir explained about the development of new synthetic methodologies using alkynes and carboxylic alcohols as building blocks. Sir also focused on the domino reactions which involves C and CX bond forming transformations under the same reaction conditions. Invited lecture 3 was by the speaker Dr. Raghu Chitta, Department of Chemistry from NIT Warangal. And sir has delivered an informative talk on boron dipyromethane based fluorescent chemosensors, which are formed by involving organic donor acceptor diodes through linkers and electron transfer reactions. Sir also explained about the investigation of sensing mechanism, fluorescent enhancement studies, and computational studies as well. Invited lecture 4 was by the speaker, Professor Ajay Kumar Mishra. Sir is professor from Department of Chemistry, School of Applied Science, KIIT deemed University, Bhubaneswar, Odisha. Sir gave the lecture on the topic nano-engineered composite materials for environmental sustainability and explained about environment safety, water pollution, which is a major concern and needs to be solved on urgent basis. Sir also focused on how to the stain resistant materials work, the electronics keep getting smaller and smarter, and also it is possible for cancer patients not to have the side effects, etc. Sir also focused on the nanoscale materials dealing with optical engineering field, defense, security, bioengineering, cosmetics, nanofabrics, medicines and drugs, and so on. Then in the afternoon, the post-lunch session was the technical session 1, which was from 2:15 to 4:30 p.m. In fact, it also took longer time than that. And the technical sessions were conducted in a parallel mode with groups A and B. Group A, for the inaugural, for the oral presentations for the group A participants, it started under the care of the session coordinators, Dr. Ravi Kiran and Mrs. J. Soumya from Department of Chemistry. The evaluator for the group A, Dr. A. Haripadmasri, Associate Professor from Department of Chemistry, UCSOU. Madam has given very useful suggestions to all the participants and interacted with them very well. In group B, the oral presentations was coordinated by our faculty, and the evaluator was Dr. M. Kavita ma'am from Department of Chemistry, UCS, Usmania University. And in this group, about 16 presenters have presented their research work in excellent and precise manner and in the stipulated given time slot. Then coming to the day 2, that is 13 today, that is 13 April, Wednesday. Invited lecture 5. We have the speaker, Dr. G. Sudhakar Reddy, sir, from Smart Solutions, USA, University of Michigan Sustainable Coordinating. And speaker, sir, has given informative talk on green chemistry leading to sustainability development in the learning and teaching methods. Sir also explained the concept of green chemistry and sustainability on the 12 green chemistry principles with real-time examples, and also discussed about the concepts like PLA cup, biodegradable bioplastics that degrade into fertilizer, ozone laundry, usage of green chemicals for textile and automotive industries. Invited lecture 6, the speaker was Dr. Addapalli Balasubramaniam, sir, from Revshire Laboratories for the Mass Spectrometry, Department of Chemistry, University of Cincinnati. Sir delivered the topic on the topic mass spectrometry based detection of the post-translational modifications in proteins. Sir explained about his research work and about the disulfide bond detection and xenobiotic detection by deamination and dehydration. Sir very well explained about the analyzers, the different types of the detectors and its applications in not only in chemistry, environmental testing, food testing, pharma and biopharma testing, etc. Then invited lecture 7, we had the speaker Dr. Radhakishan Motukuri from the Richland, Washington, US. And sir delivered the lecture on the topic engineered nanoporous materials for potential applications for energy and environment. And sir gave a very detailed explanation about PFAS research sources, then how it is harmful to the health, and explained about fluorocarbon interactions in the nanoporous materials, etc. Then invited lecture 8 was by Dr. Jayanti Subalakshmi, Associate Professor from Bitspilani, Hyderabad campus, Telangana State. And Madam has delivered the lecture on molecular materials based on organic donors, pi acceptors, and polymers. Madam explained about various aspects of molecular materials such as their uniqueness, applications, fabrication of these materials into optical, electronic, and optoelectronic devices. And Madam has explained about various forms of the polyelectrolyte templated polyaniline and also about the various aspects of these materials which were very much suitable to the theme of the conference on the sustainable development. Then there was a parallel sessions. There was another invited session in the afternoon, and the speaker was Professor T. Baswaya sir from School of Chemistry, University of Hyderabad. Sir delivered the talk on the topic Baylis-Hillman reaction, recent contribution. Sir exemplified the significance of the 2-component and 3-component Baylis-Hillman reactions and applications of Baylis-Hillman adducts. Sir explained about the philosophy of the research as how we think is more important than what is actually present. So altogether, there were 9 invited sessions that were part of this international conference. Along with that, today we had also seen 2 parallel technical sessions. So Group C, we had evaluator, Madam Professor G. Vijayacharan ma'am from Department of Chemistry, UCS Osmania University. And under Group D, we had the evaluator as Professor K. Girija Mangathayaru ma'am, Professor from Palamuru University, Telangana. And all the evaluators have given the participants encouragement through their useful suggestions and also interacted them very well. So these were the technical brief information about the technical as well as the invited sessions that we had for the 2 days as part of the international conference. And may I also share with you the information regarding the registrations. The international conference has seen very high registrations. This was possible because of the timely response given by the participants. And we have seen about 230 abstracts that we have received across the country from the states, from the 12 different states like Jammu and Kashmir, Madhya Pradesh, Maharashtra, Andhra Pradesh, Delhi, Tamil Nadu, Gujarat, UP, Karnataka, Haryana, and Telangana. And also across overseas also we have received the registrations like Dubai, Africa, United States, Oman, etc. And may I also give the information that we have received 90 oral presentations and more than 100 abstracts, and we were still receiving the abstracts till today morning. Also, we were receiving special requests and abstracts to accommodate in this conference, and also more than 25 full papers. So thank you all the participants for your timely response. Because of your contribution to this conference, I can say that this was a success. And at this point, I must acknowledge the presence, the kind presence and acceptance of the invitation by our department to all the invited speakers, as well as the evaluators, the guests who were part of this conference, and they have shared their knowledge. They have shared their research work to us, to the participants on this platform. So I'm very much thankful to each and every invited guest and the speaker who were part of this conference. And I must acknowledge the kind of support, the great support I have received from my department, the Department of Chemistry, the organizing committee of this conference, who have always been supportive and encouragement. They form the strong mechanism of support to us always whenever the department takes up any activity, any academic program. And this is what we can witness when we all come together. And this is the kind of the program that we put forward to the participants, to the people around us. So thank you, the organizing committee. As always, you have been with us. Let us continue to show this kind of the support in the future as well. So I must not forget the kind of encouragement and the support that we always get from the principal madam, Vijulata ma'am, and vice principal madam, Shailaja madam. They're always there with us and always encourage the department for the academic programs, the industrial trades, the lecture series, whatever programs we have taken up. They have always rendered their support to the department. So thank you so much, madams, for being there with us and silently, you have supported us all throughout. So thank you one and all for making this international conference of what it is. And my special thanks goes to my convener, Dr. Shashikala madam, for being with me for all these days. We were going through this more than a month. Thank you, madam, for being with me and extending your support and in all the plan Right from the title till today, we were discussing many things, and we were spending a lot of time together. So thank you, Shashikala ma'am, for your support and in all the ways. Thank you, ma'am. Thank you, one and all, for this wonderful platform you have given us. Thank you, one and all. Over to you, Vijay.
Thank you, Vijayalakshmi ma'am. Thank you for detailing us about all the things what happened in the conference these 2 days, and even we are so lucky to be part of this successful program, I can say. Now let us move on to invite our beloved principal, Professor Vijulata madam, to please address the gathering by giving her message. Over to you, Vijulata ma'am. Ma'am, you are muted.
Vijeta.
Yes, ma'am. We can hear you.
Hello.
Now. Yes, ma'am. We can hear you.
Can you hear me? Yeah. Yeah. Chief guest Professor D. Ravindra Garu, Honorable Vice Chancellor of Usmania University, guest of honor Professor P. Leelavathy, Board of Studies, Department of Chemistry, Chairman, and guest of honor Professor D. Ashok, BSR, Department of Chemistry, conveners Dr. Vijayalakshmi, in charge head, University College for Women, and Dr. Shashikala, Faculty of Chemistry, and all the organizing committee members. This conference, which is an international conference, was very successful, and I've seen many of these speakers speaking about sustainable development and what all has to be done to make this world a better place. And this program of the international conference is of apt because UGC is also insisting upon sustainable development. And this seminar has helped many of the faculty members as well as scholars and teachers to understand as to what is sustainable development and what should be done, and how the green chemistry is coming into picture when we are talking about sustainable development. What is atom economy? As Professor Gordon Mehta has told, that the byproduct should be minimal when we are doing a synthesis, and it should be a cyclic mechanism in which you are synthesizing the molecules. Not only that, many of the research scholars have sent their abstracts, and many of them have presented the abstracts, their papers in the presence of as PPTs. And I have seen many of the scholars presenting their presentations, and they have done it really well. And full papers also have been accepted by our teachers for this international conference, and they are most probably coming up with proceedings for this. So I would like to congratulate the faculty of chemistry department as well as the students of chemistry department for conducting such a wonderful program on sustainable development and how chemistry comes into role when we are talking about sustainable development, and how industries should have the importance in this kind of sustainability. Thank you very much.
Thank you, Vijulata ma'am. Thanks for your kind message. Now I invite our Vice Principal ma'am, Dr. B. Shailaja madam, to give her message. Shailaja ma'am, over to you, ma'am.
Yeah, ma'am. Am I audible?
Yes, ma'am. You're audible.
Respected Principal ma'am, dignitaries, speakers, evaluators, and the conference team, Department of Chemistry, participants, ladies and gentlemen. Good evening to one and all. First of all, I would like to congratulate the Department of Chemistry for organizing this 2 days virtual international conference on chemical advances for sustainable development. The sustainable development goals, this is the main thing which is going on everywhere. So I don't know how far it is related to chemistry, because I am the odd man out here because I am from commerce. So every time whenever chemistry department goes for a program, it is systematically done. Everything goes on very well, and it comes out with a good successful program. So I congratulate each and everyone for participating and making this conference a grand success. And I thank all the speakers, evaluators, those who have taken their time and joined online and made this program a grand success. So thank you one and all, and congratulations to each one of them who has been directly or indirectly involved in this program. Thank you for giving me this opportunity. Thank you.
Thank you, Shailaja ma'am. Thank you so much for addressing us. Now it's time for feedback. We need to collect the feedback from the participants. So I request a few participants, whoever is interested, to share their view about this conference. You can please unmute yourself and you can share your experience. So I request the participants, whoever is interested, can unmute yourself and share your experience. Yeah, I can see Bhagyashree.
Ma'am, can I talk?
Yeah, you can.
Good evening, everyone. So this is Bhagyashree. So firstly, I would like to thank the organizers of the conference, especially our principal ma'am, vice principal ma'am, Dr. G. Vijayalakshmi ma'am, Shashikala ma'am, and the whole team for giving us such a wonderful opportunity to participate in the international conference on chemical advances for sustainable development. All the sessions were so lively and so inspiring, and all the lectures delivered by the invited speakers, they were so interesting, informative, innovative. I can just say it was full of knowledge. We really learned a lot from this and we enjoyed a lot. And lastly, I would like to congratulate the whole team for successful completion of the conference. Thank you and congratulations, everyone.
Yeah.
Thank you, ma'am.
Thank you, Bhagyashree. Thank you for those kind words. I hope even other participants are feeling the same. So if anyone is interested, you can come up and you can talk. Any other participant? Session is open to all. Hello. I once again request the participants, few participants at least, to speak about your experience regarding this conference. Yeah.
Hello.
Yeah, we can hear you. Go ahead.
Yeah, this is Raj Nandini from CSR IICT Hyderabad. It was a great opportunity and a great platform where all the professors, especially, their presentations were so clear. As I'm from a biotech, structural biology with the organic chemistry background, and for me especially, the talks were so informative and so simple that I could understand everything, and I could literally understand the chemistry that they were talking about and the aspects or the realms that they were looking into, industrial aspects. They were so amazing, especially for the young like buddies like us. It was really great to listen to them and then see what is the opportunity and what are the aspects that chemistry look forward into the future. So it was really a great opportunity for us. Thanks again to all the organizers for giving me opportunity for oral presentation as well. Thank you.
Yeah, thank you, Raj Nandini. It was wonderful to hear from you. Thank you so much. Any more participants?
Yes. Good afternoon, madam. This is Dr. Yasmin from Department of
Hello.
Botany. Hello.
Yes, ma'am. We can hear you, ma'am.
Yes, thank you, ma'am. I like to thank all the organizer for the opportunity given. I feel this international conference has been on not only about the chemistry, it's interdisciplinary, has given different other departments also the chance to present their work. So this is an excellent opportunity for all the departments to come forward, as chemistry is a part of all the subjects, I feel. It's I think even the commerce people can relate to chemistry, because chemistry gives opportunities for various markets and industries. So I think this international conference has looked into the interdisciplinary aspect, which is a very forwarding, I think, forwarding move from our college. So I congratulate all the team for the brilliantly presenting this conference on the global front. Thank you, ma'am.
Thank you so much, Yasmin ma'am. Any other participants?
Hello.
Yeah, Pooja, we can hear you.
Yes. I thank all my, because I am from KOTI Women's, I thank all my teachers, professors, and lecturers for giving this opportunity, not only to the, like, within the state, but it was an international conference where we have heard the students even from the other states. The good thing about this conference I liked was that there was a time limit. So we had a challenge. After a long time, I think after lockdown and all, I have participated something which was really challenging, and I just enjoyed the challenge. And yeah, I thanks everyone for giving this opportunity.
Thank you. Thank you, Pooja. It was wonderful because you are the student of the same college and you are sharing your experience. Thank you once again. Any other participants?
Hello, ma'am.
Yeah. Yes, ma'am. You can go ahead.
Yes, good afternoon, everyone. The conference was very well organized with great teamwork. There were like eminent speakers which gave an inspirational talk. Actually, I would just like to thank the organizers, conveners, and the conference coordinators like Shrivali ma'am for Group C. So, I mean, you all have been so friendly and helpful whenever I needed any information through phone or message. So it's wonderful to see such a coordination and the friendly attitude of all the faculty members and the organizers. Thank you so much.
Thank you, Monica ma'am, for your kind words. Any other participant? Vijayalakshmi ma'am, shall we proceed?
Yeah. There are no more feedback shared by the participants, then we can move on.
Okay, ma'am. Thank you. Now it's my great pleasure to invite our guest of honor, Professor D. Ashok sir, to present his message. Before I invite sir, I would like to introduce sir to the audience. Professor D. Ashok sir has 33 years of postgraduate teaching and 38 years of research experience. His main research interests are green chemistry, medicinal chemistry, synthetic organic chemistry. Sir has published over 200 research papers and guided 36 students for their doctoral degree. Sir completed 4 UGC research projects and 1 DST project. Sir served as Registrar, Telangana University, Nizamabad, Additional Controller of Examinations, Joint Director, Directorate of Academic Audit, and so many. Sir is a Vice President of Indian Council of Chemists and Fellow of Telangana Academy of Sciences. Presently, Sir is UGC BSR Faculty Fellow in Department of Chemistry, Usmania University. With this introduction, I now invite Sir to please present his enthusiastic, energetic message to the audience as Sir usually does. Sir, over to you, sir, and very happy to have you here for gracing this occasion. Ashok, sir? We can't hear you, sir.
Thank you very much, madam. Now.
You're audible, sir.
You're audible, sir.
Huh? Okay. Thank you very much, madam, for a nice introduction. Though I may not deserve all those, thank you very much. Very good evening to you all, respected chief guest and honorable vice chancellor of Usmania University, Professor D. Ravindra Garu, guest of honor and chairperson board of studies in chemistry, Professor Leelavati Garu, dynamic principal of University College for Women, Professor Vijayalata Garu, vice principal Dr. B. Shailaja Garu, conveners of the conference, Dr. Vijayalakshmi Garu and Dr. V. Shishkala Garu, esteemed faculty members, from different universities and colleges, delegates from India and abroad, dear research scholars, my dear PG and UG students, ladies and gentlemen, warm greetings to you all. At the outset, I thank the organizers for inviting me as guest of honor for the valedictory session of virtual international conference organized by the Department of Chemistry, University College for Women, KOTI, to associate with this conference. First of all, I would like to congratulate and compliment the principal, conveners, and all the organizers for organizing an international conference on chemical advances for sustainable development, CASD 2022. Organizers have meticulously designed the conference, and the theme of the conference is latest, relevant, and very much useful to the society and also to our country. Organizers arranged lectures by inviting renowned scientists, eminent scientists as speakers from different parts of the globe. One day, a student asked me that why we have to attend the conference. Therefore, I would like to mention briefly, why should we organize conferences? Why should we attend conferences? Conference will bring together the people with common interests to discuss the issues and ideas relating to a specific topic. Conference provides opportunity to attendees to interact with the eminent personalities, to gain knowledge, to improve the skills, to find and understand new ideas, to do better research and disseminate their own research. I personally benefited a lot by attending various offline and online conferences in India and abroad. Since yesterday morning, I'm attending most of the deliberations of this international conference. And I learned many new things from this conference, deliberations of this conference. Based on conference report, I can confidently say that all the participants have very much benefited by this conference, which clearly indicates that the conference is 100% successful. The conference is a grand success. Congratulations to the organizers. Title of the conference is Chemical Transfer. Title is an excellent title. Very relevant title. Sustainable means meeting the needs of the present generation without compromising future generations. Sustainable development always encourages us to conserve and enhance our resources. Some examples of sustainable development are solar energy, wind energy, crop rotation, water efficient fixtures, etc. Green chemistry plays an important role in sustainable development. Therefore, my appeal to all the young students is adopt green chemistry for sustainable growth. For sustainable growth, industry academia interaction is also very much useful. Interaction and collaboration between academic institutions and industries is very, very important and very much required. for achievement of certain mutual goals, objectives such as sustainable development. In India, especially in Hyderabad, industry-academy collaboration is quite limited, though this has been topic of discussion on both the sides, industry and academia. A productive interface between industry and academia in the present times is a critical requirement. Industry-academia interface brings to meet industry needs and expectations, and also academic aspirants. A structured and regular interface between industry and academia is necessary while formulating curricula in colleges and universities. This will ensure that the education imparted in such institution leads to creation of expertise that would meet the specific requirements of industry. The industry-academia interface benefits not only the educational institutions, but also industries. At this juncture, I would like to give some suggestions to the young chemists. There are many societal problems which can be solved by the young chemists. One or two I would like to mention. One, tackling tobacco problem. We all know that tobacco is either smoked or smokeless, is a silent and relentless killer that is responsible for the ill health of the consumer, but also the family members due to second-hand smoke. Harmful effects of tobacco are well known. Cancer, heart stroke, respiratory problems, dental problems, vision problems, etc., arise consumption of tobacco. One important point all of you should know, worldwide, tobacco use causes more than 70 lakh deaths per year. Large number. In spite of hazardous effects, many countries cultivating tobacco, manufacturing cigarettes, biddies, tobacco products, etc. Once manufactured, people are forced to use and spoiling their health. My appeal to young students is that create awareness among the people about the harmful effects of tobacco and demand the government to ban tobacco products. Another problem I would like to discuss with you is tackling of plastic problem. Every year, 4 to 12 million metric tons of plastic end up in our oceans. And the plastic takes 500 to 1000 years to degrade. Therefore, aquatic life in oceans is very much affected. Polyethylene is one of these plastics known as PET, is used for making plastic bottles, carry bags, and other containers. Because of lightweight and sturdiness, these are very much in use. But polyethylene is hard to degrade because of its highly stable molecule. Fortunately, researchers in Japan have discovered a microbe that can break polyethylene. But for large quantities, it is not advisable and it is not economical. some of the cheap and easy replacements for plastic in our home and kitchen, I would like to mention, because first of all, we have to implement no plastic from our home. Use washable mesh produced bags to bring grocery, fruits, vegetables. Reusable food wraps, which can be reused and which are washable. Use steel containers for pantry staples. Use reusable grocery bags such as cotton bags for fruits to bring grocery, vegetables, etc. Use reusable water bottles. Use glass bottles. Steel compost bins. Reusable metal straws. Use wooden hangers. Most of the people are using the plastic hangers, but better to use wooden hangers. For storage of food, use glass containers instead of plastic containers. Use metal or glass juicers. All this we can implement. If everybody implements at every home, then we can control many plastic problems. Through conferences, seminars, we can create awareness among the people to control the use of plastic. Like this, in society, there are many problems to solve. Therefore, my appeal to all young students is identify the societal problems, find out the solution, create awareness among the people so that we can able to solve the problems easily, by which society will be very much developed. In turn, state, country will be developed. I hope all of you have very much benefited from this conference. Try to propagate the knowledge which you have gained in this conference, which will be very much useful for the development of society. Lastly, I thank the organizers for giving me an opportunity to associate with this conference, and also I thank all the participants for patient hearing. Thank you one and all. Thank you very much.
Thank you, Ashok sir. Thank you so much for addressing all of us with your motivational speech to the young researchers. Thank you once again for being with us, for gracing this occasion. Thank you. Now it's my proud privilege to share that our chief guest, today's chief guest, Professor D. Ravinder sir, Honorable Vice Chancellor, Osmania University, is along with us now. Sir, we welcome you to the conference. Actually, sir insists that his focus is majorly on research. So I think this is the right platform where we all are with sir, sharing his presence in this conference. Thank you, sir, for being with us. And we have OSD to Professor D. Ravinder sir, Professor Reddy Nayak sir, who want to address the gathering in this conference. May I invite Professor Reddy Nayak sir to please address the gathering. Sir?
Vijayta, I think they have not joined, Vijayta sir. They have not joined.
Okay. Vijayalakshmi ma'am? Yeah, madam is finding out. Just a minute.
Sir is joining Vijeta. It will take a couple of minutes.
Okay, we will wait, ma'am.
Yeah. In the meantime, if any participant can share their views. Even the organizing committee members are also invited to share their experiences.
Yeah, any participant, if you are interested, you can share your experience. Session is open. Yeah, Jahanvi, would you like to share your experience? Jahanvi Iyer?
Actually, OSD sir is traveling along with our VC sir. And they are taking some time to connect to us. So they'll be connecting in a couple of.
Okay, ma'am.
Any of the organizing committee can share their thoughts and their experiences.
Well, sorry for the inconvenience, dear participants. We are waiting for our OSD sir to join us.
Hello, am I audible to you?
Yes, sir, you're audible, sir. Sir,
Okay.
welcome, sir. Welcome to the conference, sir.
Thank you, madam. Somehow, of course, I don't know how much my message conveys to the participants because I'm in journey now.
Yes, sir.
So, anyways, yeah.
I'm very happy, sir, that you have joined with us in this conference. On behalf of
Proceedings go on.
Department of Chemistry, University College for Women, a warm welcome
Whenever
to you,
you
sir.
think that my intervention is required, I will join there.
Yes, sir. Yes, Vijeta.
Yes, yes, ma'am. It was not clear, ma'am. Sir, want to address?
Yes.
Okay. I welcome Professor B. Reddy Nayak, sir, to please address the gathering in this conference. Sir,
Madam, sorry, the signal strength is poor here. It is not catching up regularly. There is a frequent interruption of the network. So, because we are almost in a remote area now, journeying on road, I don't know how much voice is conveying there. But anyways, this is the time that I just have to pass on the message to the participants across the country and different parts of the world also, I'm told. So at this point of time, I would just wish that this 2 days deliberations through webinar must have enlightened all the participants by taking the clues from the resource persons from different parts of the world. And yes, definitely this kind of interactions, conglomerations of the scientists from different parts of the world will definitely enlighten and in sharing the knowledge. And yes, this is a time that we need to think of sustainable development. And this sustainable development is also a mandate of the UNO development of what you call sustainable development goals. So in this environment is also plays very important role, and one has to have a consciousness about the protection of environment by using different particularly today it is high time that we need to think of each and every survival, and most of the naive organisms are also being damaged and distracted because of the application of these pesticides. So it is high time that the Indian knowledge system, which is advocating all these days that to go with the organic farming. So the organic farming will be definitely, but we also need to learn. For example, experimented with this organic farming, and now it is dwindling with their emergencies kind of things. So instead of going at a time, we should have to have in a phased manner to adapt that. Yes, definitely a good initiative to go with this replacing the pesticides and organic farming. So taking these kinds of experiences across the world, we need to be cautious in designing our policies and promulgating about the prospects of the science. I'm not sure whether my voice is conveying to or not, because I could not listen any feedback from you, or nor I can have any this kind of things. At this point of time, I just cut short my message by just greeting you all very best, and I think that the take-home message to all the participants must have been thoroughly be delivered. And on behalf of the Department of Chemistry and on behalf of the Osmania University, I compliment and in this webinar, and I also wish all the very good luck to all these participants. Thank you very much.
Thank you. Thank you, sir. Thank you so much, sir. Out of your busy schedule, it was nice to hear from your end, sir. Thank you so much. Madam, let's move on to the next session.
I'm leaving now. Yeah, thank you.
Thank you.
May I leave now?
Thank you very much, sir.
Thank you. Thank you. Thank you.
Shall we proceed, ma'am?
Yes. Yes, Vijeta.
Yes. Winning is important for confidence and losing is necessary for learning. With this spirit, I would like to convey to all the participants who has given their best in exploring their work that they have done their best and that participation is more than winning. So this is a session where results are going to be declared for which everyone is eagerly waiting, those who have given their oral presentations in this conference. So I hand over the session to our conveners of this program, Dr. Vijayalakshmi ma'am and Dr. Shashikala ma'am, to take over the session and declare the results. Over to you, ma'am.
Thank you, Vijeta. Well, as we come to the end of the 2 days virtual international conference on chemical Advances for Sustainable Development. We come to the most interesting part of the conference, and we had the technical sessions which were held on 2 days, on 12th and 13th, in 4 different groups. And because of the huge response that we have got, so we had to go for the parallel mode of conducting the technical sessions. And out of about 90 presentations we have received through registrations for the conference, we had screened and we have selected about 68 oral presentations, out of which a few did not respond to the slot, to the allotted slot that were given to them. But overall, we had around 52 oral presentations from the participants across the country, and it was very nice to listen to them. They have shared their research work on this platform with all the fellow researchers as well as with the faculty in and around the places, various places. And I'm so happy that there's a lot of research work that is going on pertaining to the theme of this conference, and very interesting details have been shared on this platform by the various researchers as well as the academicians. So it's very wonderful and interesting to listen to them. And also it was a very good opportunity even for the organizers, for the organizing committee also, to come across the details that are being shared through the research from various participants. Well, as we have already mentioned in our brochure, so the best presenters will be given the cash prizes. So that's what we have announced for. So now this is the time for us to announce the results. So I hope that all the participants are eagerly waiting for this moment where we have to announce the winners. But before I could announce that, I just want to say that it's nothing to do with the winning, or it's not the matter that one is good, one is not so good enough, nothing like that. Every research work is equally important, because I feel that research is research, and we are doing something in that direction to proceed further. So it doesn't matter whether we are winning, whether we are getting the prize or something like that. So every research scholar have been putting in their best. They're doing a lot of hard work. They're trying to give their best to the research, and it shows their interest. It shows the kind of interest what they are having in the research field. So I request all the participants to continue the good research work, what you are doing in your respective labs. Please do explore. There are so many new avenues which are available to us to understand, to explore, and to do research. And of course, also sometimes we need to do research also. So now I'll take this opportunity to announce the prize winners. So before that, I would like to take the permission from our principal and vice principal madams. Ma'am, with your madams, with your permission, can I announce the winners?
Yes, ma'am, you can proceed.
Thank you, ma'am. So we have selected 4 winners out of all the total number of the presentations what we have. And the first winner, we don't say it's the first or second prize like that. All are same, equal, okay? Because we are only talking about the research work. So the first winner is Mr. A. Ramesh and Group from University College for Women, KOTI, Hyderabad. A big congratulations to you. Mr. Ramesh, are you there? Okay. All right. Then next we have Mr. K. M. Garadkar and Group from Shivaji University, Maharashtra. Is there anyone from this group? Well, hearty congratulations to the winners. Over to you, Sashikala ma'am. I request Sashikala ma'am to announce the rest of the winners.
Thank you, madam. Yeah, it is very tough job for the evaluators, because all the research works are very, very nice and very well presented. But we need to follow few of the guidelines, when we keep as a competition. So it's no matter whether it is winning or losing. Yeah, because there are 4 parallel sessions were conducted yesterday and today. So from these four winners have been selected, as ma'am said. The first 2 winners ma'am explained, gave the results. And the next 2 winners are Miss Rajnandini Kashyap and group from CSR IICT Hyderabad. Congratulations to you, Rajnandini and group.
Thank you so much. Thank you, ma'am.
Yeah, congratulations, ma'am.
Thank you.
Yeah. And the next winner is Miss Pooja Bajaj and group from CSR IICT Hyderabad. Congratulations,
ma'am. Thank you.
Yeah. Now I request you to kindly share a few words. I think you two just now you have shared your experiences and your points, I think, right? Yeah.
Yes, ma'am.
Yeah, give your just 1 or 2 points, your expression to us.
Yes, sure, ma'am. My happiness is not just that I have won it, but also that it's my own teachers and professors who are there to reveal my name as a winner. That is a more happy point for me. So I thank you so much for giving me this opportunity.
Yeah, we are so feeling very proud about you, ma'am. Congratulations again.
Thank you, ma'am.
Next, Rajnandini.
Hello, organizers. I'm really happy to receive this award, and I feel really glad that I am a part of this conference. The kind of presentations, especially since Professor D. Ashok is here, I really enjoyed your presentation. Actually, the kind of like basics you have explained. For me, as a structural biologist, I'm just venturing into organic chemistry, and I really loved it. I mean, I enjoyed it, and now I'm going to follow up for my postdoc.
Thank you very much.
So it will really help. And along with that, I also in the morning, Dr. G. Sudhakar, and there are others also. All the dignitary speakers, they have shared their the wisdom and the knowledge, I would say, rather than the presentation, because really, I mean, being in the field for so many years, experience and knowledge, they are very different in the field of research. So listening from such experienced researchers, it's very, I mean, it's a very different experience. So altogether, I really enjoyed this conference, and I look forward for future conferences if there will be any. Thank you so much, organizers.
Thank you, Ma. Definitely we'll meet physically in future. Thank you.
So big congratulations to all the winners, and keep continuing to do the good research and also be an inspiration to the other fellow researchers as well.
Congratulations.
Over to you, Vijay.
Yeah, congratulations to all the prize winners and even also to all the participants who have given their oral presentations. As we come to an end of this valedictory session, now I request Dr. V. Shashikala ma'am, Assistant Professor, Department of Chemistry, University College for Women, KOTI, to please propose vote of thanks to this valedictory session. Over to you, Shashikala ma'am.
Thank you, Vijeta. Yeah, this is my formal vote of thanks I have to give, because already the vote of thanks ma'am gave, or Vijayalakshmi madam proposed. Yeah. Chief guest of this valedictory session, Professor D. Ravindra sir, Honorable Vice Chancellor, Osmania University, and guest of honors, Professor D. Ashok sir, BSR Fellow, Department of Chemistry, University College for Women, University College of Science, Osmania University, and guest of honor, Professor Lilavati, Chairperson, Board of Studies, Department of Chemistry, University College of Science, Osmania University, and Professor Redya Nayak sir, OSD to VC Sir, Osmania University, and dear Principal Madam and Vice Principal Madam, and all other dignitaries, delegates, and all other participants of this 2-day virtual international conference on the chemical advances for sustainable development. Good evening, you all. Now the time has come to say Alvida. Before that, as one of the convener of this 2-day international conference, on behalf of the Department of Chemistry, University College of Women, it is my prime duty to express my heartfelt gratitude and sincere thanks to the chief guest of the inaugural session, Professor Bhattu Satyanarayana Sir, Honorable Vice Chancellor of Karnataka, of Karnataka Central University, Karnataka. Guest of honor, Professor U. Umesh Kumar Sir, Head Department of Chemistry, University College of Science, Osmania University, for accepting our invitation and gracing the conference with their presence and valuable messages. And the aim and the theme of this conference, that is chemical advances for sustainable development, is aptly opened by the keynote lecture of Professor Govardhan Mehta Garu, FRS University Distinguished Professor, and Dr. Kallam Anjireddy, Chair. Sir, your lecture visualized us the research community of chemistry about the importance of focus on the research for sustainable development. Thank you very much, sir, for a wonderful lecture. And chief guest of today's valedictory session, I express my sincere gratitude and thanks to the chief guest of the valedictory session, Professor B. Ravinder Sir, Honorable Vice Chancellor, Osmania University, Hyderabad, and Sir, for accepting our invitation, even from his very busy schedule, and grace the occasion. And I thank you, sir, Professor Redya Nayak Garu, for your presence and gracing the occasion with your presence and the message to us. Thank you, sir. The guest of honor of today's valedictory session, Professor D. Ashok Sir, BSR Fellow, Department of Chemistry, University College of Science, Hyderabad. So on behalf of Department of Chemistry, Osmania University, on behalf of University College for Women and myself, my heartfelt thanks to you, sir. Giving your valuable message to us. Thank you, sir. Next, I thank the invited eminent speakers of the 2-day virtual international conference, the eminent speakers of the day 1. The first speaker of this program, Professor P.V. Anantalakshmi Madam, Professor, Department of Chemistry, University College of Science, Osmania University, and Dr. B. Biraya Sir, Associate Professor, Department of Chemistry, IIT Madras, Chennai, and Dr. Raghu Chitta, Department of Chemistry, NIT Warangal, Telangana, and Professor Ajay Kumar Mishra, Professor, Department of Chemistry, School of Applied Science, Kalinga Institute of Industrial Technology, DMD University, Bhubaneswar, and eminent speakers of the day 2. The speaker 1 is Dr. G. Sudhakar Reddy Garu, Smart Solutions, USA, and is the Sustainable Coordinator of University of Michigan, USA, and Dr. Addepalli Balasubramaniam Garu, Revistal Laboratories for Mass Spectroscopy, Department of Chemistry, University of Cincinnati, and Dr. Radha Kishan Muthukuri, Senior Chemical Engineer, Material Scientist from Pacific Northwest National Laboratories, Richland, Washington, United States of America, and Dr. Jayanti Subrahmanyam, Associate Professor, BITS, Hyderabad Campus, Telangana, and the fifth speaker of Today's post-lunch speaker, Dr. Basavaya Garu, Professor D. Basavaya Garu, School of Chemistry, University of Hyderabad, Telangana. So, dear eminent speakers, my sincere gratitude and thanks to you for accepting our invitation for this 2-day virtual international conference. On behalf of Department of Chemistry, University College for Women, KOTI, I express my sincere thanks and heartful gratitude for sharing your art of research work in chemical advances and enlightening us on the importance of research focus towards the sustainable development. And for this conference, as already given that information about the responses, we received an immense response from various national and international participants. And yeah, as it is total 68 oral presentations are there. So evaluation of these 68 oral presentations is a very tough task, very difficult task. And our 4 evaluators are Dr. A. Haripadmashri, Associate Professor, Department of Chemistry, University College of Science, Osmania University; Dr. M. Kavita, Assistant Professor, Department of Chemistry, University College of Science, Osmania University; and Professor G. Vijayacharan, Professor, Department of Chemistry, University College of Science, Osmania University; and Professor K. Girija Mangatayaru, Professor, Department of Chemistry, Palamuru University. Dear ma'ams, I express my sincere thanks to you all for accepting to handle a tough job of evaluation. Thank you, ma'ams. Now, on behalf of Department of Chemistry, I express my sincere gratitude and thanks to our beloved, dynamic, energetic, and inspiring principal, Professor M. Vijulata, for her constant support and encouragement in executing planning of this 2-day virtual international conference. Thanks a lot, ma'am. Thank you very much. And next, our sincere thanks to young and dynamic Vice Principal, Madam Dr. B. Shailaja, Madam, for her constant support to us in all respects. Thank you, Madam. I thank our Controller of Examinations, all the coordinators, PRO, head of the departments for their timely suggestions and responses for making this conference a big success. I thank all the faculty of various universities of India and all over the world, the research scholars for attending and sharing their research thoughts with us. Thank you all. Now, I thank my team, that is the organizing team, each and everyone for their continuous, untiring efforts in making the big success of this 2-day virtual international conference, the Chemical Advances for Sustainable Development. Thank you all, my dear team members. Last, but the main person, without his support, the conduction of this virtual conference would have been impossible. I thank Mr. Hari Babu for his technical support. My sincere thanks to one and all who involved directly and indirectly for the success of this 2-day virtual international conference. Thank you all, one and all. And we request the same kind of response from you all for the forthcoming programs are going to conduct by our department. Yeah, we will meet you physically or virtually in future again. Thank you, one and all. Thank you very much.
Thank you, Shashikala ma'am. Thank you so much. And I would like to thank Vijayalakshmi ma'am and Shashikala madam for giving me this opportunity. Thank you, one and all. Over to you, ma'am.
Thank you, Vijayalakshmi. As we come to the end of the 2 days virtual international conference on chemical advances for sustainable development, I'll take this opportunity once again to thank each and every member directly and or indirectly, they have been a part of this conference. They have been contributing so much for the great success of this conference. Thank you, Ashok sir, for your valuable presence here. It's very heartwarming to always have you in all the endeavors that we take up, sir. You're always ready to help us in all possible ways. Thank you so much, Ashok sir, for being here with us in this valedictory session. I also thank all the speakers.
Madam, hearty congratulations.
Yes, sir. Thank you, sir. Thank you so much, sir. This is all possible because of the support from each and every member who is associated with this conference. Maybe they are from UCW or from the outside. Every member have contributed for the success of this conference, sir. So a big thank you to all of them, sir. Thank you, Vijilata ma'am. Thank you, Shailaja ma'am, for your great support behind the success of this conference. So with your permission, shall we end the session, ma'am?
Yes, ma'am.
Thank you, ma'am. Thank you so much. So thank you one and all once again. So we'll meet on yet another platform with another great team, and let us have even more deliberations as well as the discussions on the platform, on that particular platform. Thank you one and all. Thank you so much.
Congratulations to Professor Vijilata, Dr. Vijayalakshmi, Dr. Shilkala, and all the organizers. And you organized excellently, and you have role model for many. All the very best. Thank you.
Thank you, sir. Thank you so much, sir. So it's bye from the organizing committee of UCW, Department of Chemistry, to all the participants.